Distinguished guests, ladies and gentlemen, good morning. A very warm welcome to Layer 1 plus Layer 2 Forum of Hong Kong Web3 Festival 2024, co-hosted by Wangxiang Blockchain Labs and Hashkey Group, and organized by W3Me. Please allow me to introduce myself. My name is Jasmine. It's my very great honor to be the MC for today's event, and I'm very excited to spend this meaningful morning with all of you here today. Welcome, everyone. Thank you for having me here today. First of all, please allow me to extend our sincere gratitude towards our title sponsors of Hong Kong Web3 Festival 2024. They are DWF Labs, Internet Computer, Meet48, OKX Web3, Torn, and ZA Bank. Also, a big thank you to Cyberport, Invest HK, and HKTDC for supporting this event as strategic partners. Thank you so much for their great support. Now, ladies and gentlemen, without further ado, let's give the floor to distinguished speakers today. They are important leaders, investors, and observers of the Layer 1 track of the Web3 industry. First of all, let's welcome Mr. Avery Chang, co-founder and CTO at Aptos Labs, to share the future of Move and Aptos. So without further ado, please join me in giving a round of applause for Mr. Avery Chang.
Good morning. I'm pleased to be the first speaker today talking about the future of Move and Aptos. Just a quick show of hands. Which of you have heard of Move? Good to see that Move is making its way through Asia. We're really excited about what we've done as an industry and as what we've done as a company to bring Move forward into the future. Just a little bit of a history. I was at Meta for 10 years before this. A long portion of that time was spent building data infrastructure for scalable systems, and the last 3 years I spent working on DM, which you may have heard of as well. And as a part of the DM project, we really tried to take an interesting approach about how do we scale this blockchain infrastructure to not just tens of millions of people, but to billions of people that were using the Meta platforms. So I'm going to walk through that now. Let's see, this clicker, Going back to the mission, it's really about how do you build a worldwide public utility for everyone. Everyone can participate in it. It's permissionless. It's owned by everyone who uses it. And it's something that operates very similarly to the cloud. It scales infinitely with your use case. It supports security for all the customers. And you can build any kind of applications that are composable across different industries, whether it's going to be DeFi, it's traditional media entertainment, as well as gaming, and everything else that comes up in the future. Going to our technology stack, we really want to take fundamentally a look at what we could do to change the way infrastructure was built. We were excited by technologies like Bitcoin and Ethereum, but we felt that stack would not support the needs of billions of people going forward in the future. And so we focused on a couple of key concepts. The first being parallelism. How do we execute as many transactions in parallel as possible in the stack? Pipelining. Taking a look at modern CPU design, superscalar infrastructure. We see the way that staging out these different portions of the execution, whether it's kind of the early parts of dissemination or execution and consensus are split in different pieces, as well as how do you kind of bring the sub-second latency that's required for internet applications today that we see in everyday products like Amazon, YouTube, Netflix, and others. And thinking about then how do you take that design and put it into an infrastructure that is permissionless and decentralized. And we came with this interesting design, which was about breaking the architecture of transaction execution into 5 different stages. The first stage is parallel transaction dissemination. Any validator can receive transactions. Every validator then blocks those transactions and sends those to other validators to get what's called a proof of availability. This means there's no single point of failure and no issues when it comes to things like you've seen today, where a single leader might get bombarded by a set of transactions where there's meme coins, other types of workload that we see in modern systems. The next step is that we have something called block metadata ordering. We have the fastest consensus protocol built in Aptos BFT, and we've been developing something called Shoal, which is a next generation consensus protocol that combines high throughput and all the advantages of leader-based selection and reputation in practical PFT protocols. The next step is that we execute with parallel execution going forward. every single infrastructure today has been mostly sequential execution, except for like a couple, Solana, Say, and Aptos, and a couple others. What's different about Aptos, though, is the way we do parallel execution. We use dynamic concurrency techniques. If you're familiar with databases, there's something called optimistic concurrency, where you try to execute as many transactions as you can in different kinds of execution pipelines, and then resolve conflicts only at runtime. This kind of runtime parallelism is actually the most concurrent possible. And then you may have heard of static execution as well. That's a different kind of parallelism. That one is where developers need to declare those dependencies up front, and it's a little bit harder to make composable applications going forward with that. Not only that, certain applications, like when you think about how do you build a central limit order book, are impossible to parallelize compared to what we can do in Aptos. The fourth phase of execution is around parallel batch storage, making sure that you take advantage of SSDs to write in larger operations with fewer IOs and seeks. And finally, state-proof certification, where you have these authenticated data structures which are generated periodically for light clients. Anyone from a mobile device or from a phone can verify the state of those transactions as well as the history of the transactions as well. And what's really cool is that all these stages, while they are a pipeline, work completely in parallel. So we're always producing blocks that are being sent to ordering. We're always executing those transactions in parallel, and we're always continuing to generate those proofs as well. And this allows us to be able to take any kind of number of resources that are available to the machine, whether it's more CPUs, more memory, more networking, or even over time, sharding that execution across multiple machines, take advantage of more and more throughput going forward. And what we've seen is that this can produce amazing, incredible results. One thing we do periodically is we produce something called PreviewNet, where a bunch of nodes, node operators, and the Aptos teams get together and run experiments over the next generation of the software. We do this because there's a lot of hype out there, there's a lot of numbers out there, but what we want to do is produce benchmarks that are both verifiable and reproducible for anyone in the infrastructure to build out with. If you're familiar with databases, you may be familiar with something called TPC benchmarks. Our industry desperately, desperately needs benchmarks like this to understand how do different workloads perform in different systems. We've taken the first step to actually produce those benchmarks. If you go to the Aptos Foundation website, you'll actually see a long history of those benchmarks being run, as well as how you can execute those for yourself on your own infrastructure. And what we've seen is that if you take that exact mainnet setup that we have in Aptos, replicate it and mirror it, we can see over 30,000 transactions per second at peak. And the way we do this is we have that sharded storage coming into RocksDB instances. We have several improvements to the way that we increase our block space, as well as optimizations to the network stack as well. Now, having that run for 30 minutes or so is great. But a long question is also, like, what can you do with sustained demand for block space in the infrastructure? And so we also ran those experiments for a longer period of time, for 24 hours. We saw that we could do more than 2 billion transactions in a 24-hour period. And just for comparison, VisaNet does about 150 million transactions in a day. And so this means that Aptos can actually support more than 13 times what VisaNet can do in its current setup and current hardware requirements. Obviously, this is just a stepping stone, and we can do much, much more in the future. But we're really happy where we are today to show that blockchain can actually do much better than traditional systems. The last benchmark I want to talk about is also very interesting. When you generate and mint NFTs, everyone thinks it's a sequential operation. You have NFT 0, NFT 1, NFT 2, NFT 3, go on and so forth. And traditionally, this has been very, very slow. What we've been able to explore in Aptos is a technology called aggregators. Aggregators are a way for certain types of operations, which are both commutative and associative, to perform most of the operation up front in parallel, and then only at the last part, kind of assign those indexes at the end. This allows us to effectively parallelize what is sequential going forward. And that allowed us to get more than a million NFTs indexed in less than 90 seconds. The great thing about building super scalable technology is that it allows us to work with the largest enterprises in the world. So just to highlight a couple partnerships, we've been working with Microsoft on AI initiatives, Web3, as well as financial services infrastructure. Some of the products we built include Aptos Assistant. We've also been dumbing something called Find Out together. And we're starting to explore what the future of finance could be with respect to AI as well. We've partnered with companies like NBC Universal on projects like Renfield, as well as The Exorcist, to think about different ways of fan engagement that scales to millions of people that watch those contents. We're also working very closely with a lot of numbers of partners in Asia as well. SK Telecom has built an Aptos wallet. for mass adoption, and Lotte is exploring how retail applications as well as NFTs can really interest the community of shoppers and users in that platform. And for those of you who have been starting to play with Move, and we see the audience being very engaged here, Move is really growing rapidly. Aptos is already the #1 Move community in the ecosystem, and we see that the developer numbers speak for themselves. Also, by non-EVM daily active addresses, Aptos is right up there, and #1 essentially for the Move ecosystem. And so it's growing really quickly, and we expect that as people start to understand the transitional effects of Move, how it makes your application safer from the beginning, how you're able to develop faster and get from ideation to production, these numbers will only increase over time. It's not just about Move, though. It's really about the idea of how do you have control over a full stack. Many of you are familiar with the modular thesis and the integrated thesis. What we're here to talk about is that it's less about a thesis in this space, but rather how can you build a software stack that supports the use case best for what you're trying to accomplish. In our case, we have several goals. We want to make sure you have security-first smart contracts. This is where taking advantage of Move, the Move prover, and being able to formally verify security properties of the Aptos framework are really a differentiator in this space. Imagine that you can actually formally verify your DeFi apps as well. Having this composition of formal layers of security and then making sure that you can leverage the composability of security across those layers is something that's going to change the way we think about the DeFi infrastructure going forward. And not only supporting DeFi, but also open financial stacks where traditional players come in through real-world assets and other tools going forward. The other thing great about having full control over the stack is that you get parallelism at every level of the stack. Things like aggregators, which I just talked about earlier, are impossible unless you kind of have the ability to change the way the VM works, change the way the consensus protocol works, as well as the execution stack and the pipeline framework. Being able to push different pieces to different parts of the stack gives us the full control to build freely. The way we also kind of like to describe this is if you want to make a Ferrari, it's really hard to take car parts from Toyota, from Lexus, and from Mercedes and build that super optimized vehicle. Being able to select everything from the way you think about the design to the way the bumpers are put on, to the tires, to the way the weight balancing happens is really, really important to build a super streamlined vehicle for your use case. The other thing is that we have account abstraction natively built in because of the way that Move and Aptos work together. This means you support multi-sigs, sponsor transactions, as well as crypto agility. And probably the most important aspect of this is that we have a super fast development cycle. Being able to develop for a single stack, testing everything fully, and being able to look at the use cases of not having to think about, like, I'm combining this stack and this stack together over this bridge, and what happens in these use cases allows us to iterate much, much quicker as a team and produce these innovations that come to market much faster. Today I'm going to walk through a couple of the next-gen developer experience things we're building across core infrastructure, developer platform, and blockchain infrastructure. The first thing is, if you want to onboard more than 5 billion internet users today with the best UX on any device, we want to make sure that the inner experiences that we have are available for blockchain. So the first thing we've been working on is something called Aptos Keyless. Aptos Keyless provides a way to have a non-custodial social login using a zero-knowledge proof to tie to your blockchain-based account. So any OpenID platform, whether it's Google, Facebook, or others, you can log in with just 2 clicks into your application. And this allows you to create apps on mobile devices, on desktop applications, in games, anywhere you'd like, and have it really, really easy to log in, as well as authorize those transactions. The second thing is passkeys. Many of you today use your phones. I see a couple of you on them today, right now. And you can log in with them with your Face ID. You can log with them with your Touch ID. And being able to log in with your app, to your blockchain-based account, as well as sign those transactions directly because you have the web authenticator built directly into the Aptos blockchain, is a game changer when it comes to that user experience. The third thing we've been working on is a web wallet. So right now, a lot of you use Chrome extensions. You use mobile apps as well to log into your account. It's great to be able to just go to a web page, use your social login with Keyless, and be able to transact immediately without having to go through the trouble and the pain of getting started with the downloads. We've also thought a lot about how do we onboard new Move developers. We have a new developer portal coming on. We have a token platform we're designing, as well as NFT tooling. But maybe the part I want to focus on the best here is high-performance indexing. Indexing is something that a lot of people don't talk about, but is really important for dApps being built today. As you think about building a dApp, Your first thought is who's going to host the full node infrastructure? Who's going to host the indexing services for you? How will I support this very, very high throughput for my new application as it grows over time? And something that Aptos is continuing to produce is indexing infrastructure where people can plug in their own custom indexers into it. And this allows both infrastructure providers as well as users to customly use that for you. Being a high throughput blockchain requires very high performance indexing as well. And we're building out a very scalable solution to support those high indexing needs. On the developer platform side, we've been working on a lot of educational resources for how do you pick up Move. We have Aptos Learn, where you can take a look at Aptogachis, which is a fun play on Tamagotchis for those of you who are old enough as me to remember that. You can build and create your own content and have an end-to-end dApp, not just Move contracts, but front-end as well, to explore the Move ecosystem. We're also building out over to other tutorials as well that incorporate features such as randomness going forward. You should check out our new developer website. It also includes many different ways to think about Move development coming from other ecosystems. We have a guide for those familiar with Rust or familiar with the EVM stack to mapping those concepts into Move and how does it make sense in the Aptos space. There's also a ton of framework upgrades. So framework is kind of like the standard library of Aptos. We have new account caption features coming where you can do custom authentication fees. And there's also a full developer tool suite being built out. So those of you who love to build with Python, C++, and every other general purpose language are very familiar with taking advantage of VS Code, IntelliJ, and others. And you're able to do the same things within Move. We have analyzers, formatters, linters, all with IDE plugins to give you a great developer experience. We also go a level deeper into Move. We've been extending the Move language itself with many different features, including enums, public structs. We've also been exploring something called resource access control, where you can enable parallelism hints at the execution engine. This means that you don't need to do it as a programmer, but will automatically infer the information you're accessing and use that information to actually optimize for your transactions, reducing fees as well as increasing concurrency at a very low level. Move itself is a language that is young. It was kind of developed starting in 2018 and not really tried and tested until Aptos was deployed until 2022. We are actually pushing the boundaries here with the next-gen Move compiler, which makes it much easier for us to take advantage of things like the Move prover, as well as extend new features well into the future quickly. The second thing we're doing is also building out the Move VM. Our next generation of the Move VM is going to take advantage of many different techniques such as caching, parallelized runtime loading of modules, and also have new features available such as debugging. And this Move VM is something that's going to really change the game in terms of performance as well as usability. On the blockchain infrastructure side, we're proud to announce that we developed the first secure on-chain randomness primitives that are available for any application and any use case for every block. And this use case the use case for secure on-chain randomness might be the best use case of blockchain we've seen so far yet. Finding a true source of entropy is very, very hard. And being able to build a very fair and robust online casino or a very fair lottery system is something that can only be done in Aptos today. Leveraging the same kind of primitives you're used to, generating random numbers from a range or from an integer, you can imagine very, very exciting applications of space. We've had more than 75 different teams participating in the random hack. And we'll be announcing soon a lot of their applications they've been creating, but they're a lot of fun, and they can only be done on Aptos. On the blockchain infrastructure level, we've been working on the keyless accounts. That's the accounts in the back end that then tie using zero knowledge proof to your OpenID login. We've also been working on aggregators, but I want to talk about storage sharding. So being able to support those multiple storage instances for Validator to increase throughput, we are the first network to do this in production. This allows us to scale out the IOPS and the storage space to solve the state bloat problem. We're never done with consensus. We've actually iterated 4 times on our consensus protocol so far. Shoal Plus is going to be our 5th iteration. It is the first high throughput DAG paired with the benefits of leader reputation and pipeline consensus to go live. We've been testing this in our latest preview net. You can take a look at the archive, the paper that just published at FC this year. It's truly a game changer when it comes to performance. When it comes to testing, we do take this very, very seriously. A lot of our work has been to develop these benchmarks and to develop these standards which we can use to evaluate blockchains across every type of application and every type of use case. And in doing this, we have a preview net we've been running, preview net infrastructure we've been running kind of continuously. We have mainnet. We've been developing a benchmark suite, which takes into account peer-to-peer type transactions, cryptography operations, sponsor transactions, and we'll be including DeFi transactions as well going forward in the future. We hope this kind of standard and templating for benchmarks will be used across other blockchains so we can start to compare their characteristics and their performance. And just to sum it up, there's a lot going on in Aptos in 2024. We're really, really excited about the fact that we can iterate very quickly in our space. Upgradability is a core functionality of the Aptos blockchain framework, and we've done this through 40 plus AIPs in the last year and a half. You should expect a lot of changes going forward for not only Aptos, but for our industry, and we want to be at the forefront of it. So just in summary, moving Aptos is changing the way we think about next generation infrastructure for Web3. We'll start to see more and more of those use cases coming into our area as we enable what the infrastructure can support. Internet user experience is going to improve greatly. With technologies like keyless, passkeys, and others that enable our current internet experiences, we'll see those on blockchain in Aptos, and we'll see those start to change the way we think about application building in the future. Aptos itself has demonstrated unmatched scalability and performance through our verifiable benchmarks in things like PreviewNet. We hope to keep pushing the envelope here, whether it's going to be 100,000 or a million TPS in the future. We're working really, really hard to onboard folks with Move. Move is a game changer when it comes to safety and developer time to market. And rapid innovation is our core thesis. We want to continue to move the needle here because infrastructure is not yet ready, but it will be ready for the 5 billion internet users in the very near term. And we think ultimately this will lead us to mass adoption. And with this, this concludes my talk. Thank you very much.
Thank you. Thank you, Avery. A big round of applause for Avery. Fantastic presentation. Thank you. Please be seated. Thank you so much for the insightful sharing on Move and Aptos. So now, ladies and gentlemen, up next, let's give the floor to Dato Fazli Shah, co-founder at Cetrix. He will enlighten us on the topic, real-world applications for the first billion Web3 users. So without further ado, please join me in giving a round of applause for Dato.
Hi, good morning, everyone. Thank you to the organizers of Web3 Festival. We're glad and we're super excited to be back here in Hong Kong. Today, I'm going to share with you a little bit about where we see the industry as it is today and the opportunities that we see moving forward. And especially here in Hong Kong, we're super excited because I'm sure, as many of you are aware, the progress recently with the areas of regulation and how our markets are opening up globally, but we also see that Hong Kong is going to be a lead market here. So I think right at the tail end of our presentation, you'll see, as we announce some of the major partnerships that we've launched recently and our teams here to kind of engage with the community while we're here. So let me introduce Zetrix. And Zetrix is our layer 1 project. And the way that we looked at it was, as an industry, blockchain over the last decade or so, as nascent and burgeoning as it is, has still remained quite concentrated into a very select and arguably small population in the relative sense of the global population of very tech-forward and tech-savvy users. So we asked ourselves, what would it take to make Web3 technologies more pervasive, more ubiquitous, so that it becomes like how you think of databases today. Nobody thinks about whether the app on your iPhone runs on a MySQL or a Postgres database. The app just has to work. So I think over the last decade or so, a lot of us have started adopting different parts of blockchain. Now, obviously, cryptocurrency being at the forefront in terms of leading the adoption. But we identified that to make this possible, to make it accessible for the average Joe, you need two other key stakeholders to be able to add value and play a part, namely governments and enterprises. And looking at how they've been progressing over the recent few years, we believe that it's the right time to go into the next wave of technologies. So today, I think we're very privileged to be living in the present reality where we have been connected via the internet. And the internet has connected really our countries, our enterprises, and our communities together. But it is still a network of centralized systems. So we ask ourselves, as you and I walk through the streets today, we have access to multiple systems, but they still sit modular and separate from each other, connected by just this one internet. And even with cloud computing, they are more connected, but still not interoperable. So we asked ourselves, how can we make this more accessible and seamless? And we've proven this recently with the launch of our first product, where we work together with China's national blockchain, Xinghuo, and our key partners in China, Beito, who have access to the traffic police department data. And we try to build out a use case that a layperson can just do, and most importantly, not have to reinvent or relearn new technical skills to be able to leverage the technologies of Web3. So right now, if you're a Chinese national, we do not need you to learn a new language or a new app. Simply use I believe still the most popular app in China, WeChat. And they simply log in as how they do today and interact with the mini app that then verifies the driver's license that they upload, and that gets verified by our what we call trust anchors, in this case, Beito and the police department, to essentially issue on-chain a verifiable credential. And for us, this is a key innovation because in the present way that the centralized systems interact, you still need two centralized systems to talk to each other for data to be verified. By doing this and committing this on-chain, what essentially can happen for this gentleman or lady that's using the verifiable credential is that they can travel out of China, and for example, when they rent a car or when they have to register themselves with the authority of another country for them to be able to drive, or even to just use the driver's license as another form of identity, it doesn't need persistent connection and re-verification from the centralized original system, in this case, the police department. So this becomes a verified credential that can be trusted, that's immutable, and has with it built security, compartments where it is safe to use, but doesn't compromise the core original system. So the way that we do this in different countries as we work together with governments is slightly different depending on their incumbent ecosystems, but the essential framework is the same. We work with issuers who then provide the service to users and enable a set or an open set of verifiers to be able to interact with the verifiable credentials. With the issuers, we identified, obviously, that the key hurdle is in the technical ability to be able to build the applications. And we have, I think, progressed quite a lot as an overall IT industry to have been able to use IP tools over the last couple of decades, that we used a similar approach when we're working with these large enterprises or government stakeholders. They do not have to relearn Web3 technologies. They do not have to rebuild stacks as they have today. They use APIs to be able to interact and open up their services to the developer community that wants to build dApps upon it. And these get issued as verifiable credentials that are given, issued, and stored within the possession and control of the user, which means that you then remove the dependency of this middleman. And as it goes out, you can then use this verifiable credential with other verifiers, and depending on the design of the VC, either a permission verifier or in some cases, VCs, as you'll see later, that can be used openly by lots of different stakeholders. We call this system ZCert, which is our base stack for ID, and it can be used by multiple agencies, governments, and enterprises seamlessly, and it rides on Ztrix blockchain. But as I'll share with you later, interoperability is really one of the key tenets that we're trying to build upon. So when we looked at this, we couldn't design a standard from the ground up, and we shouldn't. So we looked at what would be the most feasible way moving forward to lessen the resistance to be able to adopt. And we're very lucky to find that as the industry has progressed, the United Nations and CFAC have advocated for self-sovereign identity and verifiable credentials as key technologies to be able to facilitate the movement of data across borders and across enterprises. And even more so, the World Wide Web Consortium, or W3C, has also suggested that the verifiable credentials can become a common standard. So this is key because as we build along these standards, it lessens the friction for another enterprise or another ecosystem to adopt. So when you saw the end user example of the Chinese driver's license that I shared earlier, the same base approach can be applied to lots of different other documents or credentials. So of course, we're working quite closely with parties to build out national IDs, and as countries go towards digital IDs, we envision that blockchain will be a key enabler for that within the country, but also in interoperability outside of their borders. Academic qualifications are fairly key. Today, I think we take a lot of them for granted as just things that you have and you report on your CV, but it becomes actually very, very difficult and yet meaningful to have to verify those. And this is probably a form of a verifiable credential that you do not need permissioned actors to be able to access, right? You would just need the user to want to share it, and anybody else that they share it to should be able to verify. But then you move into some more sensitive documents, such as banking statements or key and sensitive financial data that either are associated to the person or to the enterprise. And those, it makes more sense to build the VC with a couple of security components attached to it, where only the right kind of organizations can then verify. And this can still be achieved with the same kind of standards that we've been building upon, as I've shown you before. But then what we've been really concentrating on over the last year has been the most meaningful one, because as the first three are key enablers, you still have to build out use cases which are really commercial and where there's real money attached to it. And cross-border trade has been around for a long time and has oftentimes been met with lots of hurdles of interoperation and integration, because the different systems across countries and the components or the actors involved in trading are not entirely integrated. But with verifiable credentials, these documents can move seamlessly across borders and read or pretty much seamlessly across differing systems. So when you look at this particular use case, we've been concentrating on, for example, certificates of origin, which are key. So I'm from Malaysia, and Malaysia is part of the ASEAN-China Free Trade Agreement. The certificates of origin are key documents that need to be verified in order for goods which are exported into China and vice versa to receive or redeem the zero tariffs associated with certain goods. But this becomes a key hurdle when the process is very cumbersome, and the documents have to be either shared hard copy or verified and re-verified in soft copy. But with a verifiable credential, it can move seamlessly across systems, and the constituent users along that chain are always assured that it's still a valid and legitimate document. We also extend this to other documents such as phytosanitary certificates and other things which are associated with moving goods across borders to keep the transaction safe, the trade feasible, but most importantly, to speed up the actual process overall. What we've seen in the early pilots is that this takes down clearance time at customs or port down from 4 days down to a few hours. And that can save ultimately about half of the time on average and 40% of the associated costs at the import point. So we do believe that these kind of use cases are the most meaningful ones to build upon, where you are using Web3 and blockchain technology in the back end, but really translating that to real economic benefit. So with this, on Ztrix, we've built a few modules which can then be used and reused for different applications by the developer community. ZCert for our ID solutions, and Ztrade to facilitate lots of verifiable credentials associated to cross-border trade and enterprise-based use cases. But we're totally aware and cognizant of the fact that the languages, the technical challenge lies in the fact that a lot of Web3 technologies have new and proprietary languages. And we're taking the counterintuitive approach of building with what enterprises probably have already been investing in over the last few decades. Their developers probably already know things such as what we support today, Node.js, Java, and Go. And in addition to this, using WebAssembly language, we remove the friction associated to the actual programming language, such that enterprises and even independent developers can build with languages that they already know, with a compiler that then translates this to something interoperable on our network. But our network cannot do this alone, and so we've invested into building the bridges and interoperability with some key partners. As I shared earlier today, we're key partners with Singho in China, providing our first connectivity to a major government blockchain. But we're also cognizant of the fact that a lot of the developer community have been building around Ethereum. And so we built bridges onto Ethereum, but a lot of the enterprise community have been experimenting over the last 5, 8 years on private chains such as Hyperledger. So building connectivity with governments, the open development platforms, but also the proprietary and closed or private platforms enables us to be able to seamlessly move data across our network, but also to each other's networks, so that we can build out and the compounding effects of developing as an overall ecosystem. So with this, we believe that keeping to the core tenets of having an ID or innovative ID system, enabling permissioned and identified actions on a blockchain, building upon self-sovereign identity, and complying with what we have been very lucky to have witnessed recently, the establishment of common global standards, is the way forward in order to be able to build these real-world applications that can be used by the masses. With this, we can then establish identity and artifacts onto blockchain for companies, for assets or goods or things, and also people. So today we might be walking around with lots of different social logins. The goods that you work with or the documents you work with may exist in different forms, but moving forward, they can all comply to a single standard that can move seamlessly across different systems. And so that's where we will end up with a scenario where we as individual users or users within an enterprise have access to the data that we're associated with seamlessly through a single window, which might be a blockchain address, but more importantly, a blockchain address that can then transmit data between different systems. So we believe that this is probably the way forward, but as I shared, our network can't do it alone, and we know that the key areas of where this can be envisioned or realized are in real-world assets or what we think go onto real-world applications, ESG, which depend on multiple differing systems to be able to compute some meaningful data. And so that's why we launched with Web3 Labs here in Hong Kong and Summer Capital, the Global Accelerator Program, where developers can work quite closely with government and enterprise stakeholders here in Hong Kong, supported by the progressive regulations here, to then be able to build real-world assets for the next billion users. So we're excited to engage with you. We have a booth down in E04, but also we've been sponsoring coffee for the conference. So if you feel that you need a coffee fix, but also want to talk about how to build out for real-world use cases, please give us a shout, and we're excited to be working with you. And thank you again to Web3 Festival for having us. Thank you.
Thank you. Big round of applause for Dato. Thank you so much for informative sharing. Thank you. Please be seated. So now, ladies and gentlemen, let's welcome our next keynote speaker, Ms. Lily Liu, Chairman at Solana Foundation, to talk about the innovation journey of Solana. So without further ado, let's give Ms. Lily Liu a round of applause.
All right. Hi, everyone. I'm Lily. I'm the president of the Solana Foundation. I first discovered crypto about 10 years ago in Shanghai with Bitcoin, when it was just a Bitcoin world. And recently, about 3 years ago, got involved in Solana because it was my belief then, when I first started using Solana, that it was, and still is my belief, the only chain where you can actually have a direct relationship with consumers. So you've probably heard of Solana. Maybe you've even been buying some of those things recently called meme coins. But I wanted to talk about a couple of things that we've been really building in terms of applications and experiences that are actually relevant to the everyday world. So beyond speed, innovation journey of Solana. One thing we've been really focused on articulating last year, this year, is really thinking about what is only possible on Solana. And before we get into what's only possible on Solana, we even need to think about what's only possible on blockchains, right? But here's some examples of what we've been up to within Solana to demonstrate what is only possible on blockchains, and within that, what is only possible on Solana. Deepen. really hot category. We've been the category definer within DePIN. You've probably heard of Helium. They were one of the first. They've been a very substantial project over the last number of years, and they migrated their entire project over to using Solana as their L1. There's also Render, HiveMapper, and really category leaders in GPU compute networks, as well as decentralized mapping. DePIN as a category. Here's also a number of other projects that are a little bit newer, up and coming. I'm sure there's many more. And I expect this is going to be particularly relevant here in APAC, given sort of the hardware networks and a lot of the other sort of things that you really only find here in APAC. So look out for some of these folks. Meme coins, of course, right? I think it all started off with this fellow. And so you've probably been paying attention to some of these things that have been happening. However you might feel about meme coins, it is an experience that you can directly engage with on the chain. That's been incredibly popular. Another project that is near and dear to my heart, Drip. What we built last year is something called state compression. State compression basically made it such that you could take 1 million NFTs, spend only $100 minting them. And that is several orders of magnitude difference from minting NFTs on any other chain within crypto. And what that creates is it creates entirely new experiences, content delivery, ways that people can integrate with the blockchain and experience sort of content, art, delivery in entirely new ways that is only possible in crypto and only possible on Solana. But today I want to talk about a new category that we've been thinking about. We've been thinking about it for a long time with regards to payments. Actually, the simplest use case in crypto. So a few years ago, we launched something called Solana Pay. And Solana Pay essentially is, you call it a little bit of middleware layer that allows you to easily use Solana as a blockchain for payments, and people typically think about using a stablecoin, USDC or something like that, on SPL, our fungible token standard, in order to pay. Really, you can do that with any token, and that's a messaging protocol that we started about a couple of years ago. And to us, that was kind of V0, V1, necessary condition. But what we're thinking about now is new category, we call it PayFi. What is PayFi? Well, let's go back to the original vision of blockchain. The original vision of blockchain, as articulated, of course, by Bitcoin, is a peer-to-peer electronic cash system. That was articulated 15 years ago, but the reality of that is, despite the billion transaction roadmap that was written about by Gavin Andreessen back in 2013, 2014, it's just something that obviously hasn't come to pass in Bitcoin. And the next contender for that was when we got sort of the articulation of programmable smart contract-based financial systems from Ethereum. And a lot of, and they've done really amazing things for crypto, but there are some challenges with that, right? So with, so some of the principles of how you go from peer-to-peer electronic cash system and how you actually build that and where that takes us. So yes, you have self-custody, and we've all probably used this wallet before. Great start. And with self-custody, you kind of move towards programmable money, right? And so we've also probably seen this quite a bit on our browsers before. But one of the challenges there is because it's a couple of minutes to process a transaction, you click a button, and unlike in the Web 2 world, you click a button and you go refresh your Block Explorer, and this is just not a payments-ready experience that regular people are going to want to tolerate. On top of that, the vision is the open financial system, but what you've got is, yes, you've got decentralized apps where you can swap, but on some days in particular, it's a several $100 transaction, right? And so in the kind of vision where we're going towards self-sovereignty, these are some of the building blocks, but in actuality, it's a little bit, it is production, it's proof of concept, but it's not really scalable right now because of performance. So, in our opinion, there are 3 conditions for us to start to realize the original vision of blockchain, which is the peer-to-peer electronic cash system moving us towards programmable money and an open financial system. What are those 3 conditions? Certainly performance is part of it, right? So performance, You've probably heard and you're probably aware that Solana is really fast and really cheap. That's the beginning, that's not the end. Block time's 400 milliseconds, and the cost to clear a transaction about 0.001 cents. Another way to express performance is we're talking about state compression. So what does it cost to mint 1 million NFTs? Those are kind of the two core building blocks of blockchains these days: fungible tokens, non-fungible tokens. So on other chains, it can cost you millions of dollars to mint 1 million NFTs. On Solana, it costs you $100 because we've invested in protocol adjacent technology to take metadata, put it on Merkle tree, so that you can basically with the existing chain, get this degree of performance. The second condition is we call capital liquidity. Said another way, you've got to have liquidity in a medium of exchange that people actually want to use. As much as we love Bitcoin, as much as we love all of the native tokens, we're not yet at a point where people denominate their lives in Bitcoin or sats or anything like that. People still want to use the fiat currencies because that is how they settle goods and services in their normal lives. So if we want to get into the actual sort of real goods and services economies, then you've got to have liquidity in the medium exchanges that people actually use. So when you look at Solana, we now are #1 in stablecoin transfer volumes because the chain actually works for the performance, allows fast and cheap settlement, which is what you need for payments. That's the second condition. The third condition is talent liquidity. Said another way, developers. We have the #2 developer ecosystem. In the 2017-2018 era of kind of second-gen general purpose L1 blockchains, we've been the only one to build it entirely from the ground up. And have a very robust independent developer ecosystem that we kind of built according to our original vision. And so just to recap, 3 conditions: performance, capital liquidity, talent liquidity. Said another way, fast and cheap. You want to have liquidity, money that people actually use, and you've got to have developers. And up until now, at best, other ecosystems have been able to capture 2 out of those 3, which is why moving towards this sort of a scale ecosystem of open financial system, programmable money is something that's been somewhat limited within our ecosystem, within our industry, and hasn't really been scalable beyond that. And our perspective is that Solana is where this is actually going to happen. So what is PayFi? Isn't this just DeFi? So my thought on this is DeFi is all built around buy-sell, right? And buy-sell is very much the bedrock of trading, which is obviously a big part of this industry. But buy-sell is all around the trade, and it's not around a payment, right? People buy, sell, and they trade for very different reasons from when you transfer value for the intent of making a payment or settling, right? You're settling, and the transaction on the other side is not swapping for another financial asset, but rather you're using that to purchase a good or service, and that is the transfer versus the buy and sell. And so as we think about new financial primitives, what you can develop when you think about the payments ecosystem and the settlement ecosystem, so you can build entirely new financial primitives over what I would say is a much larger actually application space, which is really around the time value of money. What does that mean? So here are some examples. This is a consumer example. You've probably heard of buy now, pay later. That's been a very sort of high growth set of financial products in the Web2 world, right? And where you get a checkout button. Upon checkout, you can sort of buy something and then pay it back over time. In crypto, what if you could do something which is a little bit better? Buy now, pay never. Sounds better, right? So what you could do, as an example, you could buy coffee. It costs you $5. So you pay the merchant. But really what you're doing on the back end is you take some amount of money, let's call it $50, you put it into a lend borrow, and the interest rate from that over time pays off your $5 of coffee. Maybe it even pays back, instead of just $5, $5.50. So that's how in crypto, we've always got to be coming up with primitives and applications that are not just a little bit better than what we get in the Web 2 world, but 10x better. And this is pretty cool. Buy now, pay later, buy now, pay never. Another example, this is for the creator industry. Creators, right, if you've got 1 million views on a video, let's say in YouTube, that's worth anywhere between a couple $1,000s and call it $20,000. So let's say you've got your 1 million views, and as a creator, you've got costs to pay for, right? You've got to fund your production costs, you've got to pay your team, you've got to pay your crew, and show me a bank which is going to give you an advance on your 1 million YouTube views. Doesn't exist, right? So what if with DeFi you can suddenly not just actually get access to an advance, but you can even get immediate access to an advance through some form of credit pools online. And we already see that today in Lend Borrow. It's just not applied towards specific financial products or financial categories. Well, you could do that. Let's say someone prices my 1 million views at values it at $10,000. I get that advance today, and I stream over time payments as I get those views in and the ad dollars, so on and so forth, back to either the credit pool or the lender that advanced me that $10,000 to begin with. Again, this is not something you can do today. This is not just a little bit better. It's literally 10x better for creators and actually starts to create liquidity and support an entire creator industry and monetization online in ways you cannot do today. Third example, accounts receivable. I'm guessing most people here run a business of some sort, and you've got your vendors, and you've got to pay your vendors in net 13, net 14, net 15, net 30 days. So let's say a vendor owes a supplier $100,000 in 30 days, right? What you can do is the supplier sells that receivable to a credit pool for $90,000, and then when the customer pays, then they pay back the $100,000. This already exists, massive industry around this in supply chain, for example, in really it's a very substantial industry, but this is something which is not accessible at the micro level for a single company to easily onboard onto, and it's also not available for certainly an individual invoice. So to me, the value of these kind of new technologies has always been about how do you open up and organize and monetize a long tail of demand, right? Many of these solutions already exist in some form in the world. The business models are not new, but in the same way that we got, for example, the iPhone and gave us Uber, right? And opened up this entirely sort of long tail of supply and demand. It's my belief that that is always what new technologies do if they are valuable, and that is something that we've got to look to. What is blockchain doing for us in that regard as well? So here are 3 examples for consumers, for creators, for businesses. It's all around the time value of money, and those are the types of things we move from payments into programmable money, into open financial systems, and this new class of primitives. We call it PayFi, and if you look around, it is only possible on Solana today. Here's some more examples: payday loans, credit cards, corporate credit, even interbank repo markets if you look within wholesale banking. So for us, we're always thinking about those applications that we can uniquely build, because we are that place where you have talent, capital, and also performance. And so that is what we're looking to next, PayFi. And so that's what we got to share today. There's a lot of things that are already happening in Solana that you're probably aware of, and this is what's coming up next for us. Thank you.
Thank you, Lily. Thank you. Impressive presentation. Thank you very much. Please be seated. So now, ladies and gentlemen, moving on to our next keynote session, we're going to dig into another topic, bring Bitcoin to Web3. So without further ado, let's welcome Mr. Dennis Fadif, Head of Developer Experience at Cedar Chain, on stage. A big round of applause for Dennis.
Hi, everyone. My name is Dennis, and I'm going to be talking about Bitcoin. So Bitcoin was the first blockchain that mattered, that kind of started the whole industry, and it has been huge ever since. Right? We see that it has huge market cap, it dominates the market. Most value of the industry is actually in Bitcoin right now. So it never really became irrelevant, right, or even declined in its popularity, even though we now have thousands of blockchains that are much more sophisticated than Bitcoin. So we see it has been also accepted by the finance industry, by countries, and generally by retail users. So it's popular among institutions as well as regular everyday users. But these opportunities that Bitcoin provides never have been really utilized by DeFi and by all these interesting, sophisticated applications that we're building right now. And why is that, right? We see that the wrapped Bitcoin that can be used in DeFi is only a small fraction of Ethereum, right? So the percentage of Bitcoin that is being used in DeFi applications is really small. And if we look at WBTC versus BTC itself, like it's tiny, it's less than 1%. And that's the opportunity we see. That's the market that we want to work with, and we think that Zeta Chain has a good solution for this problem, right? Bitcoin never actually reaching DeFi applications. So what is Zeta Chain? Zeta Chain is simple, fast, and secure omni-chain blockchain. What does that mean? So first of all, we focus on chain abstraction. Chain abstraction, in our understanding, is all about interoperability between blockchains and user experience. So right now, the average user who wants to put their BTC into a DeFi application, they first have to take their Bitcoin, put it in send it to an address. It will transfer this Bitcoin to Ethereum as wrapped Bitcoin. Then they need to open their Ethereum wallet, have some ETH for gas, put wrapped BTC into a contract, figure all these things out. But they're just a regular Bitcoin user. They bought some in the past. They don't really know much about Ethereum. They certainly don't have ETH to pay for gas. And they don't want to learn all of this. Like, that's how most, not most, but many Bitcoin users are. And we can't blame them, right? That's just not the user experience they wanna have. Zeta Chain solves that, and I'm going to talk about it a bit later. And we also focus on security, because, of course, we have centralized exchanges and we have different sort of bridges that kind of do this in a clunky way in terms of UX, and not all of them are secure. So there are a lot of issues with bridging Bitcoin and having it on other blockchains. So we wanted to approach this from a point of view of decentralization and security first and foremost, because you can't really convince Bitcoin users to put their BTC into a DeFi application if it's not secure from the very beginning. So how do we do this? Well, first of all, we offer cross-chain messaging. This is a useful mechanism that other projects are offering right now as well, right? We know that messaging is one of the ways interoperability is implemented right now between EVM blockchains and some other chains. So we on testnet we have support for Polygon, BSC, Ethereum, and it's working great. It helps developers build applications that weren't possible before. You can send arbitrary data, you can send value, and we think this is a very useful mechanism to have in your toolkit as a developer. The problem with messaging is that it requires contracts on all the chains that you want to have connected. So you deploy a contract on Polygon, you deploy a contract on Ethereum, you make sure that they know how to handle messages, how to send messages. And if you have a complex application that spans potentially dozens of blockchains, it really becomes hard. Like after 10 blockchains, I don't really imagine how you can handle the complexity that comes with messaging. And of course, it excludes Bitcoin completely, which is not great, right? You can't really do messaging on Bitcoin. There are very limited scripting support, and nobody really wants to build on top of that directly. So messaging is good, but it's not for everything. So what we provide instead is Omnichain. Omnichain is a much more simple and scalable architecture where you deploy a contract directly to Zeta Chain, and the whole logic of your contract is stored the whole logic of your application is stored in this contract. You no longer need to deploy anything on Ethereum, on Polygon, BSC, or any other blockchain. You just deploy a single contract. And the way this works is users from any connected chain, including Bitcoin, can deposit and withdraw tokens natively into your contract. So what this means is that the whole logic is encapsulated in a single contract, and all users just can interact directly with your contract, deposit, withdraw, call functions, and this is really powerful. It's really powerful because it automatically gives you interoperability with all the blockchains, even the ones that you didn't really think about, like Bitcoin. But it also has an interesting property that your contract is not only compatible with chains that are currently connected to Zeta Chain, but it's compatible with the chains that will be connected to Zeta Chain in the future. So this is really cool because you no longer have to think about integrating with more chains. You just have your contract, and it operates through the same interface with all the chains. And if we add another chain like Solana, your contract will be compatible with it out of the box, which is pretty huge as we move on to this world where we have hundreds and thousands of blockchains, right? Messaging is good right now, but it's not scalable. With Omnichain, it is scalable. And it opens a lot of interesting use cases where you trigger a contract from one chain, it executes some logic on Zeta Chain, and it produces one or more outputs to other blockchains. Since Zeta Chain is also a Cosmos-based chain, once we add IBC, this becomes even more interesting because we will be automatically connected to 70+ IBC chains. So triggering a contract from BSC to Zeta Chain, then executing arbitrary logic and potentially outputting to Bitcoin. So the way this impacts user experience is also pretty cool. Imagine you are a Bitcoin user and you need to pay someone USDC on Ethereum. So in the past, what you had to do is you had to use a bridge, move your BTC to Ethereum, swap for USDC, have some ETH to pay for gas, and only then you can send USDC. You probably are left with some ETH as gas didn't use all of it, or you didn't swap enough, so you have to swap again. This is a mess. Nobody wants to do that. With Zeta Chain, it's super simple. As a Bitcoin user, you make a single Bitcoin transaction with BTC, provide a memo which says what you want to do, which contract you want to call on Zeta Chain, and that's it. You sign only one transaction. You don't have to deal with wrap Bitcoin. You don't have to think about a gas on connected chain like Ethereum. It just works because Bitcoin is being sent to Zeta Chain to a contract you specified in a memo. The contract knows what you want to do in the end, right? So you can think of it kind of like an intent system where a Bitcoin user specifies what they want to do in the end. They want to send this amount of USDC to this user on this chain. And that's it. The contract swaps Bitcoin for another asset like USDC, figures out the gas. We have an API for that. And it withdraws USDC to the user address, to the account address you specified. And that's it. You don't need as a Bitcoin user, you don't need to have a Ethereum wallet. You don't need to think about gas. All of this just works. And at the end of the day, you input Bitcoin and someone gets USDC. That's the end of the story. We think it's incredibly powerful, and it's just one example of what you can do, right? It's a general purpose EVM-compatible platform, so it's really up to you to figure out what's the best use case. We think swap is a very good example because everyone's swapping tokens back and forth, right? But here you actually have cross-chain swap pretty much out of the box. What we provide are the APIs for users to deposit and withdraw tokens. Everything else is just your contract logic. So Zeta Chain is built on a very good foundation of Cosmos SDK, Comet BFT. It features fast finality. We have a proof of stake system in place with core validators. We also have observer validators that watch external chains for deposits and withdrawals. So it's all decentralized, and it works through a TSS MPC mechanism where addresses on all chains is owned by validators. So at no point in time the private key is accessible by a single entity. It's always a signing process among a decentralized set of validators. So we feature EVM compatibility. We have all the tooling you need, including liquidity pools. We have great developer experience, very familiar to anyone who used EVM or built for EVM before. You just clone a template, run some commands, and you've got an omni-chain contract. You can complete a tutorial in just about 30 minutes, and you have a cross-chain swap. That's pretty cool. We are live on mainnet. We launched in February. We're processing hundreds of thousands of transactions, roughly 200 to 300 transactions per block, 5 seconds per block. So it's very fast, and we've got a lot of projects already deployed to Zeta Chain. We have SushiSwap. So if you're building a DeFi application, you might be interested to know that we already have big players on Zeta Chain already on mainnet. We have also native, smaller projects that are Zeta Chain native that were built from the grounds up to leverage the omni-chain features that Zeta Chain offers, like Eddy Finance, which is a cross-chain swap BTC to ETH or whatever else token. We have Curve coming to Zeta Chain pretty soon, which is exciting. What can you build? Well, it's a general purpose EVM compatible platform, so you can build anything. What we provide is the interoperability layer that you can leverage to build multi-asset swaps, lending protocols that use Bitcoin. You can mint NFTs based on the input from all these blockchains. If you're building a game, it's a very good fit because now you don't really need to do anything to accept all the tokens from all the connected chains. So your application instantly becomes cross-chain compatible without you even having to modify anything in the code, which is really powerful. And as developer, you need tooling, right? It's not enough to just have a chain, even if it provides a lot of useful features out of the box. You need oracles, you need indexers, block explorers, all of these things. We have them. We have price oracles. We have account abstraction. Pretty much everything you need as a developer, we have. And more projects are coming to Zeta Chain just because it's a very useful platform to build upon, right? When you deploy on Zeta Chain, when you deploy on a different chain, like you only get users of that specific chain. When you deploy on Zeta Chain, you get users of all connected chains that can seamlessly interact with your contract. So the community is incredibly active. We have over 1 million people using the platform, hundreds of dApps deployed. So it's a very good company of users and projects to join. So I recommend you check out Zeta Chain. We have a grants program that you can take advantage of and get some funding for your project. And we are looking forward to seeing you building on Zeta Chain. Thank you.
Thank you, Dennis. A big hand for Dennis for the insightful sharing on Bitcoin and Web3. Thank you so much. Please be seated. So now, ladies and gentlemen, Moving on to another highly discussed topic, AI meets DeFi. So without further ado, let's welcome our next keynote speaker, Mr. Scott Stewart, co-founder at Kava, on stage. A big round of applause for Scott.
Morning, everybody. Sunday morning in Hong Kong. So we're going to talk about two things today. One that you're probably familiar with, which is DeFi, and what Kava does in DeFi. And then one that you may be a little bit less familiar with, which is AI. And we're going to go briefly through the AI stack as it exists today, and then how that AI stack is going to be applied specifically to the crypto industry. Where's my stuff here? All right, so high-level intro to Kava. So Kava's been around as a blockchain for about 4 years. It launched in Q4 of 2019 as a Binance IEO, and it started as a launch pad, and it started doing DeFi before DeFi was a real term. And over time, this ecosystem developed as we saw new types of DeFi projects come on, and eventually, originally this was created as a Cosmos blockchain. So this is one of the first major Cosmos blockchains that released with IBC, actually before the hub was launched. And then an EVM was then put on top of this Cosmos blockchain that allowed for a widespread amount of users and applications to come on, build, and seamlessly connect between the Cosmos ecosystem and the Ethereum ecosystem. So as a result, Kava's been able to secure some of the largest DeFi partnerships in the space. So USDT native integration. Tether chose Kava as the official provider of USDT to all of the Cosmos. So any Cosmos chain that's going to consume native USDT through IBC is doing that through Kava. That happened about 2 quarters ago, about 160 million USDT issued on Kava today. BitGo. So BitGo chose Kava for a WBTC native integration, which just recently launched. That's up and live. And then a big thing with Kava and its DeFi ecosystem is about native assets and native liquidity. And so when you have native assets, it's important to have distribution of those assets. And so these native assets like USDT and WBTC are now integrated into the largest distribution partners like Binance and many other exchanges, as well as Stargate and Axelar, so that users can move their assets natively from the Ethereum ecosystem to the Cosmos ecosystem and on the Kava ecosystem without having to worry about bridge hacks and things like that. Just some high-level stuff about Kava. So it's the 5th largest USDT chain that's actively natively supported. 8th largest ecosystem by number of dApps deployed. We really did see a lot of dApps come onto Kava once the EVM was launched a little under 2 years ago. It's only one of 3 chains that has both a native USDT integration and native BTC integration. You can think about what the other 2 are. It's Ethereum and Tron. So it's very difficult to get these providers to want to see the value of a chain, deploy those native assets on the chain, and build those integrations with the chain. It's bridged about 2.5 billion in assets since inception. A lot of this was actually done through Binance Chain, now transferring over to bridge with BSC as they're sunsetting the BNB chain. Bunch of assets on chain, low transaction costs due to the nature of it being this Cosmos SDK based chain, and then this innovative cross-chain structure. Basically what I was talking about before, where Kava is the only chain that allows native assets on Ethereum to flow through to the Cosmos ecosystem in a seamless way, packaged with some of the largest bridge providers like Axelar and Starknet. So the Kava DeFi ecosystem, large and growing ecosystem with a bunch of large integrations, as well as blue chip dApps that have deployed on it, and a bunch of native apps, native dApps that have deployed on it. Okay, so that's all stuff that you guys are familiar with, DeFi. Now something that you may be a little bit less familiar with, AI. So what is this AI thing? People kind of keep talking about AI, it's growing, it's happening over here. There's a lot of crypto projects that are talking about using AI in their crypto project. So what is this AI thing in the general sense, and then how can this be applied to crypto? So just at a high level, cursory overview, AI ecosystem has three main layers. The first layer is the application layer. So the killer app here is your chat GPTs. So these are large language models that power these chatbots. And so this is chat GPT, Google's Gemini, Twitter's XAI, Prometheus, or Anthropic's Claude. And then the layer beneath that is cloud computing and on-prem compute. This is the stuff that those applications need to use to train their models. This is like Google Cloud, CoreWeave, Lambda, companies like this, Azure. And then underneath that is the hardware itself, the chips itself. So this is like NVIDIA, AMD. So just quickly diving into the application layer, like what is this application layer? What are they actually doing? You see a lot of just images of like some Android like lady reaching for something. These application layers consist of AI companies that are performing, they're training models and integrating these models with products. Companies like OpenAI apply a variety of techniques, a popular one being reinforcement learning with human feedback. This is a little diagram of that, RLFH, on transformer models. And the key is that they take all of these different techniques and stack them together to make a more and more intelligent model that then powers end user applications like ChatGPT. And we were looking at this at 2012, 2013. And at the time, there was interesting things that you could do with these models, but the amount of weights or parameters were only so much that you could just kind of do some interesting things. And it turns out that only after parameter count hits a large enough number were these things intelligent enough to actually be useful. So this means that the bigger the models, the more intelligent the system is. And the useful thing is there doesn't seem to be a cap on the scaling for the amount of parameters that can be fit into these models as long as the compute is there. And this is a graph of basically over the last 5 years how the parameter weights, the number of parameters has grown exponentially over time and is going to continue to do so. So that's the application layer. Finally, these large companies, some of the world's largest companies as well as startups alike, are competing viciously to create bigger and bigger models, smarter and smarter AIs that can be benchmarked on a number of different evaluations to compare them to each other. That's the application layer. Application layer needs to train their models. The way that they train their models is using cloud compute or on-prem compute. The main thing to take away from this is that it's not the case that they're training on a bunch of AWS boxes in various regions. The key thing here is if you want to train a gigantic model, you have to wire up a shit ton of GPUs together using high throughput, low latency connections to basically make one massive GPU to train one massive model. It requires a significant amount of specialized knowledge to build these on-prem or cloud clusters. And just like as a note, something like the most recent version of ChatGPT was trained on 25,000 NVIDIA GPUs. So that's $200 million worth of GPUs that had to be utilized to train that model. So this is not small stake stuff to be able to get these models to where they're at. And then finally, there's the hardware layer itself. So companies like NVIDIA and AMD, which create the GPUs, are competing to make more and more powerful GPUs. I was just at the NVIDIA GTC conference in San Francisco 2 weeks ago, where Jensen announced the newest version of the Blackwell chip, which represents a 1,000x increase in AI compute over the last 8 years, from 19 teraflops in 2016 to 20,000 teraflops this year. So at a high level, you have this industry where the model complexity and intelligence is growing exponentially. The compute, the cloud compute, is becoming more robust, and the chips themselves are growing exponentially in terms of their ability to power that compute and that intelligence. The result is this sector is growing massively, and it is going to be extended into nearly every industry. AI is coming to basically everything, including blockchain. So how does AI actually fit into the blockchain space? So at Kava, we're going to be launching Kava AI. Kava AI is a decentralized AI developed on the Kava network, and Kava AI powers a cross-chain AI marketplace. So a takeaway here is that you can indeed build a decentralized AI that's able to compete in terms of the number of modalities and benchmarks that it's able to attain with the largest AI applications and chatbots. So that's against GPT-4 right now, Gemini Ultra, and Grok 1. So this is developing an AI built on a blockchain to power a number of applications. And the first application that Kava AI is going to power is a robust decentralized chatbot, like ChatGPT and other end-user applications, where a user can come on, ask a question just like you would with ChatGPT. It'll give you an answer. You can tune that. That answer, and then you can go and actually deploy the thing. Capabilities of this Kava AI would include advanced reasoning across modalities. So just like any AI, a number of different modalities or ways in which you can ask it to do things, it will respond in reasonable ways. An important one when we're tuning this model for crypto is code generation. So the ability for a human to prompt it to generate or alter smart contract code in Solidity, for instance, that can then be used to deploy onto the Kava EVM and used for debugging complex code bases. Language processing, so the ability in a number of different languages, English, Chinese, Russian, whatever, to prompt this thing to pull real data and transaction history from smart contracts that have a ton of usage already on Kava. And then most importantly, decentralized development. So Kava AI stands in stark contrast to centralized AI development by major companies, in that Kava AI is completely open sourced and governed by the Kava community. This is going to be the first AI that is actually built and governed by a community, in contrast to these centralized AI developments that are completely closed source. It's all secret sauce, and they're not letting you know how this thing's being done, and they don't want to tell you how this thing's being done or where it's going. Very secretive. And then a natural thing then that you can do with this AI is just create extensions. So these are just hooks to be able to create a marketplace that leverages the Kava AI to allow users to discover, deploy, and consume a wide variety of applications that are built on top of this ecosystem. And so developers can easily create AI extensions to fit applications that are already run on Kava. So there's ease of deployment, seamlessly integrates to your existing Kava application, and it leverages the same advanced security that Kava needs to be able to build out to manage the hundreds of millions of assets that it moves around every day. Another really nice benefit about launching this marketplace on top of Kava is that it benefits from the existing cross-chain rails that Kava has already built out for Kava DeFi. So with the cross-chain architectures that already bolt into Kava, like IBC to the Cosmos ecosystem, as well as general message passing, which covers most of the Ethereum ecosystem, when a user creates a service on Kava's AI marketplace, that can be extended to anybody downstream in Cosmos, so the Cosmos Hub, Injective, Say, pick your favorite Osmosis, your favorite chain, can consume that service on the Cosmos side, as well as any Ethereum or L2 service can consume this using the same message passing framework that we already have, and it benefits from the distribution that Kava has already built out. I'm going to go through the end of this stuff quickly. Here's examples of how DeFi meets AI. So meme coin generation. So you as a user can now show up. Solana and Avalanche have done an excellent job of creating an ecosystem where people can launch things easily. This is going to even reduce the barrier to entry where a user can chat with this chatbot, create meme coins, create the Solidity, deploy that. Same thing with NFTs. You can generate an NFT collection, tweak it, deploy it, and query a number of different dApps. Just finishing off here, reasons why Kava is building this AI. Kava has the resources to launch a decentralized AI that competes with centralized AI. So I was just at this NVIDIA GTC conference. 90% of those companies are not able to build AIs because it costs millions of dollars to train these things against GPUs. Kava's got a community pool with something like $450 million in liquid assets that it can use to be able to train a top-level AI. Kava has experience in building ecosystems, already built out a robust DeFi ecosystem. We can leverage that know-how for AI, and AI is value add to DeFi. Incentives for the developer community are going to go first towards building DeFi applications, and it's a new use case for the Kava token. Timeline. So it's really important that all of this is community driven. There are really fantastic AIs out there that exist today. The only value of Kava AI is that it is actually run and progressed by the community. So all of this is happening through proposals. The first Kava signaling proposal will be in early Q2. Subsequent funding proposals by the community for the Kava AI development, Kava AI marketplace instantiation and developer incentives, as well as a DePIN cloud network will come subsequently. And we invite you guys to join Kava in developing the most powerful decentralized AI and AI marketplace. You can do it at kava.io or follow us on Kava Chain at Twitter. All right. Thank you, guys.
A big round of applause for Scott. Thank you so much for sharing your insightful perspectives on the topic, AI meets DeFi. Thank you very much. Please be seated. So, ladies and gentlemen, moving on, let's welcome our next keynote speaker, Hazib, partner of Dragonfly Capital, to share his thoughts on crypto and AI. So, ladies and gentlemen, please join me in welcoming Hazib on stage. A big round of applause for him.
Hello, everybody. So I'm Hasib. I'm a managing partner at Dragonfly, which is a global crypto investment firm. And I'm talking to you guys today about the intersection of crypto and AI. So this is a sector that's gotten very hot lately. A lot of people are talking about it. And as an investor, I see a lot of pitches from a lot of different startups that are trying to build something at the intersection of crypto and AI. So this talk is going to be a bit of an overview to look at all the different things people are building and why they're building them. So first of all, why crypto and AI? You can't see this. All right, whatever. Why crypto and AI? They're both sectors that have a lot of bullshit. But the one thing that's nice about crypto and AI is that crypto is an industry that creates trust, and AI is an industry that is in sore need of trust. And so there are very many interesting intersections where the two of them can empower each other. So let me give you an overview of the different areas where people are building smart contract networks or decentralized networks in the intersection of crypto and AI. First is decentralized compute. This is basically GPU marketplaces, because of course GPUs are what you use to train AI models. And right now there's a massive GPU shortage around the world. Part of the reason why NVIDIA is such a valuable company is that they're building most of these really valuable GPUs that everyone wants for machine learning. If you can't get those GPUs normally, maybe you can get them through a decentralized marketplace at a cheaper cost than through Amazon or one of these centralized cloud providers. So the two big networks here are Render and Akash. Render, about 5 billion fully diluted valuation. Akash, a little bit under $1 billion. The second category, so first you've got the GPUs. You get the GPUs from a decentralized marketplace. Now you need to train a model. Okay? So decentralized training, there are a few different startups that are working on this, but this is a very hard sector to get right because training is extremely expensive. We heard earlier in the previous talk, some companies are paying millions of dollars on these training runs. So it's very difficult to do this completely in a decentralized way. But if you look at BitTensor, which today is the largest AI token, about $12 billion FTV, it works more or less in decentralized training. You can sort of think of it as a decentralized Kaggle, where it's a competition to train a model that has maximum performance on some particular objective function. There's also Jensen, which is a pre-launch startup that is also doing decentralized training. The third category is inference. And this is what I'm going to be diving deep into in this talk. Okay, so inference is, you've got the GPUs, you train the model, now you want to run the model. But you don't have the ability to run the model yourself. You're going to use a decentralized network to run the model for you. Okay? So Ritual, Modulus, there are many different startups. This is probably the most common pitch that I see as a VC is people working on decentralized inference. So just very quickly to go through how a machine learning model works. If you don't understand that, it's useful to get some context of what's going on. When you train a model, first you have a lot of data, and ideally data that's labeled. Okay, so this is a car, this is a person, this is a strawberry. And once you have all these labeled data, use that to train the model, and anytime your model makes a mistake, you update the model weights. These are all the parameters of the model, or sort of the neurons in the model. You're updating them using backpropagation and gradient descent. And you do that over and over and over again for all these different things. And here's where you're paying the millions of dollars. Right? You're doing gigantic training runs with many, many terabytes of data that you are training this model with. Okay? Then once you have the trained model, and the trained model is very big, and it costs a lot of money to get it. But once you have it, then you can run inference, which is you give it a picture, you say, what is this? And the model will do all of its magic, and it'll say, oh, this is a bicycle. Okay? That part is much cheaper than the training. But it's still non-trivial to actually get good inference and fast inference and consistent inference on a model that you have. So to be clear, there are other AI projects in crypto that are more application layer, like MyShell, which is chatbots, Kaito, which is doing data analysis or looking at trading metrics. But I'm going to be focused purely on the decentralized inference protocols. Okay, these are purely decentralized protocols. So let's look at why this is a problem. Okay, let's say that you want to run a very popular model like Llama 270B, which is made by Facebook. Llama 270B requires 140 gigabytes of RAM. Most people don't have 140 gigabytes of RAM. Right? Even if you have a GPU at home, it probably doesn't have that much memory. So in order to run a model like this, you need someone else to run it for you who has a beefier computer than you have. So now, you might not want to trust a centralized provider like Mr. Sam and his company. And so if you choose not to do that, you might think, OK, well, I want to do this, but I need to be able to trust the output. Right? If I say, great, I'm going to run Llama 70B, but how do you know if you're doing a decentralized network that you're actually getting Llama 70B? You might be getting Llama 7B. Someone might be lying to you and then actually running a cheaper model than the one you asked for. So anytime you're doing this in a decentralized network, you have to assume someone's cheating you. So how do you make sure you don't get cheated? Well, the answer is you need some kind of verification. How do you verify this was the model that you're running? So you could think, well, that's why we have blockchains. We have smart contracts. So put the machine learning model in a smart contract, run the smart contract, done. Right? OK, this does not work. The reason why this does not work is it's way too expensive. Okay? GPT-3 has a hidden layer. The embedding size is 12,288 parameters. Okay? 12,288 weights. A single matrix multiplication of this size would cost $10 billion in gas on Ethereum today. It would fill every single block for a month straight, just one single matrix multiplication. Okay? So, and there's thousands and thousands and thousands of these in a single machine learning inference. This is not going to work. All right? So we have to find some way to do this off-chain more efficiently than running it all on the blockchain. All right? So there's a continuum of 3 different approaches that people are taking of how to build decentralized inference. The first is what's called ZK-ML. So you've probably heard of ZK, zero-knowledge proofs. These are kind of cryptography, moon magic, in order to prove very efficiently that somebody did this computation. Okay? Now, the problem with ZK-ML is that it's very slow. It takes a very long time to generate a proof over a machine learning model the size of Llama 270B. It's very costly, so there's probably a factor of about 1,000x of the cost of naive inference, doing a zero-knowledge proof over that inference, and oftentimes even more, depending on the architecture of the model. And it's slow as hell. It's about 1,000 times slower than what you'd otherwise have to do running a normal model. But the advantage is that it's extremely secure. If I run a ZK proof over any model, you know beyond a shadow of a doubt you ran the machine learning model just like you said you would. And you can also do privacy if you so choose. There's other fancy stuff you can do with ZK, but mostly this is for just pure verification. So this is insanely expensive. There are some projects that are doing this, like Ezekiel, Giza, Modulus, but right now it's not very practical to do on large models. Okay? Then on the other side, you've got crypto economics. Okay? Crypto economics is more or less what you think of when you think about blockchain consensus. So this is proof of stake, everyone kind of votes. I think that the output is this. I think the output is this. And we all have stake, and we vote, and we see if you're different from everyone else, you get slashed. That's crypto economics. Right? So it's not particularly fancy. It doesn't really use any of the unique aspects of AI. It just sort of treats it as any other crypto economics problem. If Chainlink were doing machine learning, this is probably what they would do. They would do something like this. So Ritual, Atoma, these are all networks that are doing the crypto economic approach. And the advantage of crypto economics is that it's fast, it's cheap, it's mostly secure, right? Depends on how much stake is there, what's your incentive for cheating me. But it's pretty easy. It's pretty easy to get it up and running and to get something that's relatively secure using crypto economics. So ZK, you're paying a factor of 1,000. With crypto economics, how much are you paying in order to do an inference? Well, in crypto economics, all of the nodes that are running consensus, they all have to also run the computation. So if I say, predict whether this thing is a bicycle, all the nodes in consensus have to also run the same model to see whether they agree that it's a bicycle using that model. And if let's say there are 20 nodes, then you have to pay 20 times the cost, because you have to pay all those nodes to run that computation, right? So whatever is the number of nodes that will be doing the crypto economic voting, you got to pay all of them to do the underlying computation. The third approach is optimistic, and it's somewhere in between those two, okay? So optimistic machine learning basically says, I'm going to assume that when somebody responds and says, oh, okay, yeah, that's a bicycle, I ran the model, it's a bicycle. What we're going to do is we're going to assume that that's correct. But if it's not correct, then somebody can submit a fraud proof to prove that this person didn't correctly run the model, right? So it's very similar to what optimistic rollups do. You assume it's correct unless someone can prove that it's wrong, and you have to wait before you actually can confirm and say, yes, this thing is definitely a bicycle, because that person might have cheated, and you have to wait for the challenge period to expire. So this is using some kind of challenge response game, akin to TrueBit. So it's the same thing that optimistic rollups do. So you start, I'm gonna run through this because we don't have a lot of time, but you basically play a verification game, okay? So these are more or less the three big mechanisms that I'm seeing today of how people are trying to build these decentralized inference networks. The thing that's interesting about them is that these are not new. These are actually very familiar mechanisms in order to determine whether a given computation is correct. So you can see, actually, if you go to the blockchain security continuum, much like the continuum I showed you of decentralized inference, what's on the ZK side? In normal blockchains, you've got ZK rollups, right? That's exactly what they do. They do the same thing as the decentralized inference guys are doing ZK, which is that they generate these ZK proofs that proves that the computation is correct. Starkware, ZK Sync, these guys are doing exactly the same thing, just not in machine learning, right? Same thing, what's optimistic? Well, that's the optimistic rollups. Optimism, Arbitrum, they do the exact same thing with the fraud proofs. And then crypto economics, that's most layer ones, right? What do most layer ones do in order to determine that this computation, this transaction was executed correctly? They use crypto economics. So it's the exact same toolkit that we use in crypto, but adapted to machine learning, okay? Now, there is a lot of differences though. So when you're thinking about machine learning has unique challenges that blockchains don't have, okay? Now, what are these challenges? The first thing to think about, well, machine learning is just another computer program, right? At the end of the day, saying, okay, run llama 7db, and there are all these parameters and matrix multiplications, blah, blah, blah. At the end of the day, that's just a program. And what we do in blockchains is verify that programs are run correctly. So why is this different? What is actually different at all about doing this with machine learning versus any other program? Well, the first thing about machine learning is that machine learning is not designed to be proven. Machine learning is designed to be fast. It's designed to be fast on the architectures on which machine learning models are trained, okay? A normal machine learning model can be represented as a graph. So if you see this thing right here on the left, a graph basically means that there are all these computations that have to get done. All those different weights are different multiplications that are happening. And they can happen in any order as long as the graph goes left to right. Okay? So this graph, when a GPU is executing this graph, remember, GPU has thousands of cores. So they're executing this graph in a highly parallelized way, executing many different branches simultaneously, and then collecting the results and moving forward. Okay? In this super parallelized computation, it doesn't really matter which branch goes first, which one goes second. I don't really care. All I care is that I got all the way to the end as fast as possible. Okay? That does not work if you're doing program verification. In program verification, you have to verify that these steps were followed in this order. And if you didn't follow this step in this order, then you have to go back and see, oh, okay, where did you get it wrong? Right? So you need a linearization of what is not a linear computation. This linearization is expensive. It means that you have to take a machine learning model and compile it into another format that can then be proven. And if you compile it down into this linearized format, now it's actually less efficient to run it on a GPU, because GPUs take advantage of that parallelism. And if you unroll everything into one long linear computation, then the GPU is not going to be as effective at running that linearized computation. So that's one problem with all these decentralized inference networks, is they have to adapt the model into a system that makes it provable. Okay, the second thing that's a problem with decentralized inference is that, okay, let's say we've got all these different nodes. Let's say you're all nodes in the network, and you all run Llama 70B to try to get the right answer about whether or not this thing, Llama 70B is not a classifier, but let's say you run ImageNet and you try to see, is this thing a bicycle? Okay? Well, the thing is, even if all of you are running the same model, you may get a different output. Why would you get a different output for the same model? The answer is, not all GPUs do the same thing. So a different GPU architecture might result in a slight change in the output of some matrix multiplication or something like that. Or even having a different version of CUDA. Having a different version, like not updating your OS basically, may mean that you end up getting a different result, which is kind of bullshit. So the same model does not necessarily mean the same result. So you have to fix, everyone in your network has to use the exact same model and the exact same architecture to make sure that they're actually getting the same output. So if you try to say, give me a picture of Sam Bankman-Fried, two people who are running the same model might get a different result because of pure randomness inside the model. The third thing is that floating points are cursed. I don't have time to talk about this, but floating points are not associative, meaning that if you add two floating points or multiply two floating points in a different order, you can get a different output. And that output can cascade over the course of an entire model. So this means that even the way that the cores are executing, the order in which the cores are executing all these parallelized computations, they may be slightly different on each run, even within the same architecture, within the same GPU. And if that's true, you may get a slightly different output. For an LLM, it might not make a difference. But for a classifier or a generative image, you might get slightly different pixel values because the outputs are slightly different because of these cascading floating point errors. So if you want to do this, you either have to avoid using floating points, which sucks, which is super, super slow on modern GPUs, or you need to allow some laxity in outputs because there's so much non-determinism in GPUs that in order to get two GPUs to agree, you've got to allow a small amount of error. So these are all these different implementation details that don't show up in normal programming verification, right? So if I'm doing a smart contract on Ethereum, these are not problems. Ethereum doesn't even have floating points because Ethereum knows that floating points are fucking crazy and you should never use them for financial applications. But in GPUs, floating points are all what machine learning does. So this is why this is really hard. I don't have time to talk about this, but one new promising area that many people are exploring are TEEs, or Trusted Execution Environments. The very newest generation of NVIDIA GPUs come with trusted execution environments on the device, which means that now you can do confidential computing inside of an H100, a B200. These are only the highest end models. Most people don't have these. And they're still very, very new, so there's not a lot of people using them yet. But I think these will be a new promising area for the next generation of protocols to potentially use TEEs to get some kind of verifiability or even confidentiality for decentralized compute. So, takeaways. Crypto AI is big, it's early, and it's really hard. There are a lot of problems to be solved here. It's not guaranteed that any of this is going to work or be useful, but it's a very interesting area and one that I encourage you all to keep a close eye on. So, that's it. Thank you.
Thank you. Big round of applause for Haseeb. Thank you so much for your amazing presentation. We all enjoyed it a lot. Thank you. Please be seated. So coming up next, let's welcome our next keynote speaker, Mr. Anthony Blackburn, Growth Head at Godzilla Games. Ladies and gentlemen, please join me in giving a round of applause for Anthony. Round of applause.
Okay. Hi, everybody. Good morning, GM. I think it's still, yeah, it's 11:54. GM, everybody. Hope you're having an excellent day so far. My name is Anthony. I am the growth lead at Gunzilla Games, and it'll be my pleasure to talk about Gunzilla and the way that we've decided to approach building our blockchain ecosystem designed for AAA gaming and the gamer experience. So a little bit about myself. I actually played esports professionally as a semi-pro for over a decade, either competing as a player or a coach. And my career started in Counter-Strike 1.6 back in 2007, 2006, and progressed through Counter-Strike Go and the Valorant series. Along the way, I've dabbled in a wide variety of games, but my bread and butter has always been with tactical shooters. And early on, there wasn't a lot of support from big tech like you see now and energy drink companies, and everybody competing at the top level accepted that they might not want to quit their day jobs. So many players, even back in the early 2000s, were already recognizing the potential of a digital economy underpinning these games and the potential value creation they could bring. I started in the Web3 space several years ago, primarily working with L1 and L2 blockchain ecosystems. Most recently, I worked with the SWE Foundation during its 0 to 1 phase last year, and also represented them as the partnerships lead. My experience working with ecosystems has offered me a thorough understanding of how ecosystems function, their priorities, and their unique go-to-market strategies. My fascination with the intersection of blockchain and gaming has always been there due to my gaming background, but I wasn't really convinced that anybody was seeing the full picture of what would be needed to bring big-time game studios into the mix until I met the Gunzilla Games team. So a little bit about Gunzilla. For those who aren't familiar with our ecosystem, I'm going to break down some of the moving parts. Overall, Gunzilla Games has over 260 team members across all of its appendages, and our team is spread across Frankfurt, London, Kiev, Los Angeles, and Vancouver. Our co-founders, I'm not going to go over all 266 people, I'll just go over our co-founders. The Gunzilla team is composed of the best and brightest visionaries, technical minds, and entrepreneurs to make this project happen. Vlad, our CEO, is a serial entrepreneur. He founded the biggest matchmaking app for gamers. It's called Plink, which currently has 16 million users and has generated over 100,000 matches between gamers. He also founded Blackwood Games, which is the developer of the AAA free-to-play shooter Warface, which amassed a whopping 150 million users and generated $1 billion in revenue. So as a founder, Vlad understands the deep desire that gamers have in finding their peers and fellow enthusiasts, as evidenced by his creation of Plink. And we strongly believe that creating an environment that fosters community, collaboration, and cooperation is the key to building a long-lasting community and a strong ecosystem. Alex, our other co-founder, previously worked as the CEO for Crytek Kiev. He did that for over a decade, and then co-founded Blackwood Games with Vlad. They both share the common trait of having a rich entrepreneurial background and have always created companies to solve a wide variety of challenges in the gaming industry. And with Gunzilla Games, they are looking at Web3 and how it can solve a lot of the critical components in the gaming industry. Last but not least, you might recognize that guy, Neil Blomkamp. He is the co-founder and chief visionary officer. He's an Oscar-nominated director, screenwriter, producer, best known for his production of District 9, Elysium, Chappie, and Gran Turismo. So, Gunzilla Games is much more than a studio, a game studio. Not only do we build incredible games, but we also are building the supporting infrastructure for it. So here on the screen, we have the two core platforms that we're currently working on. Off the Grid is a AAA game with Web3 mechanics and a blockchain underpinning. We'll talk a little bit more about Off the Grid later. And the other product is GunZ, our gaming-specific chain based on Avalanche. GunZ was specifically built as a blockchain platform for AAA games, something that hasn't really existed previously. So this is our thesis. So I present you Exhibit A, the self-operating napkin. So you have our gentleman here who has created a highly complex and advanced tool to allow for his hands-free operation of his napkin. I think we all recognize the brilliance of his innovation, but we also see that perhaps he is over-indexed on a solution that may be difficult to replicate, and we can assume that the onboarding process might pose some challenges for him. So we think that the gentleman probably could have just used his hands and picked up his napkin and wiped his spill himself. This is the way that we're looking at modern blockchains. The current selling proposition is having the highest TPS, efficiency, and security, and this is undisputable. This is the most important. These are the most important characteristics of a blockchain, and they need to be. But right now, most chains are building for a problem that doesn't exist. Having 100,000 TPS without any users or applications means that you've solved for one part of the equation, but you might be missing the other critical component. Having tier 1 applications in your ecosystem that can truly test the limits of your infrastructure. I'm going to play a video now.
Validators, are they taken care of well? Do they get a cut out of your fee?
Yeah, sure. They get looked after real good.
Okay.
Pretty cool, right? I actually have another video.
You actually, customize your own character. It's more like an RPG, more so.
Nice landing.
Okay, so that is off the grid. Get a little taste of our narrative campaign and our actual gameplay. This is our problem as defined by my previous slide. With a single high-quality application, our ecosystem will have more users and real on-chain activity than the majority of well-established ecosystems and chains have today. Off the Grid is a AAA next-gen battle royale extraction shooter positioned to be the first game ever supported by blockchain and Web3 mechanics on the PlayStation 5 and Xbox stores. We're delivering a blend of narrative and competitive third-person shooter experience on Unreal 5. This game has been in development for 5 years in the making, and from the early stages, blockchain was integral in the design philosophy of Off the Grid. You might be wondering why I'm talking about a video game during our L1, L2 segment, and why I didn't do this yesterday at our Games Day, but I will get to that now. The question becomes, how do we keep our users engaged as they jump from in-game to looking at the assets and the on-chain data? Introducing GunZ. So at the heart of Gunzilla Games innovation lies GunZ, an advanced layer 1 blockchain solution designed to revolutionize the gamer experience interacting with a blockchain by offering a beautiful UI and frictionless experience. GunZ was developed to address the limitations of traditional gaming systems and powers the economy within Off the Grid. We're empowering gamers with asset ownership where they have the freedom to buy, sell, trade, and use their assets as they see fit. We're building for the future, and because of our deep background in gaming, we understand what game developers and gamers want from a blockchain experience. We aim to extend our influence to other AAA games, showcasing the new era of enhanced player experiences across the gaming landscape. What makes us unique is that GunZ is a product-focused chain that optimizes for the best end-user experience, specifically gamers within the GunZ ecosystem. So, a few of our features, we have our hex cubes, our NFT validators, our visualized block scanner, our GunZ wallet, and our NFT marketplace. So, our wallet. Wallet creation is often a pain. Seed phrases are not something that is very Web2 friendly. So we're finally beginning to see innovations in account abstraction and friction reduction. Our wallet offers both features. A simple wallet solution that offers the ability to create a wallet instantly with email or simply by playing Off the Grid on any of our supported consoles. So what does that mean? It means that hundreds of millions of players that play off the grid, whether it's on console or PC, will all have a Gunzi wallet. So that is hundreds of millions of users embarking on their Web3 journey for the first time without even realizing it. And the best part about Gunzi is these players either have the ability to not interact with that experience but still enjoy the benefits of it, or they can choose to opt in and take advantage of all the benefits that we have within our infrastructure. Within the Gunzi wallet, you can look at your assets, connect to marketplaces, trade your NFTs, check your transfers, store gun tokens, and all of this can be done within our game platform. The next is our marketplace. So we did build our own in-app marketplace. So off the grid, you can actually trade directly within the game, which means our players can go directly from playing to trading in a snap. Now to some of our special on-chain assets that you can find within the Gunzi ecosystem. So hexes are our ecosystem's version of loot boxes, only we've designed them in a way that makes them much more flexible and valuable than typically seen in gaming ecosystems. Hexes can be extracted from playing off the grid or our other titles, and through a complete immersion and dedication to playing in our world, our players can feel both a sense of accomplishment and excitement that their experience of getting valuable assets was done without compromising the integrity of their playing experience. Hexes can be opened and offer a wide range of in-game assets, from robotic limbs to weapon skins that can be used either in-game or directly traded in our marketplace. The potential of hexes is quite extensive. So we could see a world where someday these cubes live in multiple worlds in the Gunzi ecosystem, farm them in one game, use them in another. Our hexes are also multi-chain compatible thanks to our integration with Layer 0. Shout out to the Layer 0 team. They were excellent working with us on Games Day yesterday, which we co-hosted with Hashkey. Special thanks to Kenny for showing up to and doing a keynote as well. Currently, we're discussing the potential of on-chain randomness for our hexes as well. We're always interested in pushing the limits of our blockchain design. So the next innovation that we bring to the table is our validator NFTs. Our validator NFTs are solving the issues of centralization on a network by having user-owned NFTs that facilitate transactions on the Gunzi network. NFT validators actively connect our active and our passive players in a way that's never been done before. So players in off the grid can earn hexes and weapons, and all trades, hex openings, and transactions happening on the network are supported by these NFT validators. So these validators get paid directly by the gamers for minting in-game items, meaning that our players support each other both passively and actively with their assets in a way that we haven't seen before. Last but not least, our visualized block scanner. So the thing that brings it all together for us is our visualized block scanner. So Gunzi's block scanner brings all of the assets, transactions, and people in the Gunzi ecosystem to life. So our entire blockchain experience, as I mentioned, is built to offer the best gamer experience, and that includes ensuring that when our user wants to see what's happening under the hood, even that is a rewarding experience. We don't want our users to check their trade and see a blank page with a bunch of numbers on it. We want that information there too, obviously, but we want to make it a little bit more exciting. So the block scanner reads each user's Gunzi wallet. It shows their profiles, if applicable, their assets, their images, and when you check any transaction that happens on the network, you can actually see what assets are being traded. If you're opening up a loot box, you can basically see that loot box, the item that is minted, and you can also see the PFPs of the people involved. So for every single transaction, you get to see, you get to put a face to that transaction and that occurrence happening on our chain. A final note. So for anybody who is interested in exploring testing our chain or our ecosystem, our off-the-grid game will be launching very soon. Can't say when exactly, but all I can say is very soon. But we do have a testing environment called Technocore. It's a drone extraction game, very simple, where you can actually extract assets that can be playable in off-the-grid. So if you would like to get involved in our ecosystem and ahead of the main game launch, you can go check out Technocore on iPhone or on the iPhone or Android stores. Thank you, everybody, for listening. Thank you to the Hashkey team. It was incredible hosting Games Day yesterday and shedding more light on how we view the future of Web3 gaming and the innovations in the space. Feel free to scan the QR code if you want to learn more about our platforms. You can find us at Gunzilla Games on Twitter or at Play Off the Grid. Our Gunzy Twitter is at GunByGunzy. And if you're interested in chatting more about Gunzilla or the things that we're doing, you can find me or some of our teammates at the Gunzilla booth over at E13. And you can find me on Twitter at 0xClablegs if you have any questions. Thank you.
Thank you. Big round of applause for Anthony. Thank you so much. Thank you for your engaging presentations. We enjoyed a lot. Thank you. Now, ladies and gentlemen, let's welcome our next keynote speaker, Mr. Kai Xu, COO of Meet48. He's going to share with us the topic, Democratized Entertainment. So without further ado, let's give him a big round of applause.
I love that music. So I guess it's still good morning, everyone. My name is Kai. I'm with Project Meet48. I'm very excited to be here. It's our first time title sponsoring this amazing event, and we met a lot of really great people here. So Meet48, we are very new on the scene. Many of our founders are from traditional mainstream entertainment. So we know that part very well. And what we're doing is bringing Web 2 and Web 3 together through democratized entertainment and do our part for the mass adoption of Web 3. So this is a very big theme, and our contribution to realizing this grand vision is to focus on the idle fan community. So we think they would be the most receptive to the concepts of user ownership, community consensus, and active participation, as these core characteristics of Web3 are reflected in the traditional idle cultivation experience. So our goal is to adapt the traditional Web2 model into Web3, encourage greater participation by providing an AI tool that would allow people who are interested to create their own virtual idols, and also take part in the idol economy through UGC content creation. So for most people who are unfamiliar with idol cultivation entertainment, it's kind of difficult to get a feel for the experience. So I've actually prepared a video to help everybody get a sense of what that's about. So if we could play that video.
得票数23,752.7票，去进玉，恭喜鞠婧祎。
得票数40,240.4票，
它是来自于 SNH48。
得票总数353,3525票，恭喜孙瑞，
恭喜孙瑞。
All right, so that's what we used to do. Our team at Meet48 came from a background of Web 2 and live entertainment. And we have 10 years experience in the idol fan community. We managed over 200 talents. It generates over $250 million a year. And we are convinced that what is possible in terms of value creation in Web 2 is only a drop in the bucket for what we can achieve in Web3. There is incredible potential in Web3 that can revolutionize traditional entertainment, especially in the idol entertainment industry. And the idol fan community is the perfect group for Web3 adoption. Let me explain that in detail. So first of all, idol cultivation, for the aspiring idols, there is a low barrier of entry. It's entirely open to the public with no experience required. What's more important than their ability to sing and dance is how they're able to build rapport with their fans. And for the fans, they're able to be part of the idol's entire career, from trainee to full-fledged performer. So they provide support emotionally, spiritually, and financially. So they are fan and patron. And this time that they have together through different growth stages form the core of the cultivation experience. And over time, fans develop a sense of ownership over the fan-idol relationship. It's process as product. The purpose of the idol cultivation process is to create a positive feedback loop in terms of community growth and engaging experiences. So it initially starts when the idol is debuted and a small group of fans begin to establish a group identity. So this usually happens when they create a nickname for themselves. And next, the fans help their idols take part in various competitions and activities by voting to show support. Because it's a long process over many years, they invest increasingly more time and energy and money into these tasks. And then the stronger the bond they form. Idols with a large fan club generate a lot of revenue. And this revenue is invested back into the careers of these idols in the form of TV shows, music videos, concerts, and events. The media exposure would help to increase the market value of the idols and give them greater reach into mainstream markets. And their success reinforces the fan club's consensus. So the more famous they get, the more fans they attract to join the community, which then gives the early followers OG status and bragging rights, since they would have much more personal relationship from the fans for supporting them over the years. And that is the greatest experience in idol cultivation. The idol voting events are one of the biggest sources of revenue for idol entertainment. Voting for their idol is the single greatest gesture of support a fan can make. But voting isn't free. In fact, it's quite expensive. So not only do fans have to have the heart, but they need to have deep pockets as well. It becomes a self-propelling system. Fan clubs that vote to get their idols up on the rankings are motivated to keep them there. And at the same time, other fan clubs will be competing to climb the rankings. So this game is the pillar that supports the idol cultivation economy and one of the primary activities that we believe can make a smooth transition into Web3. So with the three core aspects of idol cultivation being user ownership, community consensus, and active participation, we can see that there is strong congruency between the idol fan community and Web3 users. But the million-dollar question is, how willing are they to come to Web3? Does supporting their idols provide strong enough motivation? And to answer that question, we conducted a little experiment. And things get pretty exciting. We created a dApp. The Meet 48 community dApp is designed to help the fan community familiarize themselves with Web3 in incremental steps. We've got a wallet system, we've got daily tasks that reward points, a watch to mine system for uploaded videos, and a points market where they can trade in points for votes. The fans would then cast their votes for their idols to determine who gets to take part in special events. For example, this Hashkey Web3 festival, we let the fans decide through votes which 7 idols out of 250 total would be able to come here as performing guests. Now, we let the event run for 2 weeks, and the results were actually beyond our expectation. Over the 2-week voting period, we had more than 1 million registered users and over 1 million crypto wallet creations. And our DAU steadied at over 50,000, and average user time spent per day was over 30 minutes. So in total, over 5 million on-chain votes were cast, and the fan community started to share their experience online over social media. There was an explosion of activity in the various fan chat groups, and it had the beginnings of a meme-like effect. The fans were sharing pictures and stories of how they were mining, how they were earning points in the hospital, waking up at ungodly hours to watch mine to complete mine to watch to mine tasks before point pools were depleted. And in the end, for the fans of the 7 idols that made the cut, it was all worth it. And they actually thanked Meat48 for the opportunity to support the idols. And these idols are actually here today. And in less than an hour, they will be performing at the open stage. So if you have time, you should check out their performance. And please keep in mind that behind the performance are hundreds of thousands of hours of fan dedication and love from their community. The result is proof to us that what we're doing, that we're going down the right path, and that we can be ambitious. We can revolutionize the entertainment industry and improve the overall experience through Web3, especially with AI and user-generated content. And up to now, there's always been a company that's in between the idols and the fans. It's the role of the traditional talent management company. But we can change that. We can move the idol cultivation process into Web3 and cut out the middleman. We can let the fans create their own DAOs that will shape the career paths of the idols they support. We can tokenize the voting process, and we can lower the barriers to entry for participants so that everyone can experience the idol cultivation process by giving them the ability to create virtual idols. And we can reward creators equitably for their UGC contributions. We view AI as a great tool to make idol entertainment more accessible to the masses. And now it's possible to provide consumer-level virtual idol creation tools that's affordable and easy to use. IdolGPT is our proprietary AI tool for virtual idol creation. It also creates music, song, and dance choreography, and it's made possible through AI learning. We've created our own LLM system by feeding it over 100,000 video recordings of idols' live performances. And users from around the world would be able to team up and form idol groups and create their own virtual idol performances and upload it to our UGC virtual content short video platform. We've also modeled different AI personalities based on over 250 idols that we have rights to, so fans can choose an AI companion and have conversations with virtual versions of their favorite idols. And as we shift the experience into Web3, we will be releasing our first GameFi app, Pick48. It combines idol creation with GameFi mechanics. Players and fans will be able to earn tokens by completing actions that show support for their idols, both virtual and real. And we're collaborating with some of the top traditional entertainment media companies in Southeast Asia to create idol competitions where viewers can watch the shows on TV or on streaming, and also have the competition results be determined by the user activities on the dApp. And we're confident that the incentives Web3 can provide, coupled with the mass appeal and reach of traditional Web2 entertainment, would allow us to attract a large number of users from Web 2 into Web 3. And it's a new entertainment format that's scalable in different language markets, and it's never been done before, and we're very excited about it. We're bringing the idle voting mechanism into Web 3, and the fan community can vote through our token, which would give a value, and that value will allow us to create greater incentives for fan migration and integration of Web 2 and Web 3 communities. So idle cultivation is a start, and the fan community helps us to get the ball rolling. What more can we offer is really a question that requires you guys to help us answer, because Web3 is a group effort, and for anyone who is interested in our project in Meet 48, please feel free to reach out. You could come to our booth. It's quite big, and meet our team, and let's work towards mass adoption together. And before I just step off, remember to check out our idle performance at the open stage at 1 p.m. Thank you.
Thank you, Kai. A big round of applause for Kai. A fabulous presentation on democratized entertainment and mass adoption. Thank you so much. Please be seated. So moving on, we're going to delve into another topic, why AI needs Web3. So without further ado, let's welcome Mr. Amos Zhang, early contributor at Near and founder at MetaWeb Ventures, and also Elia Polosokin, co-founder Near Protocol. So ladies and gentlemen, let's give them a round of applause.
大家好，今天呢非常荣幸呢再次来到香港为 Near 的 founder Elia 做一个 opening。那今天呢会为大家分享Near 最近的一些发展的计划以及在 AI 上的一些动作。先简单的介绍一下我自己，我叫 Amos， 是 Near 的早期创始团队成员之一，也是之前的 CMO 和这个亚太区负责人。那现在呢，除了在继续为 Near 的生态做贡献呢，也是 MetaWeb VC 的创始人。我们是一个3000万美元规模的早期 crypto 风投，我们背后的投资人有红杉，有刚才分享过的那个 Dragonfly，还有 SNZ 等等。那也介绍一下 Near 的2位主要创始人。Elia 呢是 Near 的这个 CEO。他呢在做 Near 之前呢，其实有非常深厚的这个 AI 背景。他曾经是 Google 的这个 Research 的 Machine Learning 的研发负责人。然后当年呢写过一篇 paper 叫 Attention is all you need。那这个 paper 呢，其实呢就是开创了现代 AI 的这样的一个开山作吧。然后包括整个 ChatGPT 都是基于这个 paper 来研发出来的。包括他最近呢也跟这个詹森黄在 NVIDIA 的这个大会做了一些关于 AI 和区块链之间的这个分享。同时呢，他也是 Google 之前的这个 AI framework TensorFlow 最大的这个贡献者。Near 的另一位创始人呢 ，Alex 呢，他也有非常深厚的这个技术和这个 AI 方面的这个背景。他曾经呢是 Microsoft 的一个研发主管，然后也做了这个 MemSQL 的第一个 engineer。那 MemSQL 呢，其实是世界上很多大公司，比如 Uber、比如高盛比如三星等等背后用的这个分布式数据库。同时呢，他也获得过这个 ACM ICPC 2008年的这个全球金牌。简单的介绍一下 Near。Near 呢，从比较简单来说，高度来讲，它是一个公链。那具体呢，它有3个特点。首先呢 ，Near 有非常强的这个性能。它现在应该是世界上性能最强的公链。主要是通过这个 Nightshade Sharding 这个分片的技术来进行平行的处理。同时呢 ，Near 是现在世界上所有公链、所有区块链用户数最多的一条链。每天呢，现在是大概有200-300万，甚至多的时候500-600万的这个日活。比它下面的3条链就从第2到第4条链加起来的这个 DAU 都要多。同时呢 ，Near 现在也在这个主推 Chain Abstraction，就是链抽象的概念。链抽象的意思呢，就是说你只要用一个 Near 的账户，就可以同时控制你以太坊、控制比特币、控制 Solana、控制 XRP、控制 Dogecoin、控制所有的其他区块链上的这个账户，也不需要进行一些传统的这样通过桥的方式进行跨链的一些操作。 同时呢，NEAR 呢，现在也是这个模块化区块链的领头羊。它现在主要做的就是这个 data availability 啊，那包括有一些竞争者，包括还有像 TIA 啊，就 Celestia 都是一些很火的项目。那如果你现在用 NEAR 来做 DA 的话，你是要比以太坊便宜大概8000倍。那最后呢，也介绍一下 NEAR 背后的一些支持者。包括这个 Pantera， 包括 Terra Global， 包括 Dragonfly、ACNZ 等等。那在中国这边呢，有百度风投包括韩国的 Hash， 都是一些区块链这里非常知名的一些 VC。好的，那我对大家的这个简单的介绍呢，就到此为止那之后呢，就由这个伊利亚在线上呢，为大家进行一个关于 AI 和 NEAR 之间结合的一个分享。
Hello everyone, I'm Ilya, co-founder of NEAR, and today we're going to talk about why AI needs Web3. So the origin story of NEAR is actually in AI. And before starting on the startup journey, I worked at Google Research, focusing on natural language understanding, as well as being one of the major contributors to TensorFlow framework, deep learning framework from Google. Now with a group of colleagues, we have created the first model called Transformers that has led to major innovation that we see right now driving AI. And this is the T in GPT. I left Google to start NEAR as an AI startup. We were teaching machines to code. And one of our approaches was actually doing a lot of data labeling, having students to create data for us. And we faced the problem of paying them, given it was a global workforce, and some of them didn't even have bank accounts. We started digging into blockchain as a way to solve this and realized that there's nothing that matched our needs, which were scalable, low fee, and easy to use, easy to onboard new people. And this is when NEAR protocol started. Now, for those who are not familiar, language models is not a new thing. This existed since 1950s, and it was a general statistical model that allowed to model language and use it in various applications. Now, for me, the really interesting innovation happened in 2013 when word embeddings were introduced. And this is the idea that we can go from a symbol, like New York, to a vector in a multidimensional space that now you can do math with. And this works really well with deep learning models that are just a lot of matrix multiplications and activation functions. Now, after 2013, this is where I joined Google in the beginning of 2014, the predominant model that was used in research was recurrent neural network, which has a very similar approach to how humans read one word at a time. Now, that has a massive limitations because if you want to read multiple documents to answer a question, you will have a pretty large latency, which is not feasible for using in production on Google.com. And so transformers were really born from our own challenges with recurrent neural networks. And we're really about trying to leverage the parallelism in computation that existed in the modern hardware, and especially in GPUs, to pretty much consume the whole document and try to understand it at the same time without having this kind of one step at a time bottlenecked. Now, what this allows to do after we introduce a model for OpenAI team to really scale it and pre-train it on immensely large corpus. And this led to major innovations we see today with ChatGPT, Gemini, and other models. Now, we see a major innovations happening with AI, and this is accelerating, right? These models are able to do basic reasoning, they have common sense, and we see people continue pushing the envelope of what's possible with these models. And I think importantly, where before with any machine learning, data science, there was a person who was interpreting results, right? You would get a bunch of tables, some analysis, and there was a person, a data scientist, for example, a machine learning engineer, who was interpreting results and really integrating it into a product or providing business decisions. What's interesting now with language models, with large language models, is that they are able to communicate with people directly, and they're able to kind of interact with other applications and tools. And so now we have something that's kind of bypassing potentially a person in between to interpret it. Now, for those who are not familiar, when we talk about these models being trained on GPUs or used, this is not your gamer GPU or even mining GPU for crypto. This is a specialized, pretty much supercomputers. Usually you have 8 of the GPUs in one machine that have a massive kind of computational capacity. And then these machines are stacked in racks. And then these racks are pretty much deployed in data center. And you train reasonably large models now, for example, Grok, on something like 10,000 H100s for 3 months. And this is about, renting that will cost you $64 million. Now, even more importantly, beyond the compute itself is the connectivity. So one of the important parts here is that the A100s, especially H100s, are connected by 900 gigabyte per second connectivity. So for reference, your CPU to RAM connecting at 9 gigabyte per second. So this is actually faster to move data between 2 nodes, 2 GPUs in a rack in a data center than to actually move data from a GPU to CPU. And especially now we saw this Blackwell, there's a promise of doubling that to 1800 gigabyte per second. So it's insane speed that this hardware connects. And what it allows to do really is not think about these devices as separate devices, because they, from a programmer perspective, feel like a single operation. Now, there's a lot of caveats around that when you're building systems at scale, but the idea is really that these are highly connected devices, and kind of normal connectivity on local networks is 100 megabyte per second, so somewhere 10,000 times slower than this. Now, because of this kind of requirement for training, what we see now is that we have a rise of closed AI models. And even if the model weights are open source, we still don't actually know what went into the model. And it's important because these models are really about learning bias from the data. The kind of joke is that models are really just weights and biases, and that's just how models are represented. Now, there's a number of teams that, beyond just engineers, that go and decide what goes into the model by modifying data set, deciding that some content should not be in data for whatever reason, and then after model is produced as well, post-processing it and changing system prompt to decide what actually this model will inference. And especially dangerous is that we don't actually know how exactly this model was produced, because there's a potential for example, auctioning tokens to highest bidder, pretty much running ads directly in the output of the model. And we see kind of as well a massive backlash and legal battles that are rolling out because of everything from usage of data to how these models produce results to pretty much the power that these companies have over distribution platforms as they are making them kind of on the background reading the content, and the model itself becomes the distribution platform. We have massive risks that coming from this. Obviously, the regulators are trying to keep this under control, figuring out how to limit access for bad actors, and in turn actually making it harder for open models and decentralized approaches to exist. The open source doesn't have enough kind of financial motivation, so what leads to is companies who potentially start with open source, then limit open sourcing their models as they're trying to monetize to gain more capital to buy compute to train a bigger model. there is currently no way to have a clear kind of understanding when people are misled, right? And again, generative AI here is becoming a tool to manipulate people at scale. And the economics of big companies always leads to skewed incentive, right? After you have achieved your target market share, you are, to continue showing growth in revenue, you need to increase average revenue per user. And so you need to pretty much extract more value from users. This is all the case for open source AI, using Web3 as a tool to kind of incentivize it, to create opportunity for people, as well as to create enough resources, compute, and data in the open for people to actually build competitive models. Now, there's a whole stack of AI tools that needs to happen in Web3 for this to come together. I'll cover a few pieces of this on data, infra, and app side, but obviously there's a lot more, and tune in for more conversations at other talks. So one of the important pieces is that because these language models are able now to interact with society directly, they're able to pretty much manipulate and obviously create fake information across the whole broad spectrum. Now, I want to point out that the AI is not a problem here, because these types of things existed before, right? And I have a picture here of just photoshopped images. And the important part is we need to leverage cryptography and on-chain reputation to combat that. So it's not about that AI generated this or human generated this. It's about who published it, what is the provenance of this, and what are the comments from the community that are actually important, right? So community notes, as well as cryptographic provenance. And ideally, this is available everywhere on the internet, integrated across everything. The other side is we now have agents, and we're calling everything an agent. But the reality is there's a pretty big diversity here of things, right? There can be tools or autonomous agents, and this can be centralized or decentralized. For example, ChatGPT is a centralized tool versus the Llama models are open source, and so they can be used centralized or decentralized. You can also have decentralized models just running on user devices without, having, for example, blockchain or anything like that. Because if you run a model on your device, you have the guarantees that it is doing exactly what you expect. And there's a fully autonomous, decentralized, for example, AI governance that requires, verification and as it, for example, distributes money and makes important decisions. So I kind of provide agent types, so it's easier to kind of describe, for example, when people are working on something. There's different types of specialization. So this is prompt, where you for example, zero shot, teaching the LLM to respond in a specific way. You can fine tune with specific data to add more knowledge to the model, or you can do retrieval augmentation to add kind of in-context information when user requests. The output also doesn't need to be just text. It can be a rich UI component, as well as it can be a direct action, right, actually doing something on blockchain. And autonomy-wise, it can be a tool that is doing what you want. It can be something that writes its own plan and executes on it. It can be a continuous job that you just specify a goal, or it can be a reinforcement learning optimization where you just specify a metric that you want and kind of set a criteria and boundaries, and you let the model continuously explore and find ways to grow that. And finally, infrastructure, you can have centralized infrastructure like OpenAI and Grok. You can have a local model, which is distributed, and you can have a decentralized inference with probability. Now, there's a really interesting use case where we move away from just programmable money to intelligent assets. And this is where the asset behavior is defined by natural language and potentially can interact with real world or with interaction with other users. Now, this can use, for example, natural language oracle that reads news. It can be automatically optimizing strategies based on what's going on. The biggest caveat here is that current language models are not robust to adversarial behavior, and so it's really easy to convince them in various things. So there's a lot more here. I will not go into too much detail, but I want to just leave you with this idea that we have a kind of closed AI world on one side, and it will lead to more manipulation. And the sad part, the kind of regulatory decisions are usually will lead to that because regulators will require more and more oversight and more KYC and more requirements. And so only big companies are able to satisfy that. And startups, especially startups that are trying to do open source, will not have resources to actually compete and will be dying and getting acquired by big companies. And we're starting to see that happening. Or when you're in an alternative world where we actually have open models, we have commitment and ability to execute this from pretty much kind of nonprofit and open source mindset side, and we use crypto economic incentives to create opportunity and resources that are required to have competitive open source AI models. And so obviously as Near, we strive to do that, as well as through the whole ecosystem, we're working to enable this. So yeah, as Near, we'll have more updates in kind of coming weeks. And yeah, follow me on Twitter and X and Near Social for more updates. Thank you.
Thank you. Big round of applause for Ilya and Amos for the insightful sharing and brilliant presentation. Thank you so much, gentlemen. So ladies and gentlemen, up next, let's welcome our next keynote speaker. Ladies and gentlemen, let's welcome Mr. Max Rebel, CEO and Managing Partner at Harbor Industrial Capital, to talk about the future of Polkadot 2.0. So without further ado, please join me in welcoming Max.
Hello. Good morning, everyone. My name is Max, and I am here to talk about Polkadot 2.0, what we can expect from the roadmap on Polkadot. Now, before I dive in to what I have to say today, who are we and why the hell are we talking about Polkadot? Well, I'm running Harbor Industrial Capital together with my co-founder, Mario, who's also over there. We're a Hong Kong-based fund, and we're like a general Web3 VC, I would say. But we do have a very heavy focus on the Polkadot ecosystem. That's why I decided that today is a good time to talk my book. We're going to talk about Polkadot, about the Polkadot ecosystem, and all the exciting things that are happening there right now. All right, so this is our agenda. I'm going to give a little bit of a tech update, and here, yes, it does get quite techy. We have these funny acronyms like Core Time, Core Jam, and Beefy. I'm going to try my best to explain what that actually means in the short time that I have. And then afterwards, we're going to dive into a little bit of new narratives. Deep in, one thing that everyone seems to be talking about here, the DAO economy and gaming. All right. So, why the changes? Polkadot 1.0 has been fully rolled out, and it has delivered, right? It's been on time. It can do what it was expected to do, and it's overall like a great success. A timely rollout, no major issues. It works as intended. So, why do we need to change anything? Well, a good point to go back to is Copenhagen, where Gavin Wood gave a presentation on the roadmap of Polkadot ahead. And one way that I would summarize that is Polkadot 1.0 worked as intended, but one of the issues is user adoption and developers moving to the platform because of perceived or real barriers to entry. So I think one of the things, one way you can think about what 2.0 does is it makes it easier for people to get onto Polkadot. And that's like a great segue into exactly what I want to talk about next, the first major tech update, which is the change from parachain auctions to agile core time. Now for us as a VC fund, this is actually a pretty significant change, because at Harbor Industrial Capital, we have been very actively supporting projects win a parachain slot. We roughly supported 20 projects so far. We're putting down a dot deposit for them to get the computational resources that are required to become a Polkadot parachain, and we will take some of their tokens in return. Now, this is a great model, in my opinion, because it effectively and efficiently allocates resources on the Polkadot blockchain, on the relay chain. So it did its job, I would say, especially in those early stages, in the first iteration. But one of the issues with those parachain auctions, and that's something that I heard about quite often, is that people were saying, well, if I want to build on Polkadot, I have to win a parachain auction first. So perceived and real barrier to entries are there. For the projects that came on board, it worked very well because they got the block space that they needed to run efficiently, low gas fees, very high, very fast transaction throughput. For the projects that are not there yet, it was always a bit of a barrier to entry. And that's why one of the major changes of Polkadot 2.0 is the change to agile core time. So what that essentially means is it affords the ability to anyone coming to Polkadot to build to get computational resources as they need it, right? That's why the word agile is there. So if you're a startup, if you're a tinkerer, if you just want to quickly try out a new code, great, right? You can come to Polkadot, try it out. It works. You have the full security of Polkadot. And as the app becomes more advanced, acquires more users, you can, in an agile way, scale it up, right? So that's a very important change. All right, the second key feature of Polkadot 2.0 is this thing called Core Jam. So this is a pretty interesting one. It's a highly complex technical topic. Let me try my best to break it down. What Core Jam essentially is efficiency improvement by arguably an order of magnitude in the way that the relay chain of Polkadot handles transactions. The whole idea is to make the relay chain as lightweight as possible and offload all the other things that are not core to the relay chain to other system parachains. So again, fairly complicated thing, but what it really does is it increases potential scalability by, literally orders of magnitudes. So with this being rolled out, you can build applications on Polkadot that would be impossible to build on the current version of it, and frankly speaking, also on any other blockchain ecosystem. One good summary that I have heard is Core Jam turns Polkadot into a decentralized supercomputer. All right, and the third tech update that I want to talk about is the beefy bridge. So what this cute pinkish cow here represents is the bridge efficiency enabling finality yielder. So again, that's quite a mouthful, bit of a complicated technical topic, but what it does is really, really powerful. So beefy isn't a bridge in itself, but it's a change to the finality consensus mechanism of Polkadot, supplementing Grandpa, which is the current finality mechanism. And the amazing thing about it is that it is much more bridge-friendly. So what first drove me into the Polkadot ecosystem is this idea of security and interoperability, right? The ability that you can seamlessly move in and out of Polkadot into other ecosystems, and that this is secure, and that there is no risk of bridge hacks, right? You can have all the fancy applications, gaming, NFT. If bridges are insecure and you're moving value in and out, then there's a massive risk of a bridge hack. This is not like a hypothetical scenario. This has happened in the past. Bridge hacks are scary, right? And they can destroy an entire ecosystem. So focusing on bridge security first is, in my opinion, one of the most important things ever that you can do, because you're not going to be on one single chain. You wanna be able to move in and out, but you want to make sure that this is secure. So with this beefy upgrade that is currently underway, we're going to have 3 major new bridges that are non-custodial and completely trustless, and I think this is an incredible, powerful new narrative. So Kusama Polkadot Bridge is going to be one of the first ones, Kusama being the incentivized testnet of Polkadot. So that's really important. Snowbridge also has been in the making for a long time, but we're really getting there now, is a trustless bridge over to the Ethereum ecosystem. And Hyperbridge bridges from Polkadot to the Ethereum L2s, and potentially also to the Ethereum main chain. In fact, quick shout out to Sean from Hyperbridge, who's here with us today. In fact, I think he is giving another presentation on Hyperbridge on a different stage as we speak. All right, so this is kind of my tech update. What does that really mean? I think it kind of enables a bunch of new narratives that I am super excited about, and I want to run through them. And before I start, I want to say this is a non-comprehensive list that I'm going to show you here of some projects that I like, but by no means it's a finite list. All right, first thing is DePIN. Now, it seems like everyone here at this conference loves to talk about DePIN. It's kind of one of those new narratives that everyone is excited at the moment. The point that I want to make on stage here today is that DePIN is nothing new for Polkadot. So we've been building DePIN projects for a really long time, decentralized physical infrastructure. But now this kind of has a new name, and so we're also using the term DePIN. But again, this is nothing new. These are projects that came to Polkadot because of the scalability, the interoperability, and the security that it affords. But again, it's not a new project. It just fits really nicely into this new narrative that I'm personally also super bullish on. So what are some examples? I want to give one shout out to Acrest. They're also here with us today. They're building this decentralized serverless cloud, allowing anyone to turn their phone into a piece of this decentralized cloud. Really powerful, and allow people to get rewarded for that. The other Polkadot-based project that I also want to give a shout out to is Peak Network. They have been a Polkadot parachain already for quite a while. They're really writing this DePIN narrative. They're working with traditional companies like Airbus, Denso, Continental, eLoop, and many more to essentially bring this decentralized infrastructure to the masses. Again, very powerful narrative. I really like it. I think we're going to see much more from them. Another narrative that I would like to talk about is the DAO economy. So quick shout out to InfArch. The founder, Dakota, is here with us today as well. So what they are building is this multi-chain, multi-sig that enables a unified account solution across all different crypto ecosystems. Again, something that's been dearly missing, super powerful. It does enable this new DAO economy. And they come up with this new concept of DAO staking, which I really like. So it just enables, it makes it really easy for anyone to run a DAO. And anyone that could be, a school board deciding on what curriculum to teach, or an investment DAO where people get together and talk about investment opportunities from across the world. So they're building on Polkadot. And, I like to think of Polkadot itself as the world's largest DAO. So if you think about all the things that are going on OpenGov, it's a super active DAO, right? Every dot holder has one vote. They can jointly decide on the future of Polkadot. And that's why I kind of think the world has a thing or two to learn in terms of DAO management and OpenGov from the way it's done on Polkadot. All right, and the last narrative that I briefly want to touch on is gaming. So we just had a big announcement. Mythical Games is moving to Polkadot. In fact, their CEO, Aaron, is with us today as well. So a quick shout out here. He had a presentation yesterday on the substage. So we're super, super excited to have Mythical Games coming to the Polkadot ecosystem. They've been building Web3 games in different ecosystems. Their biggest game, I believe, is NFL Rivals, with millions of active players and like a few $1 million of daily active NFT trading volume. So it's one of the most active one of the most active gaming chains out there. And so yeah, we're super excited to see that these guys decided to come over to Polkadot. Again, why did they come? I would argue it's because of the security, the interoperability, and the scalability that Polkadot affords. I'm pretty sure we're going to see many more of these kind of players coming to Polkadot as the whole 2.0 roadmap is getting rolled out. Okay, that brings me to the end. Is dot dead, as one recent meme would ask it? My answer is clearly no, but I guess everyone will have to judge for themselves. So with that, thank you very much, and I'll talk to you soon.
Thank you, Max. A big round of applause for him. Thank you so much for the brilliant presentation. Thank you. Please be seated. So, distinguished guests, ladies and gentlemen, this will be the end of the morning session of Layer 1 plus Layer 2 Forum of the Hong Kong Web3 Festival 2024. So a big thank you again to all our speakers for the insightful sharing and the professional sharing with all of us. And also, I would like to extend a sincere gratitude towards all participants and audience here today for your great participation and also active engagement. Thank you so much for your great support. Also, thank you so much for your interest in our Layer 1 forum hosted by Wangxiang Blockchain Labs and Hashkey Group, co-organized by W3Me. And in the afternoon, we will have founders and experts from top-level Layer 2 projects to share with us more interesting content. So please stay tuned. Meanwhile, do have a fabulous afternoon and do mingle with the amazing people around you. And we'll see you again back at 2 p.m. in the afternoon. Thank you so much. See you all soon. Distinguished guests, ladies and gentlemen, good afternoon. A very warm welcome to Layer 1 plus Layer 2 Forum of the Hong Kong Web3 Festival 2024, hosted by Wanxiang Blockchain Labs and Hashkey Group, organized by W3Me and co-organized by SNZ Capital. I'm Jasmine, I'm the MC for today's event, and I'm very excited to spend the afternoon with all of you here. Layer 2 solutions or roll-ups represent a pivotal advancement in blockchain technology, offering a scalable and efficient path forward for Ethereum and beyond. These innovations are the result of collective efforts and visionary leadership within our community, including contributions from pioneers like Ethereum's founder, Vitalik Buterin. Last year, we convened here to discuss the potential and challenges of Layer 2 ecosystem. Since then, we have seen remarkable progress and adoption spurred on by significant developments that have made these solutions more attractive and accessible than ever before. Today, ladies and gentlemen, we are here to build on these discussions, to share insights, and to envision the future together. We stand at the threshold of a new era in blockchain technology, and I'm excited to explore what lies ahead with all of you here. Let's dive into the possibilities, the innovations, and the collaborative efforts that will drive us forward. And also, ladies and gentlemen, please allow me to extend our sincere gratitude towards all our title sponsors of Hong Kong Web3 Festival 2024. They are DWF Labs, Internet Computer, Meet48, OKX Web3, TON, and ZA Bank. Also, a big thank you to Cyberport, InvestHK, and HKTDC for supporting this event as strategic partners. So now, ladies and gentlemen, without further ado, let's give the floor to distinguished speakers today. They are important leaders, investors, and observers of the Layer 2 track of the Web3 industry. First of all, let's welcome Ali Ben Sasson, CEO and co-founder at Starknet, to deliver a keynote speech. Without further ado, please join me in welcoming Ali on stage. Big round of applause, please.
Thank you everyone. It's great to be here and connect more with the amazing developer and user community that's out here in Asia. And I want to tell you a little bit about our vision and where we're heading. So I want to tell you a little bit about the uniqueness of Starknet and how this uniqueness of vision and accomplishments and ecosystem will translate into things that you will find only on Starknet and nowhere else, okay? And then I want to tell you a little bit about how it will display itself in the UX and UI and in scale. So let's first of all talk about what is unique about the vision of Starknet. So let me start by saying that the uniqueness of the vision of Starknet is already being accepted on the ground by the developer community. So, for instance, according to the report of Electric Coin Capital on developer adoption, you can see that Starknet has the most fast-growing developer ecosystem. By the way, a lot of it is coming from this area, from mainland China, from Hong Kong, from Vietnam, Singapore, these areas, and we're very proud of that. And why is this coming? So we have a unique next-generation system, including programming language that is safe and ergonomic, called Cairo. And for instance, if you ask Moody Salem, who is a core developer of the Uniswap v3 protocol and has now moved to build a Kubo on Starknet, he says, as someone who has never written any Rust, I picked up Cairo in a few weeks, and I'm as efficient in writing Cairo code contracts as Solidity. It will be my preferred environment for writing smart contracts. So that's what he has to say about this new environment. And he has already written in a short number of months with a very small team, an AMM that is one of the hottest and best applications currently on Starknet. To take another quote, Itamar Le Suisse from the Argent wallet says that Starknet's ecosystem feels like Ethereum in the early days. It attracts the best talent in the space with its decentralized approach to development and innovation. So let me tell you a little bit about what it means to have trailblazing vision, at least according to our interpretation of the term. So it's about innovating, not copying. It's about not fearing progress and embracing criticism and adopting to it. And it's about staying true to the vision with no shortcuts. So let me explain a little bit what I mean about this. So today, everyone agrees that ZK proof systems are the end game and the way to solve scaling on blockchain. But I'm not sure many of you know, but the person to first talk about this and suggest it as a means for solving scale and privacy on Bitcoin was me in roughly 11 years ago at a conference in San Jose in 2013. So here's a list of things that by now everyone accepts, and each one of them was innovative at the time, and each one of them was first brought to the world in research, but then also in products by Starkware, through first its layer 2, the StarkX system, and then on Starknet. So ZK as the end game for scale and for privacy on blockchain, we were the first, I was the first to talk about this. Starks is the best scaling technology. By now, all of the layer 2s that are building scale on blockchain use as their scaling engine Starks. When we came out with it, everyone was dubious whether this is the route, but it is the thing adopted by everyone today, by the Polygon teams, by ZK Sync, by many others. Validity rollups is the end game for scale. Validium and data availability, these are things we innovated and then everyone picked up. So we innovate, we do not copy, which is also why we came up with a new programming environment that is ergonomic, Rust-inspired, next-generation programming language for smart contracts. We innovate, we do not copy. Now, with each one of these suggestions, when we came out, there was a lot of pushback from many important people who said, this is not the way to go, it won't work. When we believe in something and we come to a deep conviction in it, we move forward. And what happens is that often it's been shown that with time, the world adapts and accepts that this is the best way to go forward. So I guess what I'm saying is there are a lot of trends in crypto. It's a very trendy and speculative space. And one way in which we're different is we try to focus on fundamentals and things that will stay around for a while, and we do not compromise on that. And that means that sometimes, when the trends come and go, you won't necessarily find them on Starknet, but you will find long-lasting, future-proof technology that will win mass adoption. We have received criticism over a number of things in the past, and we do listen and adopt and adapt and address it. So for instance, we changed the lockup schedule for investors and team based on feedback from the community. We just recently reduced the pricing on contract deployment because developers said it's too much. And we shifted our focus from performance to stability based on feedback from the community. We listen and we adapt. That's our nature. The last thing is that our current focus right now is moving from addressing performance to addressing the side of demand and bringing a lot more developer-side applications onto Starknet in an innovative way that will shine a spotlight on why the choices that we made many years ago and are still making will turn out to lead to the best experience to users at the highest scale and smallest cost. So about staying true to vision, what is our vision? Why are we doing the things that we're doing? So let me articulate it for you. What we believe is that in a free society, integrity, knowing that the right thing is being done, integrity should never be assumed. It should be demonstrated publicly. So when someone, be it the government or a corporation or an individual, makes a claim about having done the right thing, we believe that this should never be taken on faith, but it should be proven and asserted in a way that is verifiable publicly. And that's exactly what blockchains are doing by having a system in which everyone checks everything. Well, what is unique about Starknet's vision is that we have found a mathematical way to exponentially increase the capacity of blockchains so that integrity can be demonstrated even without everyone needing to rerun everything. Now, why should we care about this? Well, the answer is that if integrity is never assumed, but rather demonstrated publicly, what we can do is we can make sure that when others are using our data, they're doing it on our own rules and with our own volition and agreement. And this will lead to you being the true owner of your data. You will own your assets, you will own your actions, and you will own your digital life. So the reason we are doing all of this is that we believe that by demanding integrity be never assumed, but rather demonstrated publicly, we will give you true ownership of your digital life, which is not the case right now. You do not own your digital life. It is being controlled by other parties that have other goals in mind. We will change this. So we're never going to compromise on integrity, on security, on transparency, on excellence, and on magnanimity, even at the expense of term wins. Our space of layer 2s and layer 1s is inundated with projects that, especially in times of bull markets, are rushing to reap the next wave of gain, and along the way, throwing away values like security and other things. We're not going to do that. So if you care about long-term vision and values, do check out Starknet and its ecosystem. How is this going to display itself? So Starknet, for instance, one of the brave choices we made early on is we went with a system that is 100% native account abstraction. There is no end user accounts that have a specifically designated cryptographic protocol to do them. Everything is account abstraction based, which means that the wallets and applications that are being built today on Starknet are going to be benefiting from UX and UI that is Web 2 while having self-custodial, highest grade levels of security. And this is something that you can only find today on Starknet. For instance, the reason that Visa Research decided to deploy on Starknet was because of this 100% native account abstraction. And if you think about the UX barrier to entry, to resolve it, you really need a system that has the security of Web3 with its self-custodial aspects, alongside the UX and UI of Web2, which is to be found only in a network that gives you 100% native account abstraction, which is currently found only on Starknet. Now, let's talk a little bit about scale. We are heading towards 10,000 TPS and more. I want to show you how we're going to get there, and I want to explain to you why we're going to get there. So, how are we going to get there? First of all, the capacity of compute that we today process is already something that is rarely seen in the web, in the L1 and L2 capacity, even among chains that have taken it their mission to scale the fastest and the best. So we measure things in terms of user operations per second. The new programming language and environment that we have allows you to put several different transactions in a multi-call. That's another unique feature that we have. And we've already clocked near to 200 of those at peak. If we look at the capacity for something like ERC20 transfers today on Starknet, so our prover, the Stone prover, which stands for Stark1 prover, this prover today can operate at a sustained rate of 1,000 to 2,000 TPS of proving on current infrastructure, which is way above the demand that we see on any blockchain today. Now, there are other parts, namely the sequencer, which is very sequential, which limit our TPS a little bit more to the range of roughly 200, 100 to 200. Our mission this year is to unclog that and reach 500 and more TPS. Now, that's our current bottleneck, and we will overcome it through this year. But we already are working on our next generation prover called Stu, which has a lot of innovations. The main one is that it uses a very small field, which leads to extremely efficient implementation. It's going to be the fastest prover. Already, according to measurements, we see it is the fastest prover out there. We see that it is at least 2 orders of magnitude faster than Stone. So remember that Stone can prove at a rate of roughly 1,000 transactions per second. Here we're talking about a new technology that will start meeting the market next year and can operate at a sustained rate of proving of 100,000 transactions and more. So this is already the level of the capacity that you need if you want to reach global scale and compete with things like Alipay, WeChat Pay, Visa, and those sort of things. So that's where we're reaching. Now, you may ask, why do we want this? Why do we need this? If you check today, demand on Starknet, we're hovering at around 1 TPS, sometimes, barely scratching 10 TPS. Why are we insisting on going to 1,000, 10,000 TPS, 100,000 TPS? Well, we strongly believe that you can learn the lesson from the internet. The internet in the early days had very little usage. And if you go and read, let's say online, what made it go through this transformation, it was really unleashing scale, which allowed a lot of applications that couldn't be found before to suddenly go on it. So we think that in order to achieve our vision, that is, that integrity should never be assumed by anyone in any case, but always demonstrated publicly, so that you can own your data, your assets, your life. In order to reach this vision, scale must be at a rate that can sustain global usage. And alongside that, and a main reason I came here is to talk to a lot of the amazing developer teams around here to get them to build the applications that are going to use all of this capacity that we are unleashing. So with this, I want to thank you, and please come up if you want to build on Starknet. Thank you very much.
Thank you. Big round of applause for Ellie. Thank you so much for the enlightening presentation. Thank you. Please be seated. So, ladies and gentlemen, moving on, let's welcome our next keynote speaker, Mr. Smokey, co-founder of Berachain. He's going to share with us the topic, Berachain Integrated Liquidity. So, without further ado, let's give him a round of applause.
Alrighty, guys. Can you hear me okay? Yeah, relatively hearable all around? Okay, cool. Hey guys, my name is Smokey. I'm one of the co-founders of Berachain. I'm here to talk to you about integrated liquidity, what we do at Berachain as a whole. I'm not exactly sure what integrated liquidity is either myself, but we're going to try to figure this out over the course of this presentation. We're going to start with a little bit of context on the backstory, what Berachain is, how we got here, and then we'll talk actually about the tech and what we're doing and why we think it's interesting. Cool? Okay, so first of all, basics. Unfortunately, and sorry to disappoint, we are not in L2, we're in L1. We're an EVM compatible or fully EVM equivalent L1, built on the Cosmos SDK, and powered by proof of liquidity. But we'll start with a little bit of a backstory on Berachain and how we actually got here. So Berachain did not start as a blockchain. It actually started as a whole bunch of NFTs of bears consuming drugs. We're not exactly sure what happened in the middle. We're very much trying to figure this out at the moment. But by the end, we found ourselves with a full-fledged blockchain with 8 million unique wallets, 100 million transactions on testnet, hundreds of applications building, a lot more than I'll tell you guys about in a little bit. So, at a high level, the Berachain story started actually from these NFTs that I mentioned, the Bong Bears, that were actually a set of 6 rebasing NFTs. These NFTs ended up building a community of thousands of heavily DeFi-oriented users. And what we actually found was that by drawing our initial community from these groups like Olympus, Curve, Frax, Alchemix, etc., these groups that are very, I guess, emblematic of what we would call a barbell distribution, we found ourselves with a really interesting group. So if you had 1 bear, then you got 2 bears, and you got 4 bears, and you kind of get the idea here at a high level. So what we ended up doing at Bearchain was relatively different from what I've seen in most L1s or protocols being built over time. A lot of times you'll find a very exciting consensus method or a novel research technology, and you'll spin it out of a university lab, build a chain around it, build a community around that, and attempt to form something around the tech. In our case, actually, what we ended up doing was building a community, talking to those folks, actually interacting with those users, and then figuring out what problems they solved or they need to have solved and how we could work with them on that. So Bearchain is actually what I'd probably see as most representative of like horseshoe theory or barbell distributions, where the far left curve and the far right curve actually align at many different points. So in our discovery time and actually talking with users, we identified a couple big things that were missing in the blockchain ecosystem as a whole. And one of the biggest unsolved logical fallacies, let's say, was really this lack of alignment between liquidity and security at the chain level. Throughout the last cycle, the Alt-L1 rotation, etc., we saw dozens of chains that had hundreds of millions, if not billions of dollars sitting in their validator set, securing the network, but absolutely incapable of actually generating any transaction volume or contributing to the chain itself. So it's wonderful. The chain is secure. You can use it all day, but there's nothing actually happening there. And if we want blockchains to scale, we have to imagine that they need to be used. And that's sort of where this idea of proof of liquidity and what Bearchain's really built around came to be. So the whole idea is that Bearchain is here to make liquidity flexible, is here to actually align incentives between liquidity and security at the chain level without sacrificing anything and without introducing leverage risk. So how does this actually work? At the high level, proof of liquidity allows the validator set on Bearchain to drive emissions and block rewards to the protocols building on top of the chain itself. This is fairly different from what we say in proof of stake chains, and what this means is that for the first time, an application actually has a reason to exist uniquely on Bearchain as opposed to any other ecosystems. It is not built around predatory grant programs. It is not built around extensive handouts and gas subsidies. It's actually built such that the chain itself can power its applications and give them a unique edge around capital efficiency and liquidity acquisition in building on the network. So that means that Bearchain is in service of its users and its applications. So let's talk a little bit through the tokens really quickly. Bearchain's kind of funky in that we actually have 2 different tokens that contribute to the network primarily. There's one called BGT, or the Bera Governance Token, which is perhaps a little bit on the nose naming-wise. And there's another one which is called Bera. But we'll start by talking about BGT. BGT is interesting because it's actually entirely illiquid. You cannot market buy it. You cannot go on Binance. The only way to obtain BGT is by actually doing the work of providing liquidity to the ecosystem. So at the start of the network going live, there are a set of applications built into the chain. There's a DEX, there's a perpetual futures vault, there's a stablecoin lending market, and all of these can accrue BGT from people LPing or providing liquidity to the network. BGT itself is then used to actually vote on where emissions across the entire network are distributed, such that the chain can power those different applications over time. Beyond this, BGT also earns fees from all of the different protocols being powered by the chain, such that people actually have a reason to hold it and actually can effectively choose between 2 paths. You can either hold this token and go long in the volume, the volatility, the general activity of the network based on its fee-generating properties, and be able to partake in governance and amplify emissions towards your own pools that you're participating in. Or you can hold Bera, the gas token of the network that all of us generally know how it works. You burn it, use it for gas, conduct transactions, etc. So that choice is something that we cared about a lot in building the chain. So when we think about a traditional value flow in a proof-of-stake chain, you see validators accruing block rewards, and that doesn't necessarily flow back into the ecosystem. So while validators play a massive role in securing a chain and actually ensuring that it is able to operate, that blocks are being built effectively, so on and so forth, they aren't actually drawing net new users in. They aren't actually helping the chain exist and grow, right? So the whole thesis of Bearchain is that we try to flip the flow of value such that it is the users and the applications who are actually benefiting the most from the chain's operation itself. So how does that actually work for each party? We'll go through this really quickly. Validators are actually in a absolutely privileged position on this chain in that they actually control the flow of liquidity and emissions across the network. The validators on Bearchain are the decentralized group that actually determines which pools, which smart contracts, which groups actually receive the most emissions across the network. At the same time, we look to incentivize validator protocol interactions, such that for the first time, a validator and an application building on a chain can work together to bootstrap that chain's own liquidity and security at the same time. That way, an application can actually say, hey, I'm going to work with this validator. I'm going to give them X amount of my tokens. And in exchange, they're going to direct Y amount of emissions, ideally in a cash flow positive manner, to my pools, my smart contract, my contracts on the network, such that that application can actually reach a degree of activation energy. So beyond this, they earn standard commissions from transaction fees, block rewards, standard validator behavior. Protocols on the chain are actually able to utilize the governance modules itself and utilize governance in the form of BGT to actually become integrated into the set of contracts on Berachain that can earn block rewards. So while I mentioned that this initially starts with the DEX, the perps vault, the lending market, over time, any single smart contract on Berachain can actually become part of the chain and part of proof of liquidity itself. So this is what we mean by integrating liquidity into the chain, such that Berachain can push its emissions and push its block rewards to any protocol building on us, whether that is a NFT marketplace, a SocialFi application, a game. If it's building on Berachain, it can receive block rewards and actually be uniquely charged by the chain itself. These protocols are generally incentivized to work closely with validators, such that they can bootstrap their own liquidity and do so in the most capital-efficient manner possible. The important thing here is that there's an equivalent exchange, or there's a value exchange here, right? These protocols are sending their validators, and in exchange, the validators and by proxy, the stakers on the network who have contributed liquidity, they're sending them fees, they're sending them token emissions, and in exchange, they're getting their liquidity. And then finally, users. Users actually don't have to modify their behavior in the slightest. They get to have their stake and eat it too. Users are able to LP or interact with their desired apps as they always have, and at the same time, take those BGT rewards that they've accrued from interacting with those applications and use it to influence the direction of the network as a whole. And that's the part that we find most exciting, as we believe that at the end of the day, if we're not in service of the users, we're building in the wrong industry, right? So the whole choice here is that the people who have contributed the most value, as we see it in the form of liquidity, to the ecosystem are those who have the greatest benefit from its growth itself. So Berachain really is an ecosystem that is entirely driven by those who've contributed value to it. The parties who have actually given to the network are those who get the biggest say in how it actually operates over the long term. So, why do we actually care about this? Why does this all matter in any way? When we think about modeling a chain, and we think about modeling an ecosystem itself, I don't think anyone cares about the chain that something is built on. When we think about the next million, the next billion users, they don't really care whether something is built on Solana or Aptos or Polygon or Berachain for that matter. What they care about is the application itself and whether it uniquely enables something that they did not have access to in the Web 2 world. Otherwise, they'd have simply built it on Web 2 rails, right? They care about the transparency, they care about the permissionless nature, they care about the verifiability of all these things happening on the blockchain, and they care about their user experience. And when we think about that as a chain, our goal is to enable as many first-class builders to take their applications from 0 to 1 in an environment where we're built to help them. And that is really the idea of Berachain and proof of liquidity as a whole. It's built to turbocharge that next generation of application builders because we really do see a chain as the sum of its parts. The chain is never meant to be the main character. The chain is meant to be a foundation layer, a background, a base plate that these applications can thrive from. So, we ask ourselves, how's this gone so far? And while we're still in the very, very early stages, and I don't think that we're, anywhere close to the finish line, we've seen a lot of promising early stages of success from the proof of liquidity model itself. There are 200+ projects building within the Berachain ecosystem that we know and have worked with closely. There's been, over $25 million brought into, pre-launch projects in the ecosystem. The testnet has been one of the most active ones in history, and there's over 50 TGEs already planned on the network that we expect to give a, healthy ground once the chain is live. So, in short, when we think about it, Berachain's the best place to take your application from 0 to 1, and we want to be the home for that class of best-in-class builders. And, the whole goal for us at the end of the day is to be able to use proof of liquidity to help make sure that people build the next category-defining application on Berachain, and to lower their barrier to entry, to increase their escape velocity, and to remove activation energy for those groups who are looking to redefine the future of crypto. Thank you so much, guys.
Thank you so much, Smokey, for the enthusiastic presentation. We enjoyed it a lot. Thank you, and please be seated. So ladies and gentlemen, while we wait for the setup for the next session, let me give you an overview of our event. So our event, the Hong Kong Web3 Festival 2024, is a 4-day event. It features amazing lineup of industry guests, as you can see, from all around the globe, bringing together the world's brightest minds, top Web3 projects, and leading venture capitals, presenting content-rich discussions and topics centered around Web3. Hong Kong regulatory representatives will also dive into and interpret the latest digital asset regulation policies. You'll also find amazing programs at the main stage as well as the sub-stages in the following event days. If you want to know more details of the agenda, do scan the QR code on the event catalog to know more about it. Also, a gentle reminder for all of you, you can collect stamps by visiting booths of the organizers, title sponsors, platinum sponsors, gold sponsors, primary, secondary, and tertiary exhibition sponsors. And when you collect a certain number of stamps, you can claim a gift at the information desk. The number of gifts are limited. They will be provided on a first-come, first-served basis. So do make sure that you collect enough stamps to win gifts at the information desk. So now, ladies and gentlemen, let's move on to the panel discussion. The topic of the panel discussion is Layer 2 ecosystem application and service. And we have a lineup of industry experts and panelists here to join us for the panel discussion. So without further ado, shall we invite them on stage? Now, ladies and gentlemen, let's welcome the panel moderator, Mr. Ross Zhang, Managing Partner, SNZ Capital. A big round of applause for our moderator. Also, our distinguished panelist, Mr. Tom Orr, Executive Lead Matters. Big hand for him. Mr. Ben Wan, Chief Community Officer, Tyco. Mr. Liana, Co-Founder, Intmax. Mr. Leo Fan, Founder, CISIC. YQ, founder Outlayer, Miss Angel Xu, co-founder of Circuit. Welcome, guys. Welcome. So now I'll pass the floor to our panelists and moderator. Over to you now.
Hello, everyone. Thanks for being here, and thanks for your time. My name is Ross. I'm a managing partner at SNZ Capital. So SNZ is a crypto native and community-driven investment firm. So we are the earliest backer for Ethereum since the very early days, and we invest in a lot of infrastructure, like some of the layer 2s. So it's our privilege to have the opportunity to discuss with a current layer 2 ecosystem and also the applications. So we have the first question here. Since the layer 2 solutions have been a pivotal topic throughout last year and also like this year, could each of the founders share their perspective on the current primary focus on each of the layer 2 and explain like why this is like the priority, the rationale behind it? Maybe we'll start with Tom.
Yeah, hi everyone. My name is Tom, Executive Lead at Metis L2. Yeah, some of the focus for L2 for us is why we were built, is scalability, accessibility as well, and really solve some of the challenges that L1 is facing currently, bottleneck with fees, gas fees, and yeah, those are the main challenges from our side. And of course, to really expand on decentralization and maintain that, we just decentralize our sequencer. So that's our main focus from the L2 side on Metis. Passing it along to our next guest here.
Hi there. I'm Ben from Tyco. And some of the more common themes that we actually see here at Tyco for all L2s is that people are trying to come off the training wheels, and we also need to be more decentralized. So what we're actually doing on Tyco is to try to build a based roll-up. And what that basically means is that we're trying to solve a number of issues here as well. So two of those areas are that we are building a based contestable roll-up, and also we are building a based booster rollup. Now, these aim to address different parts of the ecosystem whilst maintaining the Ethereum core principles of censorship resistance, permissionlessness, and security.
Hi, I'm Leona from Intmax. And Intmax is a stateless ZK layer 2. And I think the focus as a layer 2 space as a whole is going beyond the limitation of the blob 4844, what we call 4844 or product uncertain. So blob is a limited, blob is another type of block space, and it's kind of special type of block space. And it's still inheriting the limitation of the block space. And so right now, layers are super cheap because of the blob is less used by many people right now. And when it's crowded, it's still inheriting the limitation of the block space, so it will be expensive. Then, yeah, how to go beyond the block space and using less block space is less blobs is still really important. And our stateless layer 2 is working on that. And also another focus we are having as our project is privacy. So there are a bunch of projects are doing privacy, but they don't have scalability. And there are a bunch of scalability projects, but they don't have privacy. So having both scalability and privacy at the same time is our main focus from our side.
Hello, hi everyone. My name is Neil Fan. I'm a co-founder of SciSec. So SciSec is doing hardware acceleration for ZKP. Like we can support not only layer 2s, but all the ZK-related projects such as ZK Bridge, ZK coprocessor. And like our product is more on the, we try to generate the ZK proof generation in real time. Like we use a bunch of different hardware such as GPUs or FPGAs or even ASICs, which is still some time away, to accelerate the proof generation for different ZK projects. We are also trying to reduce the cost for the ZK proof by plugging our own GPU servers or our partners' GPU servers to reduce the current proving cost for all the ZK related projects. Yeah.
Yeah. Thank you, Leo. YQ.
Yeah. So YQ here, founder of Allier. So yeah. On our side, we're providing rollup as service and also real-estate rollup together with Eigenlayer. Back to the Ross question. So based on the feedback from a lot of our customers and partners, since we are launching all different rollup stacks for them, like OP stack, Arbitrum, Orbit, Polygon CDK, and also ZK Sync, ZK stack. And yeah, it's typically what they really need at this stage is sort of low gas fee, high throughput, and sometimes they want to customize the interior sort of L2 or L3 for their demands. So in that case, this one word we call a lot is basically the modularity. So they want to make it as a little bit like different Legos. For example, they choose OP stack plus, for example, EigenDA, right? And on top of that, they want to have different LRTs into their L2 or L3. So this kind of modularity is something a lot of these projects, especially gaming and social and DeFi projects, if they want to launch a rollup, typically that's something they really need. And beyond that, another demand we are trying to handle is sort of they want their token as a gas token. So basically custom gas token is one of the highest demands from these projects. So so as a summary, right? One is modularity, basically combination of different rollup stack and DA. The second thing is really more utility for their own tokens. Yeah.
Thank you, YQ. Angel.
Hey guys, Angel here from Zirkit. So Zirkit is a ZK rollup, and I think today we have many great rollups building to scale Ethereum, and for Zirkit, our focus is to scale Ethereum securely. So we really spend the past 2 years doing a lot of research on rollup security. We got some Ethereum Foundation grants on that, and we prioritize security at the sequencer level, and we want to make that definitely like a definitive feature of Circuit. And yeah, so today we are at our testnet and launching our mainnet in summer. And welcome to come build on Circuit with native security features.
Thanks, everyone. So maybe the next question is really for all the different like layer 2s and rollups. So that's a question for Tom, Ben, Leona, and Angel. So because like we already have the existing like different like rollups, either it's a ZK rollup or optimistic rollup. But then the next question will be, how to build a whole ecosystem, right? I heard people saying there are too many like infrastructures, right? There are just less users on like different infrastructures, right? So I would like to ask you guys about what is your strategy to build your ecosystem, right? Maybe we'll start with Ben.
Yeah, sure. So in terms of building ecosystem, we at Tyco believe that it's the ecosystem and the community go hand in hand. So you can't really have one without the other. Now, with the exceeding 1 million plus members that we actually have on our Discord, we actually have a really strong community behind us, which helps to boost our ecosystem partners, along with grant systems that we actually propose for our community developers and also our ecosystem partners. In addition to all of this, one of the key elements around building ecosystem is also around, we talked about things like fragmentation of the L2s. So what we're developing in the future will be what we call our based booster rollup. This is more like a system for scaling and helping developers and applications. So what this basically means is you can deploy on L1 and execute everywhere on L2. So this is more of a way of natively scaling L1 Ethereum. So these are our real plans. And in terms of our key focuses, being fully permissionless, we're not really concentrating on any particular vertical. But what we're actually looking for, and what we've actually seen, is that over the past years, even when there were no L2s and just having L1s available and the high gas fees, we found that there are certain verticals like DeFi and gaming which are really, really popular. So I think that going forward to bring the next billion users on board, these are also key ecosystem partners that will enable the adoption of L2.
Got you. Thank you. Maybe the next goes to Tom.
Yeah, from the meta side, I do agree with what was just shared. Community is a big part of really driving ecosystem development. Having tooling is a key part too. One of the challenges that we see is different toolings on different networks, and certain dApps from different network are not used to using certain tools or service providers, so they have to adapt. So that also creates latency and also bottleneck for them to deploy on different networks. So in terms of community tooling, a unified tooling that is usable across the board, each network, onboard different partners with different features. So that's a curve that a lot of dApp builders have to really figure out and work around. And we see that quite a bit. In terms of community, I think engaging and really incentivizing building is a key thing. Here at Metis, we have the Builder Mining Reward, which reward builders who contribute to the ecosystem, transactions, TVL, and such. We also have the Ecosystem Development Fund that we just launched, 4.6 million Metis for builders to incentivize. I think one of the key things is also really providing support for builders, is because not all builders have all the tooling or the structure to build out a project. They might be well equipped for tech, but not business and such. So having support from the foundation or internal support, advisories such as that, or counsel to help these teams really cultivate and build, I think is a key factor in really building that ecosystem. You need builders with business mindset, sustainability, and not just really build and just really utilize grants just to build the tech. You have to have the usability and how to maintain this runway. A lot of projects we see run dry, so they move to the next ecosystem. So I think this combination of this business, tech, and tooling that will help really drive the ecosystem for sustainability.
Got it. That makes sense. Leona?
So in my opinion, having a unique value proposition is the strategy how to make our ecosystem, in my opinion. So yeah, in our ecosystem, the priority on the core value is the statelessness, which implies that we have our scalability and privacy at the same time. And the problem in layer 2 ecosystem as a whole is that layer 2s are, ecosystems are quite similar to each other right now. The way of their ecosystem building, the way of their growth their ecosystem is a quite similar way. And so having a value proposition, unique value proposition, and uniting their community with that value is more important than kind of technical hack or tactics to grow their ecosystem. So privacy is still kind of underrated, and people are a bit afraid of privacy still, but I'm pretty sure that in the future, privacy will be a precious asset and a tradable asset, which many people want to buy, pay for that. And so in that sense, statelessness don't compromise their scalability, of course, and also having that future vision of privacy. So yeah, that's basically the strategy based on the core value of Intmax.
So what about Angel?
For Circuit, I think we primarily focus on 3 points when building our ecosystem. First is, of course, security. So we've been trying to understand what are the biggest concerns for builders, and we all know that one of the biggest problems right now in DeFi is that there's always hacks. And so we've been trying to come up with ways to prevent the hacks and to protect all the user funds. And for us, that's why we build the security at sequencer level. So projects building on Circuit, they would have the security feature basically to prevent hacks happening. And second is, like Tom mentioned, there's a lot of fragmentation right now. And we want to have day one liquidity for all users and projects. That's why we've been running this staking program. So currently, we have over 1.5 billion worth of total value staked. And most of these will be migrated to the mainnet once we launch. And thirdly, I think it's to make sure that both users and developers could be properly incentivized. And for us, we've been, running a build-to-earn program and also allocating a lot of our token allocation to these incentive programs. So yeah, that's basically our approach.
Okay, got it. Thank you. Then the next question goes to Leo and YQ, right? So besides all these specific roll-ups, layer 2s, I think you guys are sort of laying the foundation and provide the support and make the ecosystem more vibrant and more user-friendly so that people can come. So the next question is, from your guys' perspective, what are the pricing needs for the current layer 2 landscape? So maybe Leo, you can start first.
Yeah, so since SciSix focus is mainly on the hardware acceleration for ZKP, so the pressing need from our perspective, first of all, is we try to make the proof as fast as possible. In the past year, we just get maybe 2 or 3 orders of magnitude faster than all the current CPU implementation. Yeah, so that's for one thing. The second thing is if you have the fastest program to run, then you still need to figure out the scarce computing resource. You need to say, probably we can use the previous GPUs for Ethereum mining to join the ZK proof generation. Yeah, so in ZK proof generation, actually you don't need a very powerful GPU such as like H100 or A100. You just need some commercial GPU to join, such as 3090 or 4090 GPU cards. They are suffice to generate the ZK proof like very fast. Yeah, so those are two things like we are working right now. The first is the CUDA program for the proof generation. The second is to secure the GPU cards for the ZK whole ecosystem.
Thank you. YQ.
Yeah, on our side, based on like since we are serving like over 30 projects, right? A lot of them are very big ones. For example, last week we launched a rollout for a very big gaming project called Exterior. And based on all these customers and also partners' feedback, right, we feel like at this stage, since most of the rollup stack is quite stable and mature, for example, OP or Arbitrum Orbit or even Polygon CDK. So either it's optimistic rollup or it's a ZK rollup, right? Based on this feedback and also the experience, it's really about customization right now. So almost for every partner or customer, they typically ask all different demands on the customization. None of them like just do let's click a few buttons via our website and then launch at midnight. All of them, they all have these different customization like requests. So for example, some of them, as I just mentioned, right, they want their like sort of token as the gas token, and some of them they want the staking feature. And some of them, like they want like not just one DA solution, they want multiple DA solutions to further secure their rollup. And so that's something I believe probably for the next 1 or 2 years, since we will see a lot of like these application-specific rollups, either for games and social, DeFi, even for some of these BTC L2, right? We will see all different customization requirements for all the different rollups. And beyond that, granularly, for a lot of the rollups, since for most of rollup at this moment, they're single sequencer, right? And for all the rollup stacks. So people want some decentralization on it. So that's why, like, based on these demands or requests, we are working closely with Eigen and to provide this decentralized verification and sequencing network to decentralize and secure this kind of single sequencer network. So these are the real demands from a lot of these customers and partners. I believe, like in my talk yesterday, right, I mentioned like probably by the end of this year, we will have over 1,000 rollups in the market. But it definitely, I feel like there's so much diversity for all the different rollups, especially different demands. I don't think it will just converge into one type. But then, based on all the demands, I believe there's still a lot of challenges and opportunities for the next at least 2 years or 4 years for like all the panelists to address. Yeah.
Yeah, makes sense. So since YQ brought up the topic about sequencers or sequencings, right? That's definitely a hot topic right now. So I think everyone is trying to sort of like figuring out how to decentralize the sequencers, how to balance like the performance and the decentralization. So what maybe you can tell us a little bit more about the current challenges, and is there any specific like focus or any ideas on how to address the sequencer issue? Maybe we'll start with YQ since you brought it up.
Yeah, so we are working with, as a rollup provider, right? We are working with almost all the existing shared sequencer providers like Espresso, Radius, and some other ones. The fun thing is that for most of the partners we work with from this gaming, social, and DeFi, none of them want this shared sequencer at this stage. Of course, one thing because they don't really have the midnight ready yet. The second thing is really about the latency. Because like once you have a shared sequencing network, right, you need to run a group of nodes, like probably over 100 or a few hundred nodes, right? So in that case, it's not that straightforward to really have like low latency. Typically, you have minimum 2 to 10 seconds or even like a few minutes to finalize some block for the different sequencers. So in that case, for some specific sectors like gaming or social, or even this kind of DeFi perp L2s, they just couldn't like use this kind of share sequencer sort of network because their requirement for latency is sub-second. So by default, like it's sort of like they just couldn't use the share sequencer network. And beyond that, I think another biggest selling point for share sequencer network is that you need to provide the interoperability for all the sequencer, all the rollups. You basically help them to do the sequencing, right? And the challenge is that if you really want to do this interoperability across different rollups, right, you have to lock one rollup to make sure like you finish like sort of the sequencing or block generation for another rollup. So in that case, somehow you probably become the blocker for different rollups if you really want to achieve this interoperability. So that's why I feel like even right now, there are so many like concepts and projects working on this direction, but still there are some fundamental problems we need to address before we push all these share sequencing network to the market. Yeah.
Yeah, it's definitely a hard problem to solve. So Liana, what do you think?
So share sequencer, and maybe the mainstream of the share sequencer is a base rollup in another name, L1 sequence. Basically, they're sharing their same vision. And the base rollup on L1 sequencing now let me explain about this. So basically, rollups are posting a lot of transaction data on-chain, layer 1. And so, yeah, basically the transaction data can be on-chain. And in typical layer 2s, sequencer or the block producers it's kind of limited to one network or something like that. And share sequencer or L1 sequence or base rollup is combining the layer 1 validators, block producer, to a layer 2 block producer. No, we can do this because their transaction should be on-chain, right? So they're having their validators, block producers of layer 1, POS, validators, do both sequencing transaction for layer 1 and layer 2 at the same time. It solves a lot of problems like kind of fragmentation, the liquidity fragmentation of layer 2s, and also they're solving the MEV problem, the front-running problem in DeFi's. And so it's a quite strong solution. So I think it's really great. So it's making a lot of rollups to integrate a lot of rollups to one big rollup. So that's the vision of the base rollup, and basically the share sequencer is having the same purpose. And the problem of this great idea is not the technical problem, actually. And the problem is that kind of what we call misalignment. So there are a lot of advocates and supporters of share sequencers under base rollups, but there are some opponents to that. And basically, this is because it's a misalignment of the layer 2 and Ethereum ecosystem, and also the problem of the sovereignty. Their opponents are saying that they want their sovereignty to decide their own system, decide things about their own system, and how to choose the validators, how to reward the validators, and how to sequence the validators, and how to deal with the MEV profit. And so layer 2 makers they want their sovereignty. Community want to have a sovereignty, and but their share sequencer is the best for the whole layer 1 Ethereum ecosystem. So it's kind of misalignment between the layer 2 and the layer 1. Of course, the layer 2 token holders, like investors and their builders, they want to outperform Ether with that token, right? So otherwise, they don't have any reason to choose the layer 2 token instead of Ether, right? So the layer 2 advocates or layer 2 are kind of supporters, want to outperform Ether. So this is I think this is the source of the misalignment, and so there's no technical problem in share sequencer. I don't think there's no big problem in share sequencer in a technical way, but there's a kind of humanity problem or kind of human relationship problem or, what we call misalignment. So yeah, I think it takes time, but I hope that the whole Ethereum ecosystem fix this problem or misalignment and make a kind of greater, united ecosystem without the unfair MEV or the layer 2 fragmentation.
Okay, got it. Tom, what do you think?
Yeah, I think some of the challenges that was mentioned, as in latency, is a key thing that when we implemented our decentralized sequencer pool, we had to face. How do we offset this? We batch the orders, transactions and such. But going back to what was just shared here, it's the alignment of the ecosystem. Us as Metis, we use the Metis asset as transaction, gas fees, governance, as well as security for the network. I think from our take on it is there's still a lot of challenges, as was mentioned earlier before with the alt layer. They said, in theory, it's great. Some of the teams are doing some amazing research. Testnet, it's been amazing for some of these projects. But I think, how do you apply it? And I think we're still not in that phase where how do we apply shared sequencing. We see that as valuable to the market as an option for different protocols, different network as well. For us at Metis, we feel like the decentralized pool is where we're at now, and we've been able to execute that and rolling out the different phases. So in terms of challenges, I think is how do you sync all these sequencer? How do you keep them in line? The more integration, the more parties you apply and layer on, the more challenges and things that can go wrong. But I think the teams will definitely solve that. But I think that's one of the biggest challenges right now in that space.
Yeah. So Ben, what do you think?
I think it's a very interesting topic talking about shared sequences. On Tyco, we don't actually have that issue because we are a based rollup. So that basically means that we use the L1 Ethereum proposers and sequencing from directly from Ethereum. It also means that all of the MEV that is created flows back to all of the block proposers. Now, in terms of being a base rollup, that also has its own set of criteria as well. So, we previously mentioned that there are certain latency delays, for example, 12 seconds. So, for example, if you're proposing a block and it's on L2 and the proposers are not talking to each other or don't see each other, within those 12 seconds, if anybody else proposes a block, then potentially you're wasting resources and money in proposing the same sort of information. So what we try to do here is we try to utilize things like pre-confirmations. And with the use of pre-confirmation, you can actually identify and propose an L2 block using the L1 state. So these are ways that we're looking at going forward to mitigate the differences and latency actions from sequencing.
Got it. Yeah, I think that's an interesting approach. So maybe we move on to the future trends for layer 2s. So there's a trending topic recently about about layer 3, whether layer 3 makes sense or not. So what do you guys think? Like, do we need a layer 3 on top of layer 2? Or if we need, what should be the purpose of the layer 3? Is it for the scaling purpose or is it for like other purposes? Maybe we'll go with Angel first.
Yeah, I think the best recent example of layer 3 is probably DGen. And, it's like the coin's doing great. It's at, I believe, currently 1.5 billion FDV now. But I think at the same time, it's like taking a bunch of liquidity on the base chain to their own chain. And therefore, kind of like not like in the great benefit of other base projects. But I do think there could be use cases for layer 3s. For example, if we want to work with some like traditional big corporations, they want to have their corporate chain or something, I think layer 3 could be great. And so there's like pros and cons, I would say. And we're definitely still like experimenting in that landscape right now. But yeah, DGen's probably a fun experiment.
Yeah, interesting. YQ, what do you think?
We've already launched like two gaming L3s, like settled on Arbitrum 1. So I believe like for games, if they really want to enjoy the best like throughput and also much lower gas cost, L3 definitely is sort of like the balanced solution at this stage. And we're also going to launch another L3 for DeFi. Like sort of like this perp or something. It's really like because like the bottleneck for a lot of these projects right now, if they have a lot of user, right, it's really about the throughput and also the gas fee. Even for OP Arbitrum right now, the gas fee is lower than 1 cent. But right, a lot of the projects, they want something much lower than that because they want to capture probably some Web2 users, especially for games, right? The combination will be like much lower gas cost plus account abstraction. So in that case, like users don't really need to create a MetaMask wallet, whatever, and they will directly use in-game like sort of wallet, and user don't really need to create like sort of the key pair for it. But the underlying infrastructure is L3, like basically still blockchain infrastructure. So I think it's sort of like really depends on the demands from these applications. If they really want super low gas cost and super high throughput, L3 definitely is a very good solution for them. Yeah.
Yeah, makes sense. Leo, what do you think?
Yeah, so first of all, I'm not an expert on the layer 3s. Yeah, but as the previous speaker said, like if you want some like more control on the chain, probably have like higher throughput, lower gas cost, then probably you can like build a layer chain, a layer 3 chain specific to your application. So in that sense, like you can have more control on your chain, and you can like tailor the chain to your needs. So yeah, so in that like special case, probably like layer 3 is a trend. Yeah.
Yeah. Leona.
Layer 3 is differently needed because the blob has a limit. As I said, blob is limited in the future, and people will compete to use that. And layer 3 can kind of avoid that limitation. And I think the layer 3 will like more app specific, like Leo said, and yeah, people will build a roll-up stuff kind of customized for special use cases, and it's unlike the general layer 2 EVM compatible layer stuffs.
Ben.
So on Tyco, we developed on a previous testnet, Tyco on Tyco, which was an actual layer 3. And what we found as part of that is that it didn't really make sense for an Ethereum equivalent protocol to have a layer 3 because it would create some kind of congestion if we wanted to maintain the decentralization and all of those good things. However, that doesn't mean that it doesn't make sense because for app-specific activities, that would be a real bonus because you can think of it as speeding up a specific application like gaming. It will have its definite use cases there. It will lower transaction cost. It will also speed up the actual transactions as well. Now, in relation to that, there is an actual trade-off there, and the trade-off would be more centralization because to remove the congestion that we mentioned, you would have a more dedicated sequencing and proposing. So that would be the actual trade-off in that sort of sense.
Yeah, I see. Okay, Tom, what do you think?
Yeah, I agree with most of the panelists here. I think gaming is a huge sector that will definitely benefit from the layer 3 side. We're definitely exploring that. I mean, not us, but in general, the industry is. So, and the industry hasn't really adopted gaming to its fullest potential. So, to prepare for the future, I think this, and some of the games and some of the gaming networks are already building on top of layer 3s. So, I think that's one of the driving factor that will really push the utility and the need for this.
Yes, I see. So finally, maybe you guys can list like a 1 or 2 or 3 like priorities for layer 2s today. Maybe we'll start with Tom.
Yeah, 2 or 3 priorities. I think the key 2 or 3 for me would and Metis would be accessibility, continue of the decentralization of the network as well, and yeah, I think those are the top things that come to mind at the moment.
Ben.
Yeah, I think the top items from, I think the learnings from this panel will be that we definitely need decentralization, and we definitely need to maintain the core ethos of Ethereum, which is, you know, builders and security, and making sure that from an infrastructure perspective, we maintain the core principles.
Yes.
Yeah, with these partners, I convinced the layer 2 of the future. And also, yeah, we need the statelessness for scaling the layer 2 ecosystem more than before. Yeah, that's my opinion.
Okay, Leo.
Yeah, so I guess like from SciSec's perspective, we also want to emphasize decentralization is a key, but it might seem a little bit strange for hardware company to say something like this. Yeah, but we will have some like products like the ZK accelerator as small as an iPad charger, but still be much powerful than a GPU card. Yeah, so yeah, it will be in the market probably next soon.
Yeah, like you.
The first one is I think we need more this kind of customization with better modularity. Then for more and more these application demands, right? So we can provide better sort of solutions for these protocols or applications. The second thing is, of course, it's about the decentralization of the entire rollup stack, because it's not just for decentralization of the sequencing. It's also about like the decentralization of the prover, proposer, batcher, or different roles in the entire rollup stack. We should really decouple the L2 or this rollup into multiple different components, and then have better decentralization for every different components. Yeah.
Yeah, and Joe.
Yeah, I think you know, we have many rollups building today, and we'll continue to have many more. And overall, it's not a zero-sum game. I think it's important for like L2s to know that we can also like work together, and also the rollup expansion is not only happening in the Ethereum ecosystem. We're not also seeing it happening in like with Bitcoin. And so we're kind of like, you know, the Ethereum rollups, we're kind of like on the frontier of pioneering the rollup technology, the designs, and all the infrastructure setups. And yeah, so like there will be, you know, different rollups to tailor to different market needs. And I think, you know, we're still early, and for there are also still a lot of problems to think of, like we discussed today. Share sequencer and like how to bring gas fees lower. Yeah, so I think you know, in general, I would say like more collaboration and more discussion. Yeah.
Yeah, totally makes sense. I'll probably add my comments to this question as well. So I think interoperability is super important. Right now, I think like it's sort of like fragmented. Everyone is trying their own like different approach. I think there should be like more collaboration. And the users shouldn't suffer from this fragmentation, right? They should view like a rollup as sort of like a one ecosystem. That's from my perspective. The second is still the gas cost, right? So I think that's the sort of like the number one issue or the number two issue that from like blocking the users, especially the new users coming to the Web3 space, right? So I think that's the second priority. I think the third priority is the decentralization, as everyone talk about it. But I think decentralization is, well, we will spend some time on figuring out how to decentralize like different components. But like I'm a big believer in Vitalik rollup centric mode, and I think eventually we will get there. So thanks a lot for everyone for sharing the insights, and thanks to the audience for your time. And it's a wonderful conversation with you guys. Thank you.
Thank you.
Thanks, everyone.
Thank you. Let's
Thank
give it
you.
up
Thank
for
you.
our panelists and moderator. And please remain on stage for a photo together. Shall we stand in front? And let's stand a little bit closer together for a photo. All right, towards the center, towards the center. 1, 2, 3. Fantastic. Another big round of applause for our panelists and moderator. Thank you so much for an excellent presentation and insightful sharing on the topic ecosystem applications. Thank you, guys. Please be seated. So, ladies and gentlemen, a gentle reminder for all of you, the forum provides a simultaneous interpretation service. You can use WeChat, Twitter, browser, etc. to scan the QR code of simultaneous interpretation on the signage at the entrance of each venue or the conference brochure and listen to simultaneous interpretation through your mobile phone. You're recommended to bring your headphones to the venue in advance. So for those who forget to bring earphones, you can receive a free pair by following these steps. First, take photos of the relevant activities inside the event venue or download event photos from the online album. Secondly, post the event photos on Twitter or WeChat Moments with the tag Hong Kong Web3 Festival 2024. Lastly, show your social media posts to the information desk at the entrance of each stage or at the event center to receive a pair of earphones. So now, moving on to the next session. Let's give the floor to Mr. Sandeep Nirwo, co-founder of Polygon. Ladies and gentlemen, a big round of applause for our next speaker, Sandeep. Round of applause, please.
Hello everyone. So I have 15 minutes only. So I'm going to talk about the age of aggregation, as we say. When I say age of aggregation, I mean to say a specific thing actually. Let me go to that slide. Last year, monolithic and the modular, basically mostly modular blockchain in the last 6-8 months has been the major talk of the town in crypto, right? That modular blockchains and this and that. And I'm going to talk about that how, and you are already seeing that these modular blockchains where you have multiple layer 2s, layer 3s, and the liquidity starts getting extremely fragmented, and how the aggregation is the end game, on top of the modular theory. So let me go back again. And I wanted to first talk about what does Polygon stand for and what is the goal of Polygon. And I said that basically this the blockchains enable this open and trustless digital world, which obviously provides the more freedom and equal opportunity and empowerment to everyone. And we believe that this trustless environment should be scaled to the level of internet. And for Polygon, the goal is to scale this blockchain space to the scale of internet. That's the main goal. And that is where we believe that this aggregation mechanism, the aggregation design, actually is probably the only way to scale blockchains to the scale of internet. And so basically, you see till 2023, primarily the blockchain space consisted of these monolithic blockchains. Very few blockchains had come up which are modular in nature, but then primarily it was Bitcoin, Ethereum, Polygon POS, Solana, and so on. And these blockchains have very good, relatively very good user experience for the composable applications. But beyond a certain the moment you want to have a certain amount of scalability, even let's say take an example of Solana, which is very highly scalable, but then still it has a limit of maybe 5,000 to 10,000 transactions per second. The moment you start attracting a lot of users onto your chain, suddenly the blockchain starts hitting the scalability limits. Then in 2023, late part of 2023 and the early 2024, we are seeing this modular world where so many roll-ups, layer 2s, layer 3s, these roll-ups are launching. And now as a user, it's extremely, extremely difficult, right? Because you have to bridge your assets from one chain to another. You don't know what kind of security assumptions you are taking when you are bridging from one chain to another. And other kind of user experience related problems are coming up. So, and the popular modular stacks are like, OP Stack, Polygon CDK, you have like Arbitrum Orbit and all that, and there are hundreds and hundreds of these blockchains already, already coming up. And by the end of this year, I think we are going to have around 1,000, these layer 2, layer 3 blockchains. And it's going to be extremely problematic for users to actually move around their funds, and the liquidity gets fragmented. So this is where I was saying that, from monolithic we went to modular, but the next step is aggregation. Now, I'll tell you more about like what is the meaning of aggregation and what we are doing, what Polygon is doing on the aggregation layer. So what happens in the aggregation, what you are saying with the aggregation layer is that these modular chains are there, like, for example, A star, ZK, VM, Polygon, layer 2 chains, other layer 2 chains, even layer 1 chains. All of these chains are fragmented. What we are doing with aggregation is that we have this layer called, we call it ag layer, aggregation layer, which essentially, using the ZK technology, zero knowledge technology, aggregates these state machines. Each of these blockchains are essentially separate state machines. And what the ag layer does is, when it gets the ZK proofs to it, it combines all the ZK proofs and create like one single ZK proof, one single global state root. Like basically you can say the ledger of all the ledgers, right? It creates one single place. And then once you have that, then the funds or like your assets, your information can move from one chain to another in a very, very fast and trustless manner. Like then with using ZK technology, you are using mathematical proof to bridge from one chain to another, to move your, to move your information, let's say events or basically messages from one chain to another in a seamless way. Like right now, I'll give you an example. Right now, when you are moving from your bridge, you're bridging your assets from chain number 1 to chain number 2, and you are using a bridging service, like it can be any kind of bridging service, you are relying on 3 layers of security. You have the first bridge security, then you have the first chain security you have to rely on, then you have to rely on the bridging security, and then you have to rely on the chain 2's security, right? And we have seen how many bridges have collapsed. In 2023 itself, I think people lost like hundreds of millions of dollars because of the compromises in the securities of the bridge. So with the ag layer, you don't have that issue, because all the chains connected here, they are submitting their ZK proofs. And once the ZK proofs are aggregated together, it has a one single kind of mathematical security across all the chains. And that helps you unified, that helps you unifying the liquidity, where you have liquidity connected across the networks. You have on-ramp, off-ramp integrations. We have this function called like bridge and call function, for example, which we say you onboard to any chain, and then if the chain is connected to ag layer, you can seamlessly move without you as a user knowing it. You can seamlessly move your assets to the to other chains. And similarly, cross-chain transactions, like let me give you an example. Like for example, let me give an example with the A star ZK VM. Like with the ag layer, if you are using, let's say you are playing some game or you bought some NFTs and you want to swap those NFTs, or you want to, let's say, sell your gaming tokens, whatever gaming tokens you got into the ZK EVM, which is a public chain and has more liquidity, you can just click a button, and in the background, all this process happens trustlessly, not like, you relying on anybody's, safety and security of any third party. So, and then all these, like when this happens, as a user, all these chains start feeling like one single large blockchain. And that is the goal of this aggregation layer, that all the chains connected as a user, you just come to one chain, no matter which chain it is, you just get onboarded. After that, you don't have to, you don't even know that which blockchain you are interacting on, as far as they have some level of mathematical security with the zero knowledge technology. So I was saying that, fast cross-chain transactions, bridged assets, there's no need for bridged assets causing liquidity fragmentation, and so many other things, right? The first one is also very important. Like, for the blockchains, this composability is one of the biggest feature. Like, one application can interact seamlessly with the other application, and that is possible with this aggregation layer. There are multiple components to this. As we said, that the unified bridge, which basically is one single bridge, which kind of provide all the cross-chain and all the cross-chain liquidity movement and all that. We call it unified bridge. Because previously, some of you might know it as LXLY bridge. And the other thing is proof aggregation. You aggregate all the proofs and submit them as ZK proofs on Ethereum. So all the chains are secured by Ethereum. But now with the ZK proof and the unified bridge, you have liquidity flowing across seamlessly. Like this unified liquidity is probably the most important element in this, because blockchains are essentially like these, we call them like, it's internet of value, right? And value can flow around. And think of it like compared to the internet. Like current internet, Web 2, is the internet of information. And information can seamlessly flow from one network to another network. Like today, when you onboard, you can use any of your device. You can use your computer, mobile, any device. You can connect with CDMA. You can connect with broadband. Any kind of internet connection, you are connected to one single network. Similarly, the purpose of the ag layer is no matter which blockchain you are connecting and you are using, as a user, you don't know. For you, this is just trustless internet. You are interacting with blockchains, and there is nothing else you need to worry about. That is the end game, and that is the end game for Web3. Like I'm saying, maybe Polygon does it, maybe some other protocol does it, but the end architecture which takes blockchains to the internet level scale will look something like this. And will look like something like aggregation layer. And we are already seeing a lot of aggregation-related projects coming up in the space. And maybe, by the Q2, Q3, Q4, or early next year, you will see a lot of projects talking about aggregation. This is already happening. And Polygon is, pioneering this. And then other part is obviously needless to say, when you can have like these thousands and thousands of these chains, you can have unlimited scalability. Like I'm not saying like 10,000 TPS, 50,000 TPS, 100,000. I'm saying unlimited TPS, like billion TPS. This network, by the end of this year, when it has, let's say, 1,000 rollups connected to it, like not end of this year, maybe like end of next year, each chain can do, let's say, 1,000 TPS. So with the 1,000 rollups or 1,000 chains connected to this network aggregate will have probably 1 million TPS, right? So the TPS is actually a very bad metrics, but I'm just saying that, because in crypto we care a lot about this TPS metrics. I'm saying this single aggregated network will have like million, and it can scale up to even billion TPS in coming future. That's the future we are building towards. And what it essentially means is you have unlimited scalability, just like the way you have today on the Web 2 internet. You have unlimited number of mobile apps, almost unlimited number of web apps, and nobody has to think about like, oh, we don't have enough scalability on the server side. And then, I already mentioned about this, that Polygon, what is Polygon? Polygon is this aggregated blockchain. Like after multiple years of research, many of you guys might know that in ZK, Polygon is the, has emerged as the most pioneering team. Plonky 3, which is our Plonky 2, Plonky 3, our proving system, is now being used by like almost all the top teams in the space. So now after all of these years and years of this research, we reach a place where Polygon is essentially this aggregated blockchains. Thousands and thousands of blockchains can connect to one single layer, and then for the users, they can feel one single blockchain. And previously the panel was there and we were talking about layer 3s. When this aggregation layer comes, then there is no use of layer 3s also. Everything can be a layer 2 without the cost. Right now what happens is if you are a layer 2, you have to post the data and the proofs on Ethereum directly, which is very costly. So your gas fees also goes up. Right? I mean, you can post the data somewhere else, but even the proofs are costly for you to put. But when you have aggregation layer, which is combining all the proofs and putting all the proofs to Ethereum in one single shot, then what happens as a rollup, you don't need to be a layer 3. You can be a simple layer 2 and just post your proofs to the aggregation layer, which is extremely cheap. And you can almost have layer 3 like low gas fees, but you are still a layer 2. And more and more blockchains are going to choose this. When we speak to them, they are all like, when the ag layer comes, they all want to be layer 2s. Nobody wants to be the layer 3. Even for their valuations, it's actually a little bit not conducive. And then this is the last message, that we all know that, I want to end with this, that we started with this monolithic phase where, in 2017, 18, where you have Bitcoin, Ethereum, you had many blockchains talking about it. Then we had even Polygon, POS became very popular. You have Solana and many other blockchains. They were all monolithic blockchain, but one single blockchain. Then last half of the year of 2023 and the early part of 2024, it has been all about modular. But modular, we are already hearing fragmentation issues, right? This is too much fragmentation for users. It's really bad. And so aggregation is the next stage of modular. And you are right now hearing it from me. But mark my words, by Q3, Q4, you will hear a lot about aggregation. And already we can see the whole category exploding. So many projects raising funds and things like that, doing their VC rounds around aggregation. So this is the next, end game and the next stage of crypto, and probably the end game of, blockchain scaling. And then finally, there are already large quality projects which are building on this aggregation layer. You have Immutable, the largest gaming platform. You have OKX, one of the largest, exchanges launching their chains. A-Star, even layer ones like Near Protocol are connecting to this, and you will see more and more and more applications and chains, app chains and ecosystem chains launching on this. Thank you so much, guys. I am up on my time. Thank you.
Thank you. Big round of applause for Sandeep. Thank you so much for the inspirational presentation. Thank you. And please be seated. Thank you. Now, ladies and gentlemen, moving on to our next session. Let's welcome our next speaker, Mr. Sam Sell, Representative Director of Clayton Foundation, and he's going to share with us the topic, Creating Asia's Leading Blockchain. Without further ado, let's give him a big round of applause.
Okay, hello everyone. My name is Sam. I'm a representative director at Clayton Foundation. Today, I'm going to share a Project Dragon that's actually integrates Clayton and Finshare to create Asia's leading blockchain. So here's the background. The Web3 industry is growing, and so the market cap is also growing. And we haven't seen a lot of mass adoption of Web3 technology in different areas. But if we look at the Asia's market, and then the Asia's total global GDP is about 35% in total. And also, if we look at the transaction volume of cryptocurrencies in Asia, and then that is about 78%. But if we look into the value of the mainnet based in Asia, then it's very fragmented and it's only about 4.9%. So we thought that if we combine our efforts to create a larger and more synergistic ecosystem, and then we thought that we can reach out to the next level and we can make a bigger and more synergistic ecosystem. So this is the summary that our proposal. Actually, we proposed this 2 months ago to Clayton and Finshare's both governances, and then we got approval from the both governances. So in summary, we want to merge two chains, Clayton chain and Finshare chain, with the aim of establishing Asia's leading Web3 ecosystem. So Clayton was initiated by Kakao, which is one of the largest IT company in South Korea. And Clayton, since the beginning, we have been focusing on a public blockchain and public infrastructure and Web3 DApps and so on. On the other hand, Finshare blockchain was initiated by Line probably quite a similar time in 2018. And it has been focusing on more Web3 production by focusing on the conversion of Web2 application and Web2 users to Web3 services and Web3 users. So by merging these two, we believe that we can build the largest or Asia's number one blockchain in terms of infrastructure and Web3 services. So just for your backgrounds, the Kakao is one, as I mentioned, one of the largest IT company in South Korea, which has more than 96% of market share in terms of messaging services. But apart from messaging services, it also has gaming and content and finance and also mobility services. And it's a quite dominant IT platform in South Korea. And they started Clayton 2018, and this is a summary of Clayton that I'm working on. So Clayton is an EVM comparable public layer 1 blockchain, and it was started in about 5 years ago, and it has been providing high performance environment for developers and for users. So it provides 1 second block time with immediate finality, and it has more than 4,000 TPS in terms of throughput. And unlike other blockchains, it uses Istanbul BFT. It's a kind of PBFT algorithm, and so it has a set of validators like on the right side. So it has it's called Clayton Governance Council. Currently, we have more than 30 members in our council, and it's growing as well. So Line, I believe most of you heard about Line Corporation. It has a long history, more than 20 years, and it's a Japanese messaging service company, and is in terms of MAU, its global MAU is more than 193 million. And it has many members over the world. And they also, interestingly, as I mentioned, is very similar time, around 2018. They also launched their own blockchain platform called Lime Blockchain. And then they have been also developing their blockchain for more use cases. And their blockchain is called Finsia. And originally, their blockchain was called Lime Blockchain. And then at the time, the Lime blockchain was a kind of private blockchain, but recently they changed their blockchain to a public one. And public one is called Finsia, and then they have been working with many Web2 companies and users. And they also have governance structure consisting of 15 global companies, and also they have many use cases, mostly from Web2 use cases. So that means they apply the Web3 technology and Web3 environment to Web2 services. So by merging these two networks, and we can create a more a bigger environment and bigger Web3 ecosystem. So that means, as I mentioned, Clayton was backed by Kakao and KakaoTalk, and Finsia was backed by Line, and by merging these two, we can reach out to a huge user base. It's around 250 million users, especially in Asia, and we can have more than 420 DFs and services. And in terms of governance, we can build the largest governance structure in Asia, that has more than 45 members. So our vision of this chain merge is to achieve mass adoption of Web3 in Asia and throughout over the world. So our strategy to achieve the mass adoption of Web3 in Asia and in the world, our strategy is like this. So we summarize 4 main strategies to establish new layer 1 and to facilitate optimal competitiveness and growth. So first thing is, of course, as I mentioned, we have a huge user base in Asia, and it's about 250 million users, and we can reach out to them with Web3 DFs and also Web3 technology, and of course, we can connect this user base and new services onboarded on the new chain, And that would be the first strategy we want to focus and we want to utilize. The second strategy is, of course, tokenomics. We have experience of long history. Both chains have a history of more than 5 years. That means we had a lot of trial and errors in terms of tokenomics and in terms of use cases. So we think that the next tokenomics for this new chain will be more enhanced and with more the burning models or more sustainable models. And that is the second strategy. And the third strategy is about technology. Clayton is based on EVM, and on the other hand, Fincha is based on Cosmos, the Cosmos technology. So, you know, you might think that these two are very different technologies, and it will be very challenging to combine these two. So, but, you know, the cost EVM, today we talked about a lot of layer 2s and even layer 3 to enhance the scalability of Ethereum. And also there are different EVM chains, and we know that there are many developers and services that are relying on EVM. But on the other side, there is also Cosmos, and their Cosmos network is also growing, and their technology is a bit, it's different from EVMs, but in essential, they want to also make a more adoption of Web3 technology. So our strategy for technology is to combine these two to create a more interoperable and more compatible network with existing layer 1 and layer 2s. And the last but not the least is about governance and decentralization. You know, that Clayton and Fincha were initiated by bigger companies in Asia, but we have been trying to decentralize our networks in terms of governance and in terms of participants. So we, as I mentioned, we'll create a more bigger governance structure by merging these two governance structures. And also that means we'll have more participants in the network and we'll achieve more decentralized network. So a bit more specific things. The first thing regarding the strategy. So we know that we saw that the Bitcoin ETF brought a lot of liquidity to the industry, and then also we know that many institutions are interested in investing and also exploring this area, and we thought that the network and the ecosystem should be ready for these institutions, and that means we'll be ready for these institutions' demands. And again, our heritage is in Asia, and so our blockchain will be, even though we'll be expanding to the global, but we'll be Asia-based and Asia-first blockchain. And decentralized and governance perspective, again, we'll build a bigger governance that has more companies and more project teams involved in this network. And again, we'll be a more decentralized network. And the second strategy, specific strategy for our network is, that we have strengths, especially in Web 2 and also in Web 3. Clayton has been more focused on Web 3 projects and the crypto-native projects, while the Fincha has been focusing on the Web 2 use cases. The Web 2 use cases mean the connecting Web 3 and Web 2. So by merging these two, we have a broad scope of coverage. So because we can connect Web 2 use cases and Web 2 services and Web 3, so that means we can conduct this kind of two-track strategy to achieve more use cases and to onboard more developers and users. Third, interestingly, even though two projects have been focusing on the Asian region, we don't have many intersections because the Clayton has been very strong in South Korea, and we have been expanding to Singapore and Vietnam. On the other hand, the Fincha was initiated by Line, and their base is in Japan, and because of the Line Corporation, and their user bases are coming from Thailand and Taiwan and Indonesia, and the foundation is based in Abu Dhabi in UAE. So that means by merging these two ecosystems, we could see more coverage in Asia countries, and we'll be expanding more to other countries in Hong Kong and in Greater China area as well. So yeah, as I mentioned that Clayton is based on EVM and Fincha is based on Cosmos and Cosmosm. But if we look at the current landscape of programming languages for smart contracts, Solidity is the mostly used smart contract language at the moment, but it's more than 60% at the moment. So Clayton is very strong in supporting EVM and Solidity and their programming environment. But if we look at a broader landscape of programming, then there are other general purpose programming languages like JavaScript, Python, C, and Go and Rust. And WASM is more suitable to support these kind of general purpose languages. And the Cosmosm is ready for this kind of support. And by merging these two technologies, we can provide more, convenient or more advanced environment for developers. So that's our vision, and that will maximize interoperability and compatibility with existing technology and the future technology as well. Lastly, so if you look at the governance structure in Clayton and the Fincha, we have, as I mentioned, we have governance council members in both chains. But if we look into the token distribution of two networks, and in Clayton, the token distribution is a bit centered on big companies like Kakao. But in Fincha network, the token is distributed more to the holders. But by merging these two, we can have this kind of distribution. That means no one is able to handle all the governance in the network. So the governance will be more decentralized, and the token distribution will be more balanced in the new network. So this is our roadmap. We proposed this governance proposal in January, and we got approval in February. And both foundations are working hard to make it happen. And the new token and new chain will be released in June. And in parallel, both teams are working hard to merge different ecosystems and different communities. And lastly, okay, so this month, because of the time limit, I was a bit fast. So this month's new brand for the new chain will be released soon, and then please stay tuned. Probably at the end of this month, new brand will be revealed. And again, in June, we'll have a merged network launch, and new technology, token, and ecosystem and governance will be announced in June. Thank you for your attention. Yeah.
Thank you, Sam. Big round of applause for Sam. Excellent presentation. Thank you very much. Please be seated. So now, ladies and gentlemen, we're going to delve into another topic, onboarding next generation of users onto Web3. And without further ado, let's invite our next speaker, Mr. Patrick McCrory, researcher of Arbitrum Foundation. Ladies and gentlemen, please give him a round of applause.
Hi guys, I hope everyone's enjoying the conference, by the way. I love Hong Kong, it's a great place to be. So, my name is Patrick McCrory, and today I'm going to present about onboarding next generation of users on the Web3. But before I get in the Arbitrum, I want to take a step back and just remind everyone, what makes Ethereum so special? Why do we care about Ethereum? Why do we care about blockchains and Web3? And hopefully that will allude to the fact of why we should care about Arbitrum as well. So I'm sure some people here work in finance. We put our finance hat on. And when we care about Web3, what we really care about is transaction insurance. So if Alice gives a coin to Bob, who's responsible for making sure that Bob only gets one coin? Bob doesn't get 2 coins, Bob doesn't get half a coin, he only gets 1 coin. And it's done in a timely manner.
So the first thing we care about is reachability. Who can Alice transact with? Then we care about who enforces the rules. Who makes sure the transaction executes as expected. And finally, auditability. So let's say I want to look at a transaction 10 years ago. How can I verify that transaction was actually done correctly as well? So in the Web2 world for the past 30 years, we've always had to rely on a trusted intermediary like a bank or an institution or some company to facilitate transactions. And so we rely on that company to also enforce the rules. That will be the human deal, handling the deal, or it will be the software run by the companies to make sure that the transactions automatically get processed. But the problem comes up with auditability. How can I verify that the company's doing the right thing for all their users' transactions? As a user, there's no way I can check. If I go to HSBC, they're not going to let me check their database to make sure they're doing their transactions correctly. So we have to trust the employees with access to audit their transactions. And we have to rely on a third-party audit company, the Big Four. They have to get to the company's database, look at the books, and they have to go, I think the company's doing the right thing. And so in this scenario for the past 30 years, it's so easy for things to go wrong. Software bugs can go unnoticed, humans can make mistakes, and bad record keeping. I'm sure people here work in finance. Guys, raise your hand if you have to deal with spreadsheets. Spreadsheets? Over there, look at all those spreadsheet guys. It's so hard to keep a spreadsheet up to date with accurate and correct information. It's a really, really hard task. And so it makes it really difficult to audit and keep factual data as well. And ultimately, a company could also disappear and not facilitate the transaction at all, which is why regulation is so important in this world to make sure that users are only interacting with trustworthy institutions. So with that in mind, what makes Ethereum so special is that it's an entire field of engineering on trust, auditability, and safety. That is the focus of Web3. Now, what's nice about Web3 is that I can interact with anyone on the internet as long as they have an Ethereum address. But most importantly, who enforces the rules? Anyone can. I can download the blockchain software, I can run the blockchain software, and I can enforce the rules of the network alongside everyone else and everyone in this room. We don't have to rely on a trusted intermediary to do the right thing. And auditability. Again, if I run the blockchain software, it's very easy for me to audit historical transactions. I can fetch a transaction on Ethereum from 10 years ago. I can look at it and say, yep, that transaction was processed correctly according to the rules agreed at the time. But of course, in Web3, bad things can still happen. It's very difficult to implement secure smart contracts. And actually, there's too much transparency. Ethereum and Web3 are the most transparent systems we have ever built. They are literally exceedingly transparent, which makes it bad for some financial applications. So stepping back again, what makes Ethereum so special to begin with? Ethereum allows anyone to check the system is alive, its integrity is intact, and to transact without trusted intermediaries. What we're really trying to do in this field is replace human trust with cryptographic proofs. And if you recognize that that line is from the Bitcoin white paper over 14, 15 years ago now. This entire field focuses on removing human trust as much as possible. But thanks to that vision, we can transfer assets without a bank. We can vote without a tallying authority. We can have auctions without an auctioneer, and we can trade without an exchange. All these applications exist today on Ethereum and other networks, and they're used every single day. But unfortunately, as most people here are probably aware, Ethereum is too expensive. I would probably argue today, in my professional opinion, and of course as an argument, that Ethereum is probably more secure and decentralized than Bitcoin. But with great security comes great cost. So 2 weeks ago, I had to deploy a Gnosis safe, a multi-sig wallet, and it cost me $100. It's not very accessible, it's way too expensive for the everyday user. I did not want to pay $100 for that transaction. So the open problem we're all trying to solve, all of these layer 2s, can we build a system that can inherit Ethereum security, Ethereum level security, but with low fees and high throughput? Is it possible to take assets that live in Ethereum, move it to an off-chain system, transact as much as you want here, and then bring the funds back to Ethereum but while still inheriting the security of Ethereum itself. And it is possible. All the roll-ups and layer 2 protocols, including Arbitrum, are trying to solve this goal. And Arbitrum relies on fraud proofs in order to facilitate, in order to inherit the security of Ethereum. So it is possible. So layer 2s and roll-ups like Arbitrum are trying to extend Ethereum with a low fees, high throughput. There's low cost transactions. We're doing our best to have it secured by Ethereum, and it's drop-in compatible. What's really nice about networks like Arbitrum is that you have the EVM, you have Solidity, you have your wallets, your infrastructure, all the dApps. Everything works just like Ethereum, but it's faster, it's cheaper, and I don't know, it's a much better user experience in my opinion, at least anyway. Now, Arbitrum has 2 different networks currently. There's Arbitrum 1 and Arbitrum Nova. Historically, Arbitrum 1 has been useful for DeFi and NFT. It's typically called the home of DeFi in the roll-up world. And then Nova focuses on gaming and social. Now, what I really like about having 2 networks for Arbitrum is that really roll-ups are a place for experimentation. They allow us to test out different configurations and features. We can play with the block times, the gas fees, the virtual machines, the transaction ordering policies. We can have these rapid experiments to work out what's better for users and what's better for developers. What's also exciting, and actually at the foundation, I spend most of my day with the community, with the Arbitrum DAO. Both chains are governed by the community. And the DAO has 2 mission statements. One, it's up to the DAO to decide whether to upgrade the Arbitrum networks. And they also have a treasury that they can spend on initiatives as well. And they're exceedingly active. They're always catching me off guard, to be honest. So you can read the transparency report, you can go on the forum and see what the DAO's getting up to. Now, I'm a researcher, I like experiments, but that's not really useful long term. We need production-ready systems. And Arbitrum is running in production, it's very popular, and I believe Arbitrum 1's been running now for 3 years. I think they launched in, I think it was around September 2021, if I remember right. So Arbitrum 1, currently has around $15 billion locked into the system. In terms of TVL, it represents 40% of the rollout market share. There's over 2,000 dApp integrations and over 18 million unique addresses. The Arbitrum ecosystem is alive and well. As I mentioned, it's basically the home of DeFi for layer 2s. You have Uniswap, SushiSwap, OpenSea, GMX, Camelot, TreasureDAO, whole host of dApps living and running on Arbitrum every single day. And they call Arbitrum their home as well, which is really cool. And also, TradFi institutions are now also supporting Arbitrum. So there was this announcement recently with Robinhood, where in the Robinhood app, you'll be able to interact and swap cryptos using Arbitrum in the back end. So that's also really cool. Now, that's the ecosystem part of it. Again, I'm a researcher, I care about technical excellence, and Arbitrum really strives for that. So one thing I like to highlight is actually, who's aware of L2Beat? Raise your hand if you know L2Beat. Interested. Cool. Some people in the audience know who L2Beat are. So L2Beat is like the referee for all layer 2s and rollups. If a rollup makes a security claim, L2Beat are basically going to validate whether that security claim is correct or not. So they're the referee holding us all accountable to the claims we make about security for our rollups. Now, what's nice about Arbitrum 1 is that Arbitrum 1 is currently the only rollup with a general purpose EVM that's considered a stage 1 rollup. Now, we're ahead right now, but of course, this is a competition. Every single rollup is competing in terms of security, to become a stage 2 rollup and to be the most secure rollup. And I like to call this out because I really love the fact we're in an industry that focuses on security and protecting users' assets, and we have an independent referee who's always holding us accountable. So that's fantastic to have in any industry, especially for cryptocurrencies. Now, in terms of technology as well, I mentioned before, Arbitrum relies on fraud proofs to protect the system. It's called an optimistic rollup. Now, what the foundation has funded is research into a new protocol called Bold, which will hopefully be the holy grail of what we want for an optimistic rollup. It's a fraud-proof system that's permissionless that would allow anyone in this room to participate in the fraud-proof game. So we've funded the research. Hopefully it's going to be announced soon. And hopefully you guys could use it someday to protect your own Orbit chains in the future. And hopefully you'll get in the Arbitrum one as well. Another piece of work the foundation has funded that I'm also really excited by is called Stylus. So rollups are an exciting place because our goal is to look and feel like Ethereum, but we can go further than just Ethereum. And Stylus is a good example of this. So even though we'll have the EVM and Solidity smart contracts, we will also have a WASM virtual machine environment where you can implement a Rust smart contract, and your Rust smart contract can interact with Solidity smart contracts as a first-class citizen. So we sort of call this the EVM Plus, because it's the EVM plus WASM plus Rust, and they're all first-class players. So I'm really excited for that. We funded that work, and hopefully it'll be announced soon. And if you ever attend hackathons, it's already available to play around with, test out, deploy dummy Rust programs, and get your hands dirty. So the last thing I want to finish on, and I've sort of believed in this vision now for many years, is that rollups are really a tech stack. If you consider the Arbitrum chains like Arbitrum One, Arbitrum Nova, that's sort of like the testing ground, the battleground for getting this tech ready before everyone begins using this tech stack. A bit like Linux, it's going to go everywhere. And so I stole this quote from Loy Lu and Conduit, where rollup is the new server. So I would expect in the next 5 years, anytime you deploy a new server or a new database that interacts with crypto assets, you're probably going to use a rollup as a tech stack. A bit like how you deploy Linux, you're going to deploy a rollup stack on top of that to handle crypto assets. And so at the foundation, we spend a lot of time working on the Arbitrum expansion program. This is where we change the license to make it easier for people to take the Arbitrum tech stack and deploy it for their own network and their own chain. And we call this the Orbit chains. And it sort of reminds me of this old quote. So many years ago, I was an intern at IBM for a year. So I remember this quote where Thomas Watson said, I think there's a world market for only 5 computers, and he said that in 1943. On hindsight, that's a really dumb statement, isn't it? Because there's computers everywhere now. And actually, as I was writing this slide, I realized, oh, there's already more than 5 rollups. So we've already invalidated that statement. There's more than 5 rollups today. There's going to be hundreds of rollups in a few years. As I mentioned, rollup is the new server. It's going to be everywhere. And Orbit is one tech stack that you can use in order to deploy your own rollup as well. And Orbit is getting popular. There's currently 20+ Orbit chains announced. Some Orbit chains have already been, during the panel session, some Orbit chains were discussed already during that panel session. That was really cool. I had to Google it myself to make sure it was Orbit. But generally, there's lots of Orbit chains coming through the pipeline now, and I'm really excited to see people use this, tech stack. And I think for Arbitrum, Arbitrum was founded in 2018, if I remember, so it's been under development now for 6 years. So I'm really excited for people to actually use the tech stack in production for their own business needs and for what they need. And that's it. That's my final slide, guys. So thank you very much for listening, and I hope you have a great time at the conference.
Thank you so much, Patrick. A big round of applause for him. Thank you for an informative and insightful sharing for us. Thank you. Please be seated. So now, ladies and gentlemen, we're going to look into another topic, converting cloud to crypto. And without further ado, let's invite our next speaker, Mr. Sriram Kannan, CEO of Eigen Labs. Let's give him a round of applause, please.
Good afternoon, everybody. Welcome to my talk. I'm Sriram Kannan. I'm founder at Eigen Layer and CEO at Eigen Labs. Really excited to be here. In my previous life, I was a professor at the University of Washington, Seattle. This talk today is our vision. It's called Converting Cloud to Crypto. See the image here. I know some of you may recognize what's happening to the cloud, and that's what our goal is. So when you think about applications, you can think of applications in 2 dimensions. Applications need throughput, and the other dimension here is very unique to crypto. We think about how much value you're transacting per byte of transaction. So crypto applications today are not only low throughput, but high value. But to really get to powerful, consumer applications, we need to look at the cloud. And cloud applications are high throughput and low value. Each byte is low value, but together they add up to a lot of value. And what we're looking at is how do we bring cloud applications to crypto? Converting cloud to crypto, that's our goal at EigenLayer. Why do we need to convert cloud to crypto? Crypto brings certain special properties. What are the properties? Crypto brings native incentives. You can program incentives into the structure of the application. It brings user governance. We say democracy is when the governed can govern. And in technologies, including social networks today, as a user, you have no governance rights. We want to bring governance rights back to users. And the third one is permissionless innovation. How do you ensure that anybody else can build on top of your products, your services, in a rigid manner, enabling permissionless innovation? So these are the values that crypto brings. But today, cloud apps also need high throughput, and we need to be able to reduce the cost for byte of transaction. So, this is a perfect follow-up to Patrick's talk from Arbitrum. Rollups, we argue, are the perfect fit for consumer apps. Why do we say that? Rollups usually have a single sequencer. This sequencer can act to give instant confirmation, giving you the same UX that you're very used to when you're interacting with the server. Because rollups have configurable execution engines, you can start building general-purpose virtual machines, game engines, AI inference, all of these things natively on your rollups. You can start thinking about how to build applications without requiring necessarily crypto wallets. One of the main things that's happening today is when you're interacting with an application, you need to have a wallet. When you're interacting with a crypto application, you need to have a wallet. Why? You need a wallet because you need the wallet to pay the gas fees. What if you had a single sequencer, the sequencer can actually authenticate you in other ways? Already we are seeing the emergence of account abstraction, where users can be authenticated, not based on whether they have the fee or not, but based on whether they are a valid user inside your own system. And finally, when you build rollups, all of these rollups have composability with other rollups built on top of Ethereum. You can reuse the existing liquidity, but also reuse existing features built by other rollups from your own rollup. So all of these, I think, combine to create something really powerful in the rollup economy in Ethereum. But rollups do have some problems today. What are these problems? So the first one is throughput. If you're a crypto developer, one of the biggest things you worry about is, do I have enough block space? But nobody building on Amazon or Tencent worries about cloud space, because cloud space stretches to fit the demand. They will put more servers if you have more demand. The cost economics of rollups are also in jeopardy, because when you're thinking about a rollup, you actually face high uncertain costs. As opposed to if you're building on the cloud, you have guaranteed cost basis. You can reserve an instance, you know exactly how much it's going to cost, so you're building a much more reliable business. Security. You can try to compromise security and get these other properties, throughput and economics, but you lose the whole point of crypto. And finally, you want features. We mentioned different kind of execution environments, encryption, all these other features. And cloud comes with a massive array of software as a service tools that let you build applications without having to reinvent the wheel every time you need to use a new feature. I'm going to talk about how EigenLayer, on EigenLayer, we're building a new service called EigenDA, Eigen Data Availability. This is a mechanism to support rollups. When you're a rollup, what you're doing is you are moving execution and creating a mechanism to prove that you're executing the right thing to Ethereum. But you still need a place to publish the data. And that's what EigenDA does, is it creates a mechanism, a highly decentralized mechanism built on top of EigenLayer, which brings the trust network of Ethereum, portions of the Ethereum trust network, to actually support other applications. So the first, I'm not going to talk about how EigenDA works. That's going to be out of syllabus for today. I'm just going to talk about what features it actually offers. Throughput, the first feature. When you think about a data zone, you think about 3G, 4G, 5G, like your cell phone, the first thing you think about is what is the rate at which it runs, how many megabytes per second can it process. And that's the same metric you need to think about when you're thinking about a data availability system. EigenDA runs at 10 megabytes per second. But while running at 10 megabytes per second, it doesn't require, there are many mechanisms of scaling. One mechanism of scaling would be to say that every node that needs to participate in the network needs to have a really beefy, high-power machine with a huge amount of networking. But that's not how EigenDA is built. It's built with each node can have a small amount of bandwidth, but together, they're able to contribute the bandwidth to something much larger. And the principle is, this is why EigenDA is able to get orders of magnitude improvement over crypto scale today. And the reason is, in crypto today, decentralization works against scaling. If you want to make your system more decentralized, you have to make sure that the node requirements are small, which means you're not getting scale. In EigenDA, decentralization is scaling. Why? Because we're able to integrate the data bandwidth across all the different nodes so that the net performance of the system is the sum of all the bandwidths of all the nodes that participate. So our goal is to scale the throughput of data on EigenDA to gigabytes per second and one day even terabytes per second. So the next thing is economics. When you think about the economics of building a roll-up, I'm now comparing it. Earlier, I compared it to the cloud. Now I'm comparing it to building a layer 1. There are certain ways in which roll-up economics is not really competitive with layer 1s. The first one is the data costs. To write data to Ethereum, the costs are very high. Not only the costs are high, the costs are uncertain because you'll be using your rollup, writing data to the common Ethereum data pipeline, and then what could happen is there is a new NFT drop somebody else is doing, another rollup is doing, and that interferes, that contests, that congests the common network that you're using. So DA cost becomes uncertain. Suddenly the price shoots up. And then the next thing is, unlike a layer 1, a rollup takes exchange rate risk. What is the exchange rate risk I'm talking about? If you're a layer 1, you fix a certain amount of inflation of your token to pay for validators. But rollups actually have to pay fees in a different token in an uncertain exchange rate. And finally, rollup tokens do not have any native utility in their system. Unlike if you're a layer 1, your token's actually securing your network. So what happens with EigenDA is all of these change. How do they change? The first one is because we have plentiful data bandwidth, the cost is low. Not only the cost is low, we have a mechanism called long-term reservation. Just like you go to the cloud, you go to Amazon and you can reserve a certain instance just for running for you. You can actually reserve a certain amount of data bandwidth just for your rollup on EigenDA. This bandwidth is uncontested, uncongested. Nobody else can use it. It's only for you. And the next feature in EigenDA is you can pay for data availability in your own native token. You don't need to take an exchange rate risk. You can have a fixed fraction of inflation of your own token to actually pay for data availability. And finally, rollups can use their own token using EigenDA in what we call dual staking, where data availability is guaranteed not only by each stakers in the Ethereum Trust Network, but also by your own token holders and your own quorum. They participate in securing the data availability for your network. How does EigenDA bring all these features? Because it is an Ethereum-centric data availability system. So the way we think about it is, you look at Ethereum, there is a fundamental problem, which is there's a lot of rollups, but there's not enough data bandwidth. How do we actually build this? How do we bring the security of this as close as possible to Ethereum? You can never get exactly the same, because a natively integrated system is always better, but how do you approximate Ethereum security closer and closer? And EigenDA is built on several aspects. of security. The first one is ETH staking. So Ethereum stakers stake ETH and participate in EigenLayer, and they commit to also participating in EigenDA, the data availability system. Operators in Ethereum are already decentralized. We can bring on board a lot of them into EigenDA and bring the decentralization back into the data availability system. And finally, I mentioned EigenDA supports dual staking, where you can use your own native token, your rollup token, to secure the data availability using the EigenDA software, but not only now running ETH staking, but also running your own token staking. So all of these tie together to ensure that the system is as secure as possible. Finally, when we think about features, I highlighted 4 problems earlier: throughput, cost, security, and features. What features are rollups missing today? Ethereum's data bandwidth is limited, and what you can do is, on EigenLayer, not only we have EigenDA, but there is a large ecosystem of services building on top of EigenLayer. The first example is EigenDA, and what that does is to scale the data bandwidth from 80 kilobytes per second in Ethereum to 10 megabytes per second on EigenDA. The next thing is the Ethereum finalization time. When you write a transaction into a rollup, it needs to be returned to Ethereum, and Ethereum needs to finalize. It takes 12 minutes for Ethereum to finalize a block. How can we get super fast settlement? Other layer 1s have really fast settlement times. You can actually build a super fast settlement layer on top of EigenLayer. There are many coming up. We're working with Near Protocol, for example, on a super fast settlement layer, but there are many others as well which can actually do this, and you can bring finality time of your rollup to less than 1 second. Rollups rely on single central sequencer for ensuring censorship resistance. If you want to build decentralized sequencers, there are many protocols building different kinds of decentralized sequencer. AltLayer has a protocol called Restaked Rollup, which bundles several of these features and allows you to run decentralized sequencers. Espresso is building a shared sequencer where a common zone orders transactions across many, many rollups. Bridging. When you want to bridge it from one rollup to the other, you have latency problems. Each rollup needs to settle back to Ethereum. Arbitrum takes 7 days to settle back to Ethereum. And if you want to move an asset from one rollup to the other, it's going to take you 7 days. Can you actually do anything better? If you incorporate restaking, what you could do is, once a bridge has a measurable amount of economic security, let's say your bridge has $1 billion of economic security, it can let you mint and wrap assets worth $1 billion within that 1 week period. So what you get is you can actually get instant bridging across different rollups, where you can even move value and create new services on top of the rollup economy. MEV is a major problem. How do we do transaction ordering while managing MEV? There's a whole bunch of MEV services like threshold encryption coming up on EigenLayer, which can actually solve some of the problems. Finally, we talked about limitations and how EigenLayer can solve some of these limitations. But you can also add new features which never existed before. You can have new oracles secured by Ethereum staking. You can have transaction activation. You can have two-factor authentication. You can have trusted execution environments, fully homomorphic encryption, ZK-proof verification, AI co-processors, a whole host of really powerful services coming up on EigenLayer. When you integrate with EigenLayer, you can start consuming these services to provide a really rich ecosystem of services to your own rollup. With that, I conclude my speech. Thank you so much for listening.
Thank you, Shriyam. Fantastic presentation. Thank you very much. Please be seated. So ladies and gentlemen, apart from the exciting programs at the main stage and the substages, you can also visit different booths at the venues where you can collect stamps from the booths of the organizers, title sponsors, platinum sponsors, gold sponsors, primary, secondary, tertiary exhibition sponsors. And when you collect a certain number of stamps, you can claim a gift at the information desk. And please be aware that the number of gifts are limited, so it's served on a first-come, first-served basis. So make sure you collect enough stamps. Also, you can redeem a t-shirt at the information desk on each day by collecting all stamps on any one of the 4 areas. Also, do follow Web3 Festival at festival_Web3. And also do tweet a post with HK hashtag Web3 Festival 2024. Show your post to our staff at the information desk and you will win a gift from the information desk. So moving on to the next panel discussion, we will dive into the topic, the new trends in Layer 2. And without further ado, let's welcome the panel moderator, Mr. Keith Chen, Managing Partner, SNZ Capital. Round of applause for our moderator. And also our fabulous panelists. They are Mo Dong, co-founder of Breakfast. Georgie Corelli, founder of Hinkao. Fabio, co-founder of Paddle Labs. And last but not least, Dennis Song, Chief Security Officer of Mind Network. Welcome, panelists. And now I'll pass the floor to our moderator. Over to you now.
Good afternoon, everyone. And thank you very much for your time being here. So I am Keith Chen, Managing Partner of SNZ Capital. SNZ Capital is a crypto-native fund. We supported Ethereum in early days since 2015 with a lot of our OGs, including Hashi Capital, definitely. We are here today to just give this panel to discuss about Layer 2 and also the new technologies. So definitely as a crypto fund, our main mission, one is definitely to support the innovation. The second one will be like to facilitate the communication, to communicate between those projects, the community, and the West and the East. So we dedicate to those missions in the past about 10 years. Today, we'll please welcome our founders here. So to start, I just want you guys to give a very brief introduction of yourself and also the project of you guys are doing. Yeah.
Hi everyone, I'm Mo from Brevis, and we are working on ZK coprocessor to enable new exciting use cases for blockchain.
Yeah, I'm Georgie. I'm from Stanford. I'm founder of Hinkao, which enables private storage and execution environment for Ethereum and EVM dApps.
Hi everyone, I'm Fubiao from Paddle Labs. I'm co-founder of this team, and we trying to use cryptography technology like synology proofs, homomorphic encryption to library the data and the computation for the end users.
Hi everyone, this is Dennis from Mind Network, and I'm the Chief Security Officer. We Mind Network are using full homomorphic encryption to help secure the consensus of AI network.
Good. I think in early this afternoon we have a lot of updates from the famous layer 2s like a Polygon and also Stockware, and also just previously Arbitron and Sriram from Eigenlayer. So in this session, we are more going to explore some of the new challenges and the new innovations in, in layer 2 or beyond. So to talking about a lot of those innovations, I think we're gonna, explore different directions. But to better facilitate the conversation, I think I will dig a little bit more into each project of you guys. Then we're gonna take a little step back later on to talk about in general the layer 2 innovation and the trends. Hopefully at the end of the talk, I know some of you guys are developers. Hopefully their experience can give you some of hints and stuff. Let's start with in general. I think I want to set up the problem. So when you guys choose the direction or the problem you guys want to solve, right? So what kind of come to your mind why this is the problem you're gonna choose? And your solution and at a very early stage. Yeah.
Sure. So first of all, layer 2s are amazing. Layer 2 blockchains, and now we're in this multi-blockchain world. one way to kind of look at this is that we look at the analogy in computer history, right? So like layer 2s and this multi-blockchain ecosystem is like evolution from like a single core CPU to multi-core CPU, right? So like in computer history, you have the single core CPU, you can just like do one task at a time. And now we have like Ethereum and then multiple different kind of layer 2 growing on top of Ethereum, where you can essentially parallel the capacity of this entire blockchain ecosystem. But there's a challenge. The challenge here is that every single one of these layer 2s are still essentially blockchains themselves. And they share the same nature of blockchain because they're still deeply rooted in this distributed consensus systems. And the result of that is that just like CPUs are not good at certain type of computation, and for these Web3 CPU, which are blockchains, essentially the blockchain construct, they are also fundamentally bad at certain type of computations. And specifically, what are they? They are data-heavy, data-driven computation and very complex computation. You just simply cannot put that in smart contract and in blockchain directly. And one example that I always take is that if you look at every centralized exchange, you have this kind of a VIP fee discount where you trade a lot, and then based on your trading volume, in the next month you get the discount. But if you look at every single decentralized exchange, including Uniswap and everyone, none of them actually has this feature. The reason to do that is as simple as computing a user's historical trading volume directly on blockchain is prohibitively expensive. To do that on Ethereum, it takes about $40,000 in gas cost, plus like 4 hours of computation time. So even if you do it on layer 2, it is still prohibitively expensive. Now, how do you solve that problem, right? So, we need to kind of just like draw analogy again, the inspiration from the computer history, where, for CPUs, we actually introduced something called a GPU as a CPU's coprocessor to offload certain type of computation that is very hard to do on CPU to this GPU component, then return result back to CPU. And this is why we have amazing graphics. So this is why we have like a machine learning models and all that stuff. So for blockchain, we also need to introduce a coprocessor. But the key thing here is that we actually need to maintain a trust-free nature of this entire computation cycle, where we basically kind of can still relay many of the computation of this special component, and then relay this result back to blockchain without any trust in this third-party component. So this is where Brevis comes in play, where we introduce a ZK coprocessor that enables various different type of computation and data access on historical blockchain data like events, states, and the transactions to entirely just compute it as off-chain, but we generate zero-knowledge proof to put it back on-chain for smart contract to consume. One simple way to look at this is that basically you're enabling a Dune analytics dashboard for your smart contract, right? So like, if you're just looking at Dune analytics dashboard every day, they are for human and off-chain entities. But we're enabling that type of visibility and the computation capability for smart contract, and this is where we think we should push the frontier for blockchain.
So the key word here is like a ZK coprocessor.
Coprocessor, yeah.
Okay, great. Georgie.
Yeah, with Aptos, we are currently arrived to the point where finally institutions can come to blockchains and have similar user experience that they have on centralized exchanges. They can move assets. They have composability of liquidity. And with this in mind, one crucial point that we are solving is privacy. So, but actually, I don't like calling it privacy. I prefer calling it confidential environment because privacy was a bad word used by bad actors before. And the way we approach this problem is how can we make sure we can plug in current liquidity, current DApp experience, and with one click of private mode, enable full confidential execution environment on your current dApps. And that's what we solved with Hinko. So you can, swaps on Uniswap, provide liquidity on Curve, stake on Convex Beefy. Now we're adding Pendle as well. So you have end-to-end experience without withdrawing your assets with your private address inside smart contract. And this private address is compliant because we also use the term reusable attestation. So you can basically attest that you have done KYC somewhere in internet before, and you can reuse this attestation with Hinkle proving that you are not illicit actor. And then what we are focused on is removing all necessities for bridges, for separate liquidity, so you don't need standalone L2 to enable privacy, right, and private execution. You won't be copy traded. And one more use case that we are focused on that actually is very relevant to the current market is private liquidations of tokens. So now with the bull market coming in, a lot of need is how can you liquidate tokens in a fully private environment, but also receive these tokens privately. And Hinkle enables this in also very compliant and fully confidential DApp set ecosystems such as Uniswap or OTC desks.
So I think most of the layer 2 solutions provide a nice scalability solution right now. And from our perspective, we think it's a time to pay more attention on the application layer. So that's why Polkadot actually want to build something more relevant to the user's data. So because the logic is like in the traditional Web2 economy, the user's data has been proven very valuable, and especially on the private data. And the Polkadot's idea is we would like to create a compliant and fully secure technical solution with the technology of cryptography. So for example, we think the user can truly control their own data by first they can retrieving their data from different Web2 data sources, and then they can freely share their data, which can help them to gain some benefits from that. So in our first step, we have built the ZK attestation solution, which leverages the technology of zero-knowledge proof, which can first guarantee the user's data is truly from that web data source. And also, we can guarantee the user's data will be used in a privacy-preserving manner in different applications, and they can gain benefit from that. So a very simple example is, for example, you have some, say, some crypto assets in the off-chain exchanges, and traditionally you cannot doing that in different dApps. I mean, the exchanges, they just use this data for themselves, and the data cannot be leveraged or be shared with their on-chain smart contracts. However, with Polkadot's technology, we think it's possible to help the user to first prove their data in the centralized exchanges, satisfy some certain condition, and say, for example, they can prove their wallet balance in some exchanges is more than 1,000 USD, and they can show this proof to a decentralized application, and then they can potentially get some rewards from that. So this makes a very a new paradigm for the end users to leverage their existing web data. And of course, there will be some other challenges in building such kind of solution. For example, how we can guarantee the user is powerful enough to do this kind of data computation. For example, if the user using some mobile phone, and people know that generating some zero-knowledge proof is quite costly in such kind of resource-limited device. So in that case, we need to delegate this kind of computation to some external node. And how can we guarantee the security in that new data sharing process is another challenge. So to sum up, I think we have seen there are some more opportunity and their business chance to leverage the users' private data in Web3, while we can still keep their data safe and be more valuable to the end users.
Okay, great.
Yeah. From our perspective of view, we also think that keeping secret on blockchain is a big challenge. Because we know that in blockchain, we just achieve the consensus based on open information. We just broadcast the data, the parameters into P2P network, and everyone can get to access this information. This works well in traditional blockchains. However, when it comes to, for example, AI networks or deeping, there's a problem here. Because for AI networks, no matter the income parameter or outcome result, they are all very valuable considering the computation power consumed. So the operator knows they don't want to their results to be copied or to be stealed by others until their result is officially accepted. So we cannot use just such kind of the open information in plain text. Then my network, we worked out a solution which is empowered by full homomorphic encryption. In our solution, the consensus of AI network or DP network, they can be achieved from ciphertext. This eliminates the risk of the leaking secret. And our users, they can also stake their tokens in our FHE restaking layer, and they can contribute to secure the consensus of the AI networks.
Great, thank you very much. And I think the talk is pretty technical, but definitely I want to give some kind of keywords to each of the projects. Definitely for Brevis is ZK coprocessor, and for Georgie Hinkle, it's more like account-based like a privacy wallet. And for Pado, I think it's more like a ZK FHE. And for my network, they're also using the FHE to build in their network. So that's, I think, the keywords for those guys. But to explore a little bit more of each of the projects, I'm going to throw like specific questions to each of them. This actually covers like 3 different sectors. One is ZK, and the other one is privacy, and the next one will be FHE. Is a pretty new technology here. Definitely, I want to go with the Georgie first. So to you, definitely privacy, like you mentioned previously, used by a lot of those bad actors as, when you mention privacy in blockchain, usually people give a really negative feedback. So, but definitely, I think privacy is a kind of in my mind, is like one of the big issues we have to solve in blockchain anyway. Then to your point, now I think in between privacy and the compliance, there's a huge gap. I think people also talk about it, but in your point of view, how could what's your opinion about this kind of balance? How do you guys in Hinkle to balance this problem?
Yeah, definitely. It's a big issue, and we started Hinkle right after the cash sanctions. So it was our main priority. How can we combine both compliance and privacy? And then we have solved this with several layers of compliance, I would say. So first, we integrated several KYC DID protocols, such as ZKMe, Authento, so users can pass KYC or reuse previous attestations with those protocols. And second, when we realized that actually not all of our users have these attestations, we thought, how can we simplify even here user experience and enable more people to come on and enable mass adoption, right, without everyone just manually plugging KYC and KYB data. Though none of this KYC or KYB data is stored with us, right? I want to make sure that this data is stored either, it's not stored anywhere with ZKMe, so it just uses ZK solution for this, or it's stored with certified KYC providers, right, like Web2. And then in order to simplify even this user experience, we enable reusable attestations through centralized exchanges. So most of users have Binance, Coinbase, or other exchange accounts. So when we already added Binance and Coinbase, so users can just prove that they have Binance account, and now they're able to become private and have end-to-end confidential experience on their dApps they're using with just this attestation. And then every 6 months, per regulation, they just have to re-log in and prove that they still have this Binance account, and this way we solve the problem of compliance, right? And then I think the second question here around compliance is how we can make sure that institutions that currently use Hinkle, feel comfortable using it and can share data about their transactions with their LPs, right? And to achieve this, we have built an attestation system inside the protocol where users generate, when users join Hinkle, right, they generate private address, and this private address is decrypted with private shielded key. And every time they do transaction on external dApps, they generate zero-knowledge proof to smart contract and stealth address, one-time stealth address, and then Relayer executes this transaction on external dApps. So the question is that if all this transaction is with ZK-based and no one knows who is the owner of this transaction, how can they prove to their LPs as well as to other entities that they want to share this information, let's say accounting companies, that they did these transactions. And for this, we have built a system where they can plug in viewing keys and automatically generate all data about their transactions and share with their LPs or with whoever they want. So it took us some time to build, but now it's live on 7 chains with 7 highest TVL dApps, and most of them are on L2. Actually, in fact, we have the biggest traction on Base, and we see a lot of demand for private transactions coming from there, also because we removed all these barriers to adoption.
Thank you. The next question will be for Mo. I think in ZK space that evolving so fast, right? I think in the past few years we witnessed a lot of those, even algorithm or other like hardware acceleration, all kinds of stuff. So, but one of the interesting thing you guys did, I think last year, was the benchmark test. So yeah, just one quick question for you is how's that going, and what's your next plan on that benchmark test stuff?
Yeah, definitely happy to share more on that. So for the ZK benchmark thing we basically want to look at what is the landscape for zero-knowledge proof stacks today. Like what are some of the frameworks that the developers can use? Because as Keith mentioned, there are a lot of changes over the last 3 years. That a framework that might be the best choice in maybe just last year might not be so this year anymore. So we did a very extensive benchmark testing across all ZK frameworks, and I realized that the answer is definitely more nuanced, because it really depends on what type of application and what type of infrastructure you want to build with each of these stacks. And generally, if there are any builders and developers in the audience, we generally find that Gnark from Consensus team actually offers very, very high performance, out of the box, and coupled with solutions like Ingoyama's hardware acceleration, it can really do magic. And this is what we are kind of choosing for our stack as well, to optimize for both the algorithms to build the ZK coprocessor and also the system to make this entirely parallel and with multi-level aggregation, and finally with very strong hardware acceleration. The exciting thing about this is that the more we do this, we start to realize that the ZK coprocessing and the ZK computing overhead is not as bad as many people would think, right? So before, 1 year before, we should probably be looking at 1 million time inflation in terms of the amount of computation you'll be looking at for each of these ZK coprocessing and ZK computing for the same thing, right? But right now, I think we're pushing very, very close to 3 orders of magnitude, which makes many use cases very attractive. Even for things like ZKML with cross-stack optimization to utilize certain properties of the machine learning model itself, and also combine that with a ZK design, proper ZK design to cater to that, you can actually achieve very, very close to native performance when you are also doing ZK proof of the model, which can bring a lot of exciting use cases to the table as well.
So how a Brevis is gonna use all those TK technologies in the coprocessor? Then, for example, nowadays where people, I think in the research side or engineering side, we talk a lot about folding scheme or like a new ZK EVM. So in a previous kind of like a scope, how do you utilize that? Or what kind of technology you guys gonna exploring?
Yeah, we definitely, as mentioned, like we basically kind of tackle 3 different directions. One is on the algorithm side. We did a lot of the innovation in the algorithm side to kind of find the best kind of proving stack, and also the algorithm to do very efficient multi-layer aggregation. We're also doing a lot of work on the GKR stack to kind of make things super fast. For certain type of computation. But very importantly, we also want to make sure that while we are optimizing for specific type of circuit, we still maintain the generality of ZK coprocessor, right? So like because Brevis is a smart ZK coprocessor, you can use it to actually build and integrate it into your application in whatever way you want. You actually don't need to use any ZK circuit or write any ZK circuit to integrate that into your in your product. So that's one front. And then we work very extensively on hardware acceleration as well. So we actually kind of have our small cluster data center in San Mateo as well. So like that really helped in terms of like accelerating things. And finally on the system side, right? So because we don't want to make sure, we just want to make sure that the entire system is entirely parallel. So when the load of the entire system is increased, we can keep adding load to this system stack as well. But finally, I think there is a role for crypto economics in the ZK coprocessor space as well. We're working very closely with EigenLayer to launch previous AVS and to enable things like crypto economic-based proposal plus ZK challenge architecture that is like going to bring the ZK coprocessing cost down a lot.
Thank you. For the next question would be for like FHE related. So for Dennis and also for Fubiao, you guys are working on FHE related stuff. So one question is for definitely for Pado. So currently, I think on the market there are at least like 3 companies working on FHE. So what's the difference of Pado you guys worked on, and what's the benefits all the other developers can get from?
All right, thanks. That's a good question. So FHE is, right now we have seen a lot of projects like Zama, like Phoenix, and maybe more pioneering projects bring this new crypto technology into this industry. So I think most of the interesting here is fully homomorphic encryption is quite powerful, and basically he can support arbitrary computation on the ciphertext. So just imagine you as a user, you have some private data and you want to do some computation, but if the computation is too complicated, for example, you want to contribute your data to a machine model training, then definitely your device will be not supportive, and then you need to delegate your computation to some other powerful node, so which is called outsourced computation. And the FHE actually can provide a very perfect privacy for this kind of outsourced computation paradigm. I think this is the most significant property which provided by the Zama or some other projects in this area. For example, they use FHE to provide the FHE-based virtual machine or FHE-based rollup or some other new blockchain design. And definitely this will provide a very nice and flexible privacy from the design perspective. And however, Pado's solution is called ZK FHE. So we know the zero-knowledge proof, technically, it can provide the scalability for some applications like layer 2. However, an unusual fact is zero-knowledge proof, in some circumstances, it's not provide privacy. So it's quite unusual. Just considering a user want to generate as a zero-knowledge proof, and if the user, I mean, his device is not powerful enough, he will definitely delegate this proof generation to some other worker. And due to the security property of the Zenor proof, if the worker doesn't know the witness, I mean the secret information within this kind of proof generation, then the worker will not be able to generate the Zenor proof. So in that case, the ZKP solution will not provide this privacy. But FHE solution, actually, people just care about the privacy, but it cannot provide the integrity. So in the FHE solution, the worker can do some outsourced computation on this private but encrypted data. But on the other hand, we cannot expect that the worker is honest enough. So the FHE guarantees that the result will be privacy preserving to that user, but the worker itself can doing something like a random response to this computation task, but you have no way to distinguish this random response from a honest worker. So in that case, we definitely need a kind of security called integrity within such kind of computation process. So that's why we, as Polkadot, we provide a new, I think new but also very, let's say, win-win solution of FHE. We call ZK FHE. Yeah, so we kindly can provide both privacy and together with the computation integrity during such kind of FHE computation. And also we're trying to provide some performant protocol design from scratch. Yeah.
Good. The next question will be for Dennis. So I think FHE is really like a good, new technology. So what FHE actually mean to you guys, and what you guys are gonna use FHE as a network or in the architecture-wise? What are you guys gonna use FHE?
Yeah, just as Fubiao said, FHE is actually outsourcing computation. So this kind of outsourcing means two things for us and our AI blockchain partners. First is confidentiality, which I've just mentioned before. It's about the secret. And the other is about flexibility, which means with FHE, we can actually use flexible forms of consensus. This is important to AI, because for traditional consensus, they are simply, they are very simple, and they just simply based on the exact match by comparing hashes. However, in the scenario of AI and the deeping, the parameters or the results, they normally are approximation. They are not exact values. This means that by comparing hashing, this simply doesn't work. And on the other hand, FHE, it can do this job very well. So we worked out our solution, and our solution consists of three major parts. One is the security layer. In this layer, we just use FHE computation nodes to compute the parameters of consensus. And of course, they are encrypted, so these nodes can freely joined by any third party, and the user, they don't need to worry about the leak of the secret. And the second layer is called the consensus layer. It is supported by EigenLayer. We use EigenLayer to enhance our own security. And since the computation of FHE is deterministic, so they can achieve their consensus in this consensus layer, which is an Ethereum rollup. And the third layer of our network is the FHE restaking layer. So the normal users, all the stakers, they can just stake stake their token in our staking layer to help to secure our AI partners, our deeping partners, help their blockchain to secure their consensus. So that's our architecture.
Sounds great. I'm gonna jump out a little bit. So because I think in the past, half an hour, we just explored all those what all those guys are doing, but definitely we're exploring some of the new technologies and opportunities. So I think in the Ethereum roadmap, thanks for Vitalica and the Ethereum Foundation. So the roadmap is laid out really well. I think everybody can explore. But beyond that, for each of you, what kind of opportunities you saw, or like a new technology you guys see from there, and any kind of like a new technology or new trend gonna play a great role in the future blockchain development? Yeah, I will just like start with Mo. So.
Yeah, sure, definitely. So, I think, I'm mostly looking at this trust-free computing and, coprocessor and asynchronous computing space. And there are very exciting things that are happening. One thing is that ZK machine learning, right? So, people say that there is no use case for ZK machine learning, but the way I'm looking at ZK machine learning is, are really twofold. One is that it's really a test station and a showcase for the entire ZK community to say, okay, as long as you can process and deal with this type of large model, any type of computation then is possible in ZK, right? So, the push to the ZK machine learning space is very exciting because it introduces this kind of arm race process to generate many, many new innovations in the ZK underlying space in both cryptography, in hardware acceleration, and also in the algorithm and the system side of things. So that's one thing that is particularly interesting. But another thing, I'm also very interested in, the second fold for ZK machine learning is that there are actual use cases that you can actually see today, right? So there is a large untapped opportunity in blockchain space today that is kind of active liquidity management or protocols that can manage liquidity on behalf of users, right? So, but this type of things is just simply not possible without both the ZK co-processing capability and also the machine learning capability combined together. So yeah, that's something that I'm super excited about in the next couple of years.
Yeah, ZK machine learning. How about you, Georgie?
Yeah, I think there are two layers, right, that I want to emphasize. First is moving from transparency, and then, when we, for example, share about privacy, like regular users say, isn't it the core use case of blockchain to have transparency, right? Why would they need privacy? And I think we should shift our mindset completely from transparency to accountability, right? Because with privacy at place, your transactions are still on chain, so they're verifiable and therefore accountable. But they're not transparently coming from you, right? So there is no way for anyone, for Akraham basically, or for Nansen to dox your wallets and to show everyone, right, and run bots against you. And that's the biggest problem, right, in the educational piece, right, with this idealistic mind in place that Ethereum and Vitalik and Ethereum Foundation outlines. It should be always transparent, people should emphasize, but for real world adoption, that's not the use case, right? We want blockchain to become reality for every human, for everyone to just plug in wallet or just even without knowing wallet, right? To be able to have verifiable transactions, composability of these transactions, and then derivatives from on top of that, right? With full ownership. And with this, we should completely shift our mindset. And second vertical that I would emphasize is adoption, right? So in Vitalik's roadmap, there is no mention of, how can we bring broader adoption to Ethereum and, EVM chains, as well as Aptos, right? Outside of core, TPS improvement or technology improvement. But there is a lot of work to do, right, to emphasize this direction. How can, for example, BlackRock deploy like 5 billion assets instead of 200, right? And there are several primitives that should be met to enable this use case.
Good. How about you, Fu Biao?
Yeah, I think for talking about the new technology and new trend within the Ethereum ecosystem, so like Mo said, ZKML will definitely be an interesting new topic. And for me, I think another interesting thing about attestation, and also I think Henka mentioned that. So attestation actually is not only about the on-chain part. You can definitely claim your, for example, on-chain activities or on-chain reputations from the third-party issuer, but also you can bring your off-chain historical data to the blockchain as well. So also we can think about how, let's say, using the zero-knowledge proof or some other secure technology, we can truly prove our off-chain record and bring this kind of private data, kind of private oracle to the smart contract, and then we can really build a kind of non-DeFi applications, which will be definitely more excited to the data-driven economy. So yeah, that's my pretty much my yeah.
Dennis.
Yeah, I'm excited about two areas. One is BTC rollup, and another is AI rollup. One is the biggest blockchain, and the other is the most important new industry. And neither of them works well directly with EVM. So there are big challenges. But both of the rollups, they are very important to the Web3 world. Yeah.
Thank you. I think we are in the very last minute. I just want to give you guys like a very simple like a wrap up and like just how people can follow up with you. Yeah.
Yeah, feel free to follow us on the Twitter. Our Twitter account is Brevis_ZK. And yeah.
Yeah, please follow Gigels on Twitter, Gigels on Telegram, and yeah, Hinkel is live on 7 chains with all end-to-end experiences. So just plug in, open it up, and become private.
Yeah, and you guys, you can follow us from Twitter, Polkadot Labs, and also our website, polkadot.org. You can simply click that and can download our Chrome extension and then have a try about ZK attestation and ZK FHE as well.
Yeah, you can also follow our Twitter, and actually in May we will launch our mainnet of FHE restaking. So maybe you will be interested in staking to our restaking protocol.
Thank you very much. Thank you all for your time and the really good sharing. And I hope that you guys, have some key takeouts from here. So thank you very much.
Thank you. Let's give it up for our panelists and moderator. And please remain on stage for a photo together. It's lovely to have you all here today. Thank you so much for such a great sharing. And let's stand a bit closer together for a photo. All right, let's smile at the camera in the front. 1, 2, 3. Fantastic. Another round of applause for our panelists and moderator. Thank you so much. Wonderful discussion, everyone. So it's definitely lovely to have so many industry experts, investors, enthusiasts here to exchange thoughts and share insights with you all. So do feel free to reach out to them or follow them on social media. I'm sure they're more than happy to get to know more about you guys and share more ideas and insights with you all. So moving on, we'll have another panel discussion. Next, let's try to understand the global landscape of Web3 from the investment perspective with leading investors around the globe. And without further ado, let's welcome our panel moderator for our next panel session, Mr. Ryan Chan, Managing Partner, Hashkey Capital. Big round of applause, please. Also, our fabulous panelists, they are Mr. Lasse Clausen, founding partner of 1KA, so big hand for him. Mr. Rodney Jessup, partner of Hack VC, round of applause. Mr. Vineet Bucky, Managing Partner and CEO of Cyber Capital. And last but not least, Mr. Gavin Wang, CIO of SNZ Capital. And now I'll pass the floor to our moderator. Over to you now.
Thank you. Hi guys. Hi. Good afternoon to everyone tuned into the frequencies of blockchain's future. Today, we will try our best to navigate a digital ledger deeper than a submarine in the trench, accompanied by 4 titans of venture capital who have seen more ICOs than most of us have seen crypto meme coins. So let's blockchain the talk, okay? As we set sail, so let's first chart the waters of blockchain's current and the future vistas, I would say. So considering the shift in global finance and the technology, how do you view the future trends of blockchain technology and its applications? So, and if you dare to venture, which emerging sector excites you the most? So let's say begin with Lasse.
Yeah, hello everyone. My name is Lasse Clausen. I'm one of the founding partners of 1KX. We're one of the earlier funds in the space. First fund actually to focus exclusively on tokens, on digital assets. As the firm has grown, we also venture out a little bit as well, but we're generally an early stage investment firm. So we're a venture capital firm that invests in the crypto ecosystem since 2017. And I think coming back to your, to your question broadly, I think it's almost like the lowest common denominator right now to predict on how this is going to be used at a larger scale. I think there seems to be now some consensus forming in TradFi as well. It's mainly from, led by Larry Fink, the CEO of BlackRock, that, sort of tokenization of real world assets, which basically just means that we use blockchain and crypto infrastructure to do, trading, clearing, settlement, which is, if you look at it, what happens in the real world, you buy, a stock on Robinhood, there's this insane, inefficient, slow process happening in the background of, trading on Robinhood, then clearing, and someone's trying to figure out, did Robinhood sell enough of the stocks that I actually theoretically have an IOU on? They do the settlement, the clearing, and then the settlement. That takes like 2 days. So there's trillions of dollars of capital just like locked up in all these different towers full of people with different spreadsheets, just trying to figure out whether my number in the spreadsheet actually matches what your spreadsheet says. And then whether, if you just compare that to a trade on a decentralized exchange, trading, clearing, settlement is all one and the same thing. It happens basically you're in a second or less, depending on which L2 or L3 you're on. That's it. You have no counterparty risk. You have no, provably impossible for any operator fraud to occur on the exchange level. So I think that's kind of like what I see now. It seems to be like the lowest common denominator to just, take some real world assets, tokenize them, and then use basically blockchains, decentralized exchanges, lending protocols, etc. Which for us is actually kind of basic now. Anyone's been in the space for a long time. Most of this DeFi stuff is called basic DeFi primitives, but they are actually 10, if not 100 times better than if you really look under the hood of an equity trade, for example. There's also a really interesting number. I think it's 10 or 15% of all global bond trades fail. So they think they've done the trade, and then in the settlement and the clearing process, something goes wrong and the trade just didn't happen, right? And so I think that's like the lowest common denominator, a big one where, we just have to settle on, do we trust, I don't know, that Citigroup issues some tokenized asset, and then on-chain you believe this is real, you don't really question the redemption mechanism too much anymore. The same way it happened with Wrap Bitcoin, right? We know now except, like, who here has had Wrap Bitcoin in some form in the wallet, and who here actually knows how the redemption process would actually work, how long would it take, etc. Right? So that's sort of like, kind of, I guess, what in-depth more answer of mine. Where do we think we're going to settle on like a larger kind of use case? So what about you, Ronnie?
Yeah, quick intro. I'm Rodney, Hack VC. We're based in North America. We're a crypto-native venture capital fund that with like a big developer community. As for where I think the crypto space is going, it's pretty interesting to see a lot of different pieces of technology coming together, over the past few quarters. AI in the real world has been a big topic over the past few years. And at the same time, I think like crypto's going through another, Cambrian explosion of innovation, with a lot of people looking at a lot of new categories of business. And within the world of crypto AI, I think we're definitely going to see a lot of really interesting, use cases on the supply side and on the demand side come together. Specifically, the stuff I find most interesting is like decentralized compute, especially because like compute for the AI side, for like image or video rendering is 5 times more lucrative than compute for the Web3 side. Yeah, it's just going to be interesting to see how all of this plays out over the next few quarters, and I'm really looking forward to having an outstanding application on the crypto AI side become popular in the future. Yeah.
Good evening, guys. This is Vineet from Cypher Capital. We are a $100 million fund based out of Dubai. Over 400 investments across last 2 funds. Some of them are Sui, Sei, all the big names out. Well, coming to the question that you asked, I think we're too early in this sector. When we look at the numbers, Crypto.com came a report that there's 400 million wallets out there, which basically means if I assume one wallet is one person, it's 4% of the world's population. And personally, I believe out of that 400 million, 90% are just waking up in the morning to see BTC price. They really are speculators who have no clue how crypto is changing the world. So I think we're too early. It's someday you will have 1 billion+ users. Someday people will start using blockchain for real world transactions. It can be either RWA assets where people tokenize their real estate. It can be something like a WorldCoin, which is actually digitizing a person into a hash rate, so that it's something like the Aadhaar card in India. So I think use cases will take time to come around. We're too early. We are like in the 1990s .com crash where everyone wanted to build up a amazing website and raise millions on it, and use cases later on followed. Now, personally for us as a fund, we more or less invest on teams who have track record of building something, and the idea makes certain sense. But if you look at the flavors that have been growing, I think in the bear market, everyone was investing in things that could last longer. You had the infrastructure layers where people were raising $200-300 million to survive the bear, and you had Suis of the world, Seis of the world. But coming now, it's all about, I think, people are looking at how can users come on board. How many highways are you going to build with layer ones? And then you need cars on them. You need dApps that can actually get users. So for us as a plan, we are investing in things like games. I think games is the best way to get users on board. I think last season was all about games that had great tokenomics. This season and next season is all about games, having real games where people play these games. We're looking at RWA as a sector. I personally am very bullish on NFTs, especially ordinals. We've been investing a lot on Deepin as well. One of our investments, Peak, is making a lot of news as well around that. So these are 4 or 5 sectors where we think users will come this season, and that's what we are investing in. Cool. Thank you.
Okay, cool. Hi, everyone. I'm Gavin, I'm CIO of SNZ Capital. I'm based here in Hong Kong. And we have been working together with Hashkey Wanxiang Group for nearly 10 years. We have been the earliest supporter for Ethereum back to the old days in Shanghai, and have been actively engaged in community, like a developer community, like incubation as well as investment. Currently, we run 2 books. Like one is like principal book is more founders money. The principal investment, a very flexible mandate. Actually, we are LP for Hack VC and Hashkey Capital as well. So with lots of making lots of partnership. And the current focus is on the venture side. So the venture is focusing on early stage, like pre-seed, seed investment. I think the other 3 honorable guests also made very good point regarding to the potential massive adoption. From our side, like 2 very high level kind of investment thesis and focus, right? The first one is like taking digital asset as an emerging asset class, right? It's an alternative asset class. The wallet share, the penetration rate is going to pick up. That's an inevitable trend, right? To address those needs, getting along with this trend, you will have all the infrastructure, as Lassie mentioned, like so the trading facility, settlement, etc. That's for sure is very, it's really necessary, and it's happening in minutes, right? Because you can kind of imagine back to 1917s when you are doing stock trading in the exchanges. I need to say, hey, like so $1 to buy one like a fall stock or whatever. It's like you just see yelling. It's like a supermarket, like a supermarket, right? But now it's like later on they move to like electronic trading. Then you have like lots of unicorns, like huge companies like winning in that trend, right? So blockchain for sure is like on one hand, because of the digital asset, in essence, it's a different kind of asset. There will be huge like adoption. On the other hand, like as an infra layer, it could provide tons of potentials. To give you an example, like JPM coin, right? JPM has like 1 trillion JPM coins, purely helping like the overseas branches to do like settlement, clearance, etc. That largely enhance like the efficiency, right, for them. The second investment thesis we're looking at is like blockchain as a kind of a like tech development, a disruptive tech innovation or business model innovation. What kind of the real demand they can address? If we are thinking of like people are sometimes like talking, well, this is Web3 festival, right? So we are moving from Web2 to Web3. Personally, I think it's still not there yet, especially when we compare to mobile internet, right? If we consider mobile internet is Web 2.5, you can see like from Web 2.2 to Web 2.0 to Web 2.5, there's a huge kind of a change. So, for example, right, if you don't have this kind of location-based services, you cannot have a Uber, right? This kind of then this created tons of real demand that people, you will engage in daily lives, right? So for crypto nowadays, like mostly people, the demand is still around trading, earnings, stakings, etc. To some extent, well, this is something controversial, right? Some people may argue this is not real demand for a normal layman, right? So then the idea is like some of the other guests mentioned, like okay, gaming and the other emerging application, whether they can like bring the normal layman to join the Web3 world, join the blockchain world, that could potentially open a new, new area. So that's what we will be very excited about. Yeah, thanks.
Thank you, guys, for the introductions and the insights. And so let's talk about more sweeter investment strategies. So I'm curious, when assessing investment opportunities, which factors are most important to you? And how have recent fluctuations impact your investment strategies recently? So let's maybe we start with Gavin this round.
Okay, sure. So you can consider, besides the team comes from a traditional finance background, so you can consider us like more like we try to be more organized and systematic, right? So internally we divided in sectors into threes. The first one is called infrastructure and the middleware. The second one is application and content. The last one is the financial related, including DeFi and CeFi. So personally, I'm more focused on the infra and like a financial related side. So those are the like general sectors we are focusing. Mostly cover everything, but like we do have some internal, I would say, red line that, i.e., some of the things that we don't touch, right? Some, for example, like legally or like morally or reputationally might be very risky. Like then we don't get into those industries. For example, like pure gambling. So we're not doing that. Like drugs and whatever. Like like we don't do that gray market stuff. And secondly, like some things like from business perspective, like it's really hard for us to understand sometimes like a narrative in the industry is like the words you can always hear, right? So even some of the pure narrative play can work, or like in terms of like evaluation or whatever, but those might not be our cup of tea. So from our side, at least we need to really understand there is a like solid business model. Of course, like crypto enjoy the higher multiple, like valuation multiple, whatever, but like at least you need to have a real solid business model. So that's what we were looking for. So lastly, we don't do too much like well, I know it might be controversial, but like it's like we cannot do too degen, right? It's like it's a meme coin, etc. They might be a little bit too much for us. Like although we spend tons of time to understand to spend on the infra, etc. But like pure meme, this kind of thing might not be our given the mandate limits. So those are generally what we are looking at. Thanks.
So, the second question was quite interesting, where you said, how did the developments actually impact our investments?
Yeah, the fluctuations.
Yeah, actually, I think everyone is a Warren Buffett when BTC is at 70,000. Everyone knows what to invest in. For us, we've been consistently investing. We did 90 investments in the last 18 months. And I think it was all about investing in the last 2 years, not just investing in terms of projects, investing in terms of meeting people and building up relationships. In the next 1 year, when BTC probably goes over 100,000, you will see the room full of VCs who just woke up 20 days back. I call them tourist VCs. So as a VC, you cannot be seasonal in nature. You have to keep on investing if you believe in the technology. And that's what we have done. Now, with respect to what excites us to invest, in then investing across Web 2, Web 3 is all the same. You really need to know whether the team has the capability and the capacity to do something great. They have to, those cool kids can also build something great, but people have to have the expertise to build a $1 billion entity. Second, we have built up this whole theory about a need case and a want case. You need water and food to survive. Similarly, you need things like Ethereum because 80% of the smart contracts are on Ethereum. You need a BNB coin because you'll end up making millions on the Binance Launchpad. While a lot of projects are want cases, that means you take my token and someday, it's like a Ferrari. You want a Ferrari, but it doesn't really kill. If you don't have it, you don't die. So similarly, a lot of tokens are want cases. Governance is technically, who goes and votes? I haven't voted for sure. There are a lot of projects which are giving up these coins, which will give you a 30% discount on some project, something that you buy on their platform. I think I can go to Amazon as well. So for us, we look whether this token has a need case tomorrow. We definitely, business models are critical, but let's be fair, how many of those 10,000 tokens on coin market cap have huge revenue streams right now? It's still early stage. So we look at how money will be generated, but do they have to have money right now? I don't think with the amount of users in there, there's strong traction put on that. So team, use case, business model, and how strong the technology is. That's what we look at.
Thank you very much. How about Ronnie?
Yeah, for sure. Maybe to start, I need to read a disclaimer. We're a SEC registered investment advisor, so all these opinions are my own, and I can't comment on any hack VC related strategies specifically. But I've been angel investing for a while. The founders that I like to work closely with are the ones that play long-term games with long-term relationships. And especially ones that care the most about the community of people that they work with, the ones that care about building something that's actually frontier tech and not just about token listings, the teams that care about incentivizing the right kinds of people as well. And apart from that, there are all sorts of different kinds of standard parts of diligence and stuff like that that an investor would go through when you're looking at making these sorts of investments. But I think that over time, the dynamics between the founder, the team, their ecosystem, and their community is really the moat. Because the reality is that the frontier of innovation continues to move forward, especially when Cambrian explosions of new financing for new tech come in. And this is all open source tech, so the defensibility really does go down to community at the end of the day.
Yeah, I would agree with a lot of the things that already been said. What I could add is that towards the end of your question, you really have to understand the motivations of the founders, and it's just insane how many, and it doesn't matter, they can have great academic pedigree, or they can be just, lifelong hustlers. It doesn't matter, just how many people just want to raise money. Really, that's at the end of the day, and they're convincing themselves that they think this is a great project or a great idea that they need the money for, but you can really tell that that's just their mind playing tricks on them because they really just want to raise money, pay themselves a salary, and kind of, fly to conferences and kind of thing, and then figure it out. And so it's incredibly difficult to just differentiate those because again, they come with some wonderful academic pedigrees, etc. So you can't really tell. The timing is pretty easy because if someone who raised in a bear market, the odds of them actually raising a lot of money are very low. So they're probably way more motivated to actually see this thing built that they want to build. And so that's just a broad, I think that's a pretty easy low-hanging fruit to see when they're raising, and then just ask the question: how much are you paying yourself? Like, you'd be surprised how many times they come out with like, oh yeah, I'm paying myself $250K because I'm the CEO, and it's like, okay, but you're raising $2 million. Like, I mean, fucks up with that here. So so some pretty basic stuff. Really trying to understand the founder motivations are important. And then another thing which is harder, but it's just the ability to grow, because you're ideally every second day you're out of your element as a founder. You're just catching up to how the project is growing, and you're just trying to intellectually, in your mental models, in your execution, in your energy levels, in your leadership, how you're guiding teams, like you're constantly out of your element. You constantly have to level up. You constantly have to become better and smarter. And that's also a hard one to predict, but you can kind of see these patterns of just certain mental models, just certain ways that people talk about their shortcomings, how they are, they have self-awareness, do they have general like frameworks, and how they try to figure out where could I be wrong, and they're unemotional about it, right? And so another way is you just like ask really stupid questions about their project, like you just question it on a very fundamental level, like almost insulting.
Okay.
And then you can see how they react, right? And if they get offensive and aggressive, then it's maybe not so good. If they're very patient and trying to see a way that they could be actually be wrong. Yeah, those just to provide some additional color to what these guys said. Yeah.
Thank you very much. And nowadays, I think artificial intelligence is an inevitable and a game-changing topic all the world. So we're at a fascinating crossroads where AI isn't just an add-on, but a core component that's turbocharging blockchain's capabilities, right? So I'm curious to hear from our panel. In practical terms, how is AI being integrated into blockchain projects today? And what kind of technical innovations or collaborations do you think we need to really harness the full potential of AI in the blockchain?
I mean, I think on a high level, you can just say whenever artificial intelligence autonomously transacts with value, with money, it's going to be on blockchain. It's not going to be on Swift that turns off on Friday at 5 p.m. and sleeps on the weekend, or whatever Swift does, and ACH, etc. Right. So you really want the not just immutability, but the guarantees, the liveness guarantees of blockchains, right? Those are the most resilient databases in the world. And so that's on a very high level, if AI starts transacting autonomously with money, it's going to be on blockchain, 100% for sure. Then now there's a lot of, now there's this kind of peak AI hype, and especially peak crypto AI hype. So there's a lot of vaporware out there. Again, I would check with these founders, what were they doing in the bear market versus did they just start their project a couple of months ago, et cetera, right? And so there's a big risk here that is just sort of opportunistic founders raising a lot of money, trying to figure it out. Maybe a little bit less high level is another thing that just sort of attestation, authenticity, origination kind of attributions are going to be a huge issue, right? So just as an example, I think it was a Hong Kong investment firm where I think the CFO had a video call with the CEO and the COO and then wired $30 million to the wrong bank account, right? And all these guys on the Zoom call were deep fakes. And he just wired on the instructions of them, right? And so there's going to be a huge issue knowing that if you're talking to someone on a Zoom call, is that actually the person they're saying they are? Because with deepfakes, you can create that, right? So that's, just a simple example of attribution where really you have no way of knowing that unless you start actually integrating cryptographic keys, meaning that my wallet, which is known, and that wallet signs a message and authenticates actually that it's me on the Zoom call telling you to send some money over there or not. There's also some where, you have to prove that the computation happened on a certain smart contract. So again, that comes back to the authentication kind of origin kind of attestation questions. Like, you're claiming that this, zero knowledge proof went through these different smart contracts, but how do you actually prove it, right? And so there, you have some functionalities there, or some use cases there. I think there's like, a decentralized AI compute network. There might be something there, but I'm also skeptical because it's just like a simple narrative that people like, because you had like decentralized compute networks in crypto, and now they do decentralized AI compute networks, and so that's like a really like left curve kind of thing that works really well. Like, it's the same thing but AI. So, also be careful. It might be a little peakish here.
Thank you very much.
Yeah, happy to share my opinion on crypto AI. On our side, at our fund, we've all been like Web2 VCs in SF, before 2020 as well, and a few of us have accumulated, 50 to, or more AI portfolio companies before then. So we've seen a lot of the Web2 AI world kind of play out. And so when we approach Web3, the way we started to think about it is, where does value accrue in Web2? In the real world, NVIDIA is one of the most valuable, organizations on earth now. And on top of that, companies like OpenAI have publicly stated that they're looking, to go raise $7 trillion. And so, I can speculate that something like OpenAI may have a moat long-term to accrue value. But I can with certainty say that at the GPU layer, NVIDIA has done very well and will continue to do well when other people need compute. That's also how I look at the AI world right now. I talk to a lot of people with a lot of GPUs these days, and the first thing they tell me is that they're getting offers from AI companies that need additional compute to, render the software that they're looking to put together there. And so, I think for the first time ever, a lot of people with a lot of different, flexible setups are looking to deploy compute into the world of AI, and a lot of people are thinking that compute through AI could turn into, more of a currency as well. And so, at the compute layer, it's pretty interesting to look at. Compute marketplaces, probably the natural extension. From there, at the application side, I think it's still too early to call it. A lot of founders are putting together a lot of ideas, but within open source tech, again, it's really, hard to find a moat until you have true product market fit and build community around it. And so, still keeping an eye out for what's happening on the application side, but I can tell you that there are a few developments that I've seen that make me incredibly optimistic for what the future could look like. Yeah.
So when I look at AI, generally, there are two things that come to my mind, top of my mind. One is, in a general world, not crypto. I'll go to crypto later. One is ease of work. It's making things easier for everyone. You today posting on LinkedIn, you just use the AI feature, and suddenly the content is also done. The second thing is non-emotional decision making. So when you trade, you have your emotions attached to it. But when you have a trading bot which uses AI, the emotions are out and the structure is in. So I think these two things will definitely change how people work and take decisions in the future. Maybe you really don't need humans in the long term. Now, when it comes to so this definitely, as a technology, has great legs. It will go far. Now, when it comes to crypto, I think the two trends that I'm seeing is anyone and everyone who had any project last season is changing it to putting AI in there and saying, now we are an AI project.
Yes.
Amazingly. So there are two new trends in this season. I've seen it in the last 2 months. One, change the name of your project. If your project was known as ABC last season, make it PQR this.
So how do you view this trend?
Come on, and it's all.
Okay.
So how do we actually, as investors, you keep on seeing that. We have seen projects that have been really slogging it out in the last 2 years. Again, there are teams which are saying they are AI, but have 0 people working on who have ever worked on AI in the past. Like there was this good project that I saw in one of the events in Saudi where they were building up a event app which would connect you with other people in the event. Looking at, the AI would actually see the characteristics of different people attending and you as well and match someone perfectly. They came with a clear AI background. So, when you look at those projects and you have been seeing them in the last 2 years, you believe they will add value. But most of them are just taking the hype and building up. So for me, I think there's definite use cases even in crypto. It can be either in trading bots. It can be, there are some projects which are actually helping you build videos and images out of text, using AI. They have a lot of applications in games as well. We have invested in a company that where you can train AI models to let your game characters play. So there are use cases coming up, but it's too early in crypto to figure what will be the future. But 100%, there's a lot of BS that's happening in the market right now. And we just need to be careful while investing and looking at these projects.
Thank you, Vinny.
Yeah, well, my thoughts the question could be divided into several, right? So the first one is AI is not just happening after like ChatGPT, GPT-4, OpenAI, or whatever, right? They has been there for decades. We have these tons of the other application, right? So Lazy mentioned like the deepfake, like this kind of facial recognition, like how about robotaxi, etc. There are lots of the other like kind of trial and very established unicorn in the industry. But if you're looking at their revenue generation or whatever, right? So, for example, robotaxi, right? So Waymo, how many cars of Waymo are now on the street of San Francisco? So can they make profits? And can they be sustainable? Like so, yeah. There are still tons of question marks. Still, AI has been there for decades, right? So what could be? Well, before we talk about like crypto, like AI companies, how can they be developed? Can they develop a certain sustainable business model? These are some question we probably should look at first, right? And second one is like, what's different this time, right? After generative AI, what's different, right? So they could be more smart, they could, they could be more helpful, efficiency, etc. But like, unlike internet, my personal view is like AI is more focusing on helping to improve the cost side, right? So co-piloting or whatever, for sure, there will have be imminent, like large improvements, of your efficiency, right? So you can either in the call center business, in the like even when you are like writing the blockchain smart contract, you can use AI, etc. They will largely help you to improve your cost, like helping your bottom line. So I think that will be huge difference. But like, it's fundamentally whether it can replace human. It's can be that kind of intellectual. I think there's still a very long way to go. It's like if we're talking about the tech curve, right? It's just kind of a start. The next question is like, if we're talking about what's the relationship between AI and the crypto or AI and blockchain, right? In my opinion, like if we are talking about the world of Web3, AI is focusing to solve the problem of productivity, while blockchain will try to solve the problem of product relationship and like 3D indexing or what the other like hardware, whatever, like the Vision Pro or whatever, the other technologies solving to provide the real the factor ingredients in the digital world, metaverse or whatever. So those all components are necessary in that world, right? So that's why AI will, in the long run, will for sure in favor of blockchain. And also, if we're talking about decentralization or whatever, let's just mention, like, let's say if we are having AI massively adopted in next 2-3 decades, but GPU is still dominant by NVIDIA, like the big model is still is dominant by OpenAI, will you be afraid of that? Will the government be afraid of that? The only solution is decentralized, right? The autonomous, like, it's not, it's Lazy mentioned, it's like the system needs to be live anytime. That's a reason. The other reason is like, I think the governance is very important in that sense. And also, if, what's specifically in AI plus crypto, we would be interested is like, if like AI agents, right? Plus like IoT, deeping this kind of thing, whether we can have some business model. So in the future, maybe an AI agent can talk with the other AI agent directly. They can charge them to help him. For example, maybe it's like it could be a robot, could be a AI model, could be whatever. But AI agents, for sure, they cannot having a bank account, but they can for sure have a blockchain account, right? They can pay each other, they can facilitate. So that's also, I would say, in favor of blockchain development. That will be very interesting. But for now, we are as a fund. I totally agree with everyone. It's like I think it need to be very prudent to develop, to deploy into the industry, given the valuation is a bit high, a little bit more formal here. The other reason is like our strategy is like you need to stay humble and thirsty, right? So for AI, to be honest, it might not be our like top expertise. So we will be even more prudent in that sense. Thanks.
Thank you, Gavin, for bringing the government words up here. And I will continue on the question with the increasing attention from global regulations on blockchain technologies and cryptocurrencies. So how do you view this trend? And are there any particular strategies you advocate for navigating this dynamic landscape?
Maybe Gavin, you go first.
Okay. So I came from finance and law background, and probably I can say a bit words about this. So, well, to be honest, I think by the end of the day, like government policy, regulation is all about choice, right? It's like if you choose one side, then we'll hurt the other side. So like, to give a very simple example here, like regarding decentralized DeFi, whether they need to have regulation, it's like by the end of the day, it's a question for principle. So in traditional finance, there is a KYC, KYP, know your client, know your products. You need to have a properly matching of the two sides. Then you can distribute the products or whatever, right? But like the essence of a decentralized DeFi is like, okay, we want to do kind of finance democracy or whatever, right? So everyone can access whatever they want. We don't need, we might not need to have big parents to decide which you can access to, which you can buy, etc. So this is more about like choices. It's not about like a procedure. It's more about like the format or whatever. So I think there will still this kind of a debate will still be continuing. And if we are sitting in the seat of the government, like for sure they will need to protect the normal people, right? It's like not even back to the 2008 financial crisis, right? The U.S. established the Financial Consumer Protection Bureau is to protect the layman people. So that's in line with what the government thought. But like on the other hand, I think we see very good momentum either in U.S., in Hong Kong, in other like legislative jurisdiction. That we will see more kind of clarity from regulators. That is even more important compared to the result. If you have a final answer, then people have, oh, we can based on this to do this, that, and we can based on this to do this. So I think the clarity and the feasibility is even more important compared to the final result. Yeah, thanks.
So I have a controversial view on the regulation part. I think governments regulate something which affects masses. You know, in the Indian stock markets, 1980 stock markets came, people didn't understand that a share represents the future earning potential of a company. And, you know, there were less people on board. People, there were two big scams that happened in between the Harshad Mehta and the Ketan Parekh scam. But go 10, 15 years ahead and a lot of people in India are in stocks. Things got regulated. Once the stocks happened, people went up the roof, the crashes happened, they jumped. So until it doesn't lead to such a case where the government has to take notice, full regulation doesn't come. Yes, if touches and bits of these regulations are coming up where you are regulating some exchanges, getting some things done, but full regulation, I personally think, is a long way ahead. What is important is education as well. You know, first of all, people have to understand what Bitcoin is in itself rather than regulating Bitcoin. If you go out on the roads, talk to a taxi driver, what does a Bitcoin do? He really doesn't have a clue. He still thinks that I will buy Bitcoin because it will go to $1 million because someone has told him on Twitter. So regulation for me is far away. Still, minimum 3 to 6 years ahead, full regulation. Education is something that people need to focus on and get people understanding on what we are trying to do over there.
Thank you.
Yeah, happy to share my thoughts on the regulatory side. So I think it has a lot of implications on, the regulations of a country have a lot of implications for the kinds of costs and structures that founders end up putting together within these countries, and like the implications for how these businesses can interact with other businesses in other countries. And so for example, in the United States, since it's, so it has like a lot of ambiguity in the regulation, a lot of founders might find themselves paying like quite a lot of money in order to set up businesses where if you were to set it up in another geography, it'd be a lot cheaper because now you have to find a lawyer who's willing to take the risk to say it's okay. Separate to that, it's interesting to look at the history of a lot of these different countries. For example, if you look at the UAE, a city like Dubai, the reason why Dubai is so successful, even though Abu Dhabi is like, such a great place, is because it made its regulatory structure and its laws composable with, UK common law. And when you do that, businesses within these geographies have a lot more predictability on what sorts of outcomes they can expect because they've already done that sort of homework and they have a lot more comfort around, their own legal system. And so I think that's definitely something a lot of these geographies should consider when they're looking to break in and take a lot of talent in and try to become the new hub for Web3. But yeah, I think like over the next few weeks or few months, everyone will probably be very thrilled to see a lot of new opinions on how people view the future of crypto within their respective geographies. So definitely some of the most exciting times in the world for Web3 right now.
It's a little bit tragic right now in the US. As a founder, from the regulation side, you're incentivized to just release a meme coin that doesn't do anything. You take less risk than actually trying to build something of utility. So you have this really, really perverse incentives right now. And so I think that's a problem. On the other side also, I like this Benjamin Franklin quote who said, you can always rely on the Americans to do the right thing after they've exhausted every other option. And that's kind of what the US felt like at least since Biden got elected, right? They're just shooting in all the wrong directions. They're trying to kill it. But then you can fight back with the courts, and it's, like I said, there's a lot of ambiguity there, and I think it's actually a good system for change, because you have this. It's really unlikely that a bunch of bureaucrats are honestly going to be able to predict 10 years, 20 years in the future, and then regulate this properly accordingly, right? This is a space that's evolving. And so just people starting to regulate it, it's kind of an arrogance of regulators that they think they can predict really what the outcome is here of this industry. So I like this American system, a lot of chaos, a lot of ambiguity, but it sort of figures itself out over, some difficult times and some uncertainty. It is also, at the end of the day, it's really only the US that matters. You saw when the EU signed off on their regulation, the markets didn't move at all. Nobody even knew this was happening. So at the end of the day, it's all going to be up to the US. But there is, global competition now between jurisdictions, and that's great because you've got the UAE, you've got Switzerland, you've got Japan that are very pro and that are moving this forward. And yeah, it's a global world now, and you can just move as a founder somewhere else to another country and do it there. And you've seen this, that the US lost actually Web3 engineering talent to other countries, and the market share fell. And because you have this jurisdictional competition, and that as a political message has been heard in Washington, D.C. So, again, coming back, I think the US will figure it out. It'll be a few more years of sort of things being quite messy. You also have now, I would say, just because you have these strong commercial interests or corporate interests that basically solidified crypto, at least Bitcoin is part of the financial establishment now. So now that gives a lot more clarity, even though regulation-wise maybe it's not so clear. So I think you will also have this mix of just corporate interests moving further into the space. They want to be offered, they want to also offer Ethereum, and staked Ethereum as a product. So if that happens, then, whether even the regulatory status of Ethereum isn't that clear, but, it's part of American finance now as well through ETFs. So what I can say is a lot more kind of like chaos and sort of uncertainty. But the great thing is that in the US, it's very participatory. It's very easy to create a super PAC, start funding, politicians that endorse your policies, start funding industry associations that are educating lawmakers. And so I think eventually the US will figure it out.
It's not about just building a faster car, but also make sure the road can handle speed, right?
Yeah, and that the regulator doesn't put a speed bump every 5 meters because they thought that was a good idea,
Yeah. Thank you. And as our journey reaches its harbor today, and I will extend a thank you to our panelists, and I also thank for all the audience joining us today. And before we part ways, allow me to make a commercial here. And we have written a book about how you evaluate the digital assets from an institutional perspective, and perfect for anyone looking to make sense. Grab a copy after 20 this month at any bookstore in Hong Kong if you are curious. Okay, thank you very much for today.
Cool, thanks.
Wonderful. A big round of applause for the gentleman on stage. Thank you so much for an excellent presentation and discussion. We all enjoyed a lot. Thank you. Please be seated. So, ladies and gentlemen, I hope that you've all gained some insights from the discussion and have some great takeaways from the discussion. And I hope that you enjoy the discussion and the speaker's presentation as much as I have. So do make the most out of the event. Feel free to reach out to the speakers and mingle with amazing people around you. And moving on will be the last panel of this forum, and we will explore the influence of the hotly debated Bitcoin Layer 2. And without further ado, let's welcome our moderator of this session, Ms. Emma Tway, co-founder and managing partner of Long Hash Ventures. Big round of applause, please. And also our fabulous panelists. They are Rina Shah, VP of Product and Operations, Stacks Ecosystem Trust Machines. Big hand for her. And then Hannah Yang, CEO of Terp Layer. Lou, partner and CTO of Slow Mist. Welcome. And Jan Kamenish, CTO of Definity Foundation. A big round of applause for them. And I'll pass the floor to our moderator. Over to you now.
Thank you so much. Thanks for HashKey for organizing such a wonderful festival. It's always good to be back to Hong Kong. I come here every year, and it's really a good opportunity to kind of meet some wonderful panelists, the thought leaders in this space, and also I think the market is really picking up. So it's great to see so many turnout for the Web3 festival. I think first of all, let's go around the panel for a quick introduction among the panelists. So maybe I'll start first. So I'm Emma. I'm the moderator. I'm the founding partner, managing partner of Long Hash Ventures. We're a Singapore-based global VC fund. Have been in the space since late 2017. Invested in more than 100 portfolio companies, include some of the household names like Polkadot, Astar, Manta, most recently Neutron, Saga. So yeah, have been super excited to placing bets in this space. I'll pass over to Rena.
Hi, my name is Rina Shah, and I'm with Trust Machines. We are a Bitcoin product studios who build real-world products on Bitcoin. We are a core contributor of the Stacks ecosystem, which is a Bitcoin L2. And I've been building on Bitcoin for about 10, maybe 15 years. I started off as a Bitcoin miner in the US in 2012 and worked with a lot of oil companies to help them diversify their strategy to mine Bitcoin. And after leaving oil, I went to Binance, where I was the COO of Binance US.
Hi everyone. My name is Hannah Yang. I'm the co-founder of the Terp Layer. I get into the crypto area since 2017. I was a founding partner with some a public trend and also involved a lot on the NFT and DeFi. And also I'm a big believer of the Bitcoin. And we believe we want the Terp Layer want to release the Bitcoin potential. And also we are focused on the Bitcoin native assets, for example, the BRC20, and also we try to release their potential into the all kind of Bitcoin ecosystem and also the other layer too. So yeah, that's what we do.
Hello, my name is Blue. I'm CTO of Slow Mist. We are an auditor firm. We audited a lot of projects, such as centralized exchanges, DeFi protocols, and public chains. We also provide some service and products like Slow Mist AML. Yeah, that's all.
Welcome.
Good afternoon. I'm Jan Kamenisch. I'm the CTO at the Definity Foundation. The Definity Foundation is like a major contributor to the Internet Computer Protocol, which on the one hand is like a layer 1 blockchain, so you can host smart contracts that are way more powerful than anywhere else. You can do front ends, back ends, like everything on chain. But the Internet Computer Protocol is also like a layer 2 to Bitcoin, because like it integrates the Bitcoin network directly, so smart contracts can read securely transactions from the Bitcoin blockchain. They can also hold Bitcoin directly with like threshold crypto, and there's also like write to the Bitcoin blockchain, so it actually adds smart contract to the Bitcoin network.
Wonderful. And thank you guys for staying for the last panel of the day. I think the first question that I had for the panelists is, every cycle in crypto, there's new topic. I think BTC L2 is definitely one of the big narrative and big ecosystem that's developing and shaping up this cycle, right? However, in many people's mind, it still remains as a sector that's pretty uncertain because of a lot of people, the narrative that's associated with Bitcoin has always been the digital gold, right? So you want to do as little as possible, keep it secure in your cold wallet, whereas Ethereum is the settlement layer. So now it seems like we're trying to do a lot more, bring smart contract capabilities, bring layer 2s to Bitcoin. So there's a lot of controversies around this. So just kind of want to understand from the panelists, right? How do you guys think about this emerging trend and what are you building in this space? And why do you think it's necessary to have a Bitcoin layer 2? Whoever wants to take it, feel free to jump in. Maybe Rena?
So I'll kick it off. Bitcoin is the first reason why we all came into this industry in the first place. And if you think about the value of BTC as an asset, that is $1.3 trillion. But it is just latent capital that is not being deployed in the ecosystem whatsoever. If you were to maybe compare this to Ethereum, Ethereum is about $400 billion for Ether, just the asset, but the value attributed to the Ethereum ecosystem is $52 billion. So think about L2s, stablecoins, DeFi, NFTs. If we applied that to Bitcoin, we would be a 200, 300 billion ecosystem easily on top with value created. That transforms Bitcoin from a passive asset to a productive asset. And I think there's real opportunity to use the secure base layer and build on top of it.
Thank you, Rena. You guys are truly one of the OGs. I think probably one of the first projects to building Bitcoin.
Stacks has been building on Bitcoin since 2017, and it is. We have seen this vision from the start. We've always believed that Satoshi wanted layers on top of Bitcoin to recycle Bitcoin's security and capital so that you can have innovation on the L2.
Yeah, maybe I take the next. Yeah, I'm really agree with Arena because if we call back to 2017, before that, before the ETH actually grows like that right now, actually everyone was thinking to how to improve on Bitcoin. And I think probably that Bitcoin is everyone, why they get into the crypto side. And also some people even thinking, I really remember when we first met Vitalik, invite him into Wanxiang blockchain, and people thinking maybe issuance just a side chain for Bitcoin, right? I'm pretty sure right now it's totally different, but I think it's another time to why people start to talking about Bitcoin. But we all know that the principle for Bitcoin is the high security, large market cap, and also the consensus is really important. So right now, most of the layer 2 is still, but how to keep that simple and the principle. So for Bitcoin, it's still just more on the value storage and also for, I think still for the asset issuance. But if you want to do some really complicated integration, that's why we need layer 2. And that's a lot of people was thinking how to take the consensus and leverage the security with the layer 1. And really exciting to see a lot of layer 2 start to program on here. That's my point.
Thanks, Hannah. Blue, do you want to take it further?
Okay, I think at first Bitcoin is much more value than other blockchain assets. But every 4 years, we mine less than before, especially half less than before. So we should find how to earn more assets and money from this blockchain. So I think this is the main reason, because a lot of BTC layer 2 and BTC mainnet is very secure and stable. So and it's very slow. Yeah. So we can't do DeFi and other things on mainnet. So I think layer 2 is reasonable. Okay.
Awesome.
Right. So I guess in my view, actually having a layer 2 on Bitcoin is like much more attractive or more valuable than Ethereum. And you see, like on Ethereum, I mean, in some sense, Ethereum is like a more powerful blockchain than Bitcoin. That might be a pro, but I think it's actually a disadvantage because it still doesn't scale enough. So it's still all this layer 2, and it's unclear what you do on Bitcoin, what not. What you do on Ethereum and whatnot. Whereas on Bitcoin, it's very clear, right? Bitcoin stores Bitcoin, and well, now with Ordinal, we have extended that. But so that's actually very powerful. It's still proof of work, which like it's much harder to change history. Whereas like proof of stake on Ethereum is sort of went down in some way the wrong path, and that's also like why with the Internet Computer we have actually first integrated with the Bitcoin network and actually have added, have nodes on the Internet Computer that also are nodes on the Bitcoin network. So that's why then smart contracts actually get all these transactions. They can own Bitcoin. So that's, I think, much more promising. Rather add more functionality, something that like Bitcoin that is valuable, and it also can have more impact there than in Ethereum, where there's like a lot of layer 2s. It's not clear who does what. It's like a very complex infrastructure, and everybody tries to add something, but that also, if all these layer 2s that can't really interoperate, whereas on Bitcoin you can add like much more power there and profit from the I mean, as previous speakers said, from the load, the value that is there, from the security that is there. So I think it's way more attractive actually than on Ethereum.
Yeah, thank you for summarizing that. I was going to say, right, sounds like from all the panelists basically converging and why we need a BTC layer 2. One, it's one of the largest asset class within crypto. Secondly is I guess everyone is relentlessly pursue the utmost security, right? That's driving for that. And I think you also mentioned a really good point, Yang, which is fragmented liquidity in the Ethereum ecosystem today. And I definitely want to go there because I feel we're still in the early days of Bitcoin layer 2, but we've already seen quite a number of them emerging, right? So it seems like we may very well go down that path of fragmented liquidity as well. You know, what we've seen in the Bitcoin, Ethereum ecosystem, right? You have layer 2s, we've seen some layer 3s, right? Interoperability becomes a big question, UX, UI become a big question. Do you think Bitcoin, as Bitcoin layer 2 proliferate, that might become a problem? And how do we actually solve for that? So maybe we can start with Yang.
Sure, I mean, I think, as you say, like in Ethereum, that was sort of like a bit of a dead end, but you can also see that people now recognize that you want to build applications that are actually cross-chain, that are multi-chain applications, and also that's like why on the Internet Computer or at the Definity Foundation, we work on like what we call chain fusion, such that like one smart contract on the Internet Computer can like work across any blockchain. So we have like what we call chain key signature. So that means like a smart contract can actually have a public key, can have a Bitcoin public key, can have an Ethereum public key. So right now we have like threshold UCDSA, we will have threshold Schnorr in the summer that can really like write to any blockchain. And conversely, we also will enable that the smart contract can read. As I said before, we've integrated with the Bitcoin network, we'll do that with other networks. And I think that will just remove that sort of competition between all the layers too, because then you have like one place where you can write smart contracts that can really deal with all the different front ends. So hopefully, I guess we're not making the same mistakes like with Bitcoin layer 2 that we maybe had with like Ethereum L2s, but it will be like a more like a universe where interoperability is really key, and I guess that's what we're working towards, making sure that we can read, like smart contracts can read and write, we can have front ends on the Internet Computer that can deal with any other chain. And so have like a, like a very prosperous future where we share liquidity. It doesn't really matter where your tokens are. You can write your smart contracts like anywhere, move tokens around freely, and make it life much easier for developers.
So in other words, what Definity is working on is essentially wanting to become that interoperable kind of layer for Bitcoin.
Yeah, very much, because like I guess the Internet Computer is like the architecture is a bit different from other blockchains. Like You know, like we have threshold crypto, for every, what we call subnet has their own like public key and they can sign with respect to that. And also means like smart contracts get their own public key, they can sign with respect to that. And so now you can write smart contracts that, you know, like read some Ethereum event. Once this Ethereum event does something, they can write Bitcoin on the Bitcoin network, or and just replace like Bitcoin and Ethereum with any other chain you want to elect. So that's our goal, really. So that it doesn't really matter where liquidity is, where tokens are. You know, make your choices. If you want to have a Bitcoin, or you want to have ETH, or if you want to have Solana token somewhere, it shouldn't really matter, right? You build your application and don't have to worry about that. It's just like you know, like a different. You know, argument to your function call, whether you want to have Bitcoin or Ethereum or any other blockchain, really.
That's super interesting. So maybe we can go to other panelists. Do you guys have anything you want to share regarding UX, UI, or fragmentation?
So I would start with Bitcoin UX has been pretty terrible from the get-go. It's no secret that if you were building on Bitcoin maybe 15 years ago, you were using Bitcoin script, which is not intuitive for anybody. And lo and behold, you would be using Bitcoin script right now if you were still building on Bitcoin. I think a lot of L2s like ICP and what we're doing at Stacks are trying to reimagine Bitcoin to be more developer friendly and more consumer friendly. Stacks is taking the approach of building a virtual machine that operates fully 100% recycling the hash power of Bitcoin so that anyone can recycle Bitcoin capital and use that as their security. A lot of other approaches are available, but I think at the end of the day, however you're choosing to build on Bitcoin, you need something that's interoperable, but still maintains the peg of one-to-one with Bitcoin on Stacks versus Bitcoin on Near or Bitcoin on Solana. You need that trust minimized to trustless bridge to deploy the capital is the most important part.
That's really cool. Hannah, do you want to share any perspective on this?
Yeah, from my perspective, because why we're doing the tab layer is we want, I think the most important thing between why we call those are Bitcoin layer 2, that somehow you need to have some like data or stat sequencing with the Bitcoin layer 1, right? But right now most of most of the layer 2 they are maybe it's not actually rolling up anything with the Bitcoin layer 1, and probably they still figure out what's the solution to do that. But that's very important. It's not saying like how much TVL you have on your chain, and I think that's definitely will have something different than the EVM or Cosmos right now, and that's definitely need a lot of work on that, and especially definitely a lot of infrastructure need because we all know that it's difficult to write a smart contract on Bitcoin, and but how to leverage your smart contract, like programming smart contract or modular smart contract to the result could be communicated or the status could be communicated sequentially with the Bitcoin layer 1. I think that's a really important thing, and I think everything is from there, and then we could talk more about like how we build the ecosystem on top of that. I think the most looking forward probably is that maybe DeFi, because we could see there already have some like native Bitcoin asset, like for example like ORDI or Unisat like happens on the Bitcoin, but because they will. They need some infrastructure to helping them to exposure to more different layer 2. There could be Solana, could be Base, could be or EVM, could be others. But why it's so difficult? There were a lot of infrastructure need. I think if we want to grow the Bitcoin ecosystem, probably need more focus on there, and also that will definitely improve the liquidity for the Bitcoin ecosystem. That's my output sense.
I don't know if Blue, you want to share anything on this topic?
I don't know how to solve this problem about fragmentation. I think maybe time will solve the problem, because after a long time, I think maybe only several projects, only several layer 2 will be left, because we don't need those so many projects and so many chains. Only, I think after a long time, I think only several. So the problem will be solved automatically. I think.
Hopefully. But that's what we said about the Ethereum ecosystem. Now look at how many layer 2s are being launched. So yeah, that's an interesting challenge. I want to go to the topic about developer, right? For any ecosystems to kind of prosper, you need a very vibrant developer ecosystem, right? And I think for Bitcoin developer, the core dev, right, has been known to be quite risk adverse, right? Because everyone's so kind of security concerned, right? Any upgrades or fork takes, years of discussion, years of alignment. So how do you guys see how do we solve for the developer problem in the Bitcoin ecosystem or Bitcoin layer 2 ecosystem, given you guys are building in this space or auditing contracts in this space? Do you see a rapid uptick in terms of talents, developers coming to this, or do you see a challenge? How do you guys think about it? Blue, do you want to, Yang?
Okay, sure. So I think at the end of the day, if you want to make developers' lives easy, then you have to make it easy for them to onboard users, right? So it's at the end of the day, like if a user can't get, if a developer can't get users to their applications, then it's very hard for them, right? And I think there's like two aspects there, and we've already talked a bit about bridges, right? So if, we have to get rid of bridges, because bridges is the thing that gets hacked, that puts blockchain in the press all the time. This gets hacked, this gets hacked, this gets hacked, and as a user, that scares you away, right? So I guess that's also why we've done like direct integration of the two networks. I think the second part is really like usability, user interfaces. Like if I tell my family, hey, why don't you buy some Bitcoin or some ICP and so on and so forth, they get scared because like, oh, there's this seed phrase kind of stuff, right? And nobody can deal with that, right? It's already hard to deal with like professionals like we are with all these seed phrases, and so we have to get rid of that, right? And that's like here also why, and that's why at the Dfinity Foundation we have built like a blueprint wallet. It's like a browser-based only wallet where you can actually hold ETH and Bitcoin and so on. And it's like, well, I guess let me shill it a bit. Here it's like oisy.com, OISY.com. It's like the prototype of this wallet. And so what this means is like you can, like all you need is a browser. You enter the URL. That's actually the URL of a smart contract on the internet computer, and that smart contract, like with threshold crypto, and so will then manage the Bitcoin, Ethereum, and so on, the keys for you. And in order to authenticate, you just can use your passkey on your phone, right? It's as simple as using any other application on your phone. I think that's where, as a industry, we need to go, right? If we need to give developers the tools that they can build applications that users can just use with your browser, securely authenticate with your passkeys. If they have to store seed phrases or anything like that, it's just like a nightmare, right? And so that's really where we need to go, and that's where also like at the Dfinity Foundation, we want to contribute to the Internet-Computer Protocol, to Bitcoin at the end of the day with integration, that's possible very easily.
Do you have an estimate of how many developers are currently building in Bitcoin space, like applications, layer 2s?
Not on top of my head. I guess Lomesh is sitting in your audience. He's our growth guy. He would know that much better. But we certainly see an uptake. We had like a Bitcoin startup day last year where there was already like something like 50, and this year we did it again, and it was like a couple of hundreds already. So I think it's really, you see uptake here. You see that people get excited about like a new, Bitcoin L2 is really like a new field. And I mean, also I guess in ICP in general, we see like a lot of developer uptake, even like last year through the bear market, and much more so now with the bull market kicking in.
Awesome.
Okay. I think as a BTC holder, we don't like to move our assets every day. I think so. At first, we should care about security issue. We must solve the security problems. So the solution, I think, I talked with a lot of BTC layer 2. We also audited a lot of some layer 2. I think usually they can we can transfer the Bitcoin to an address via OP return script, and the BTC never transfer to other chains. So you locked it on mainnet. So then you can get some wrapped BTC on layer 2. So it's a good solution because you never lose your Bitcoin. So on layer 2, we can do a lot of things like DeFi protocol, like loan and swap and other things. We can get a lot of interest. I think it's a good way. About for developers, I think competition is very important. I think because we don't like to use different languages. We should we don't like to learn new languages. So it's easier to use Solidity or other language to write DeFi on BTC layer 2. So I think a lot of public chain, they for now we never heard them because they use a lot of very strange language. It's very hard to use it. So I like competition. Yes.
I think that's the strong preference from smart contract auditor, right?
No
new language, just something proven, well tested.
Keep simple. Keep the same like before. It's more secure and more simple. Yeah.
Yeah. I think Rena obviously have something to share because I think Stacks might have its own separate language.
Stacks uses its own language. It's called Clarity. It's a didactable language. It's very similar to Lisp or Rust if you're a developer. And we prefer having our own language because as you are going through runtime testing, you can see all the syntax errors in real time before you have to deploy the code. So it's a little bit of a safer environment. But to your point, I do believe that you have to expand to other languages, especially for auditing companies and such.
Yeah.
And so one of our big initiatives is we're launching WASM technology, so you can develop on Bitcoin through Solidity or through Rust and still deploy on Stacks because it's a virtual machine. So I think that is the real key for developer adoption, is to have that type of technology. There is a great company in the ecosystem called Hero who builds developer tools specifically just for Bitcoin so that anybody can deploy smart contracts on Bitcoin. And then going back to maybe the consumer side of like how to bring developers in, you do need good UX, but I would say even some of the more degen-like experiences are what is needed for Bitcoin, for people to want to build on Bitcoin. So until a year ago, no one wanted to build on Bitcoin until you saw of ordinals and high-value settlement of an NFT to basically break Bitcoin main chain. We're seeing that again through BRC20s, and in 2 weeks, we will likely break Bitcoin on the L1 through runes with the new inscription standard or token standard coming to Bitcoin. So what I would say is that the more degen-like approaches that come to Bitcoin, the more the developer experience is actually going to get better because people want to do things with their Bitcoin.
Yeah, after Rina, I totally agree. I think because I'm not the tech founder, but I want to add different angle from the community. Because we all know that why Bitcoin, we have this Bitcoin ecosystem, they're all from the inscription and also BRT20. And why they will start have the layer 2? Because people see their opportunity and see the big community, and they see what's the power from the bottom up and what's the fair launch. So because have those like the rich in fact, so that's why people will get in. So actually, I'm still really worried about the technology side, because if people making money from there, that a lot of people will get in, and I don't think the developer doesn't want to learn new language just if they could make money from there. So that's my point. And also, I was thinking there were another important thing is still we could see the power community, how the people who doesn't know tech very well, but could join this community. That's really important. It doesn't really matter what kind of language you use, but it definitely need, there was some like still that how to have the maybe better way to do the bridge or Oracle or price feed or also the data sequencing. I think those we would definitely need to use maybe some new technology to do that. Also, I definitely believe all the developer, if this ecosystem is real and have a lot of huge market cap and people will get in. That's my point.
I like the spectrum of opinions of the panel, right? Because we've got, I think, Blue coming from the kind of smart contract auditor perspective is like, you know, we want EVM compatibility, something that's tested and proven. But then from the layer twos that are developing new language, I think we're seeing, you know, as long as there's new use cases that's being developed, right? Perhaps there will be demand for new assets, and that's will drive the developer activities to learn about new contract language. So I can see I guess the rationale behind the different opinions here. And I just know Rena was talking about some of the new things that were emerging in Bitcoin ecosystem, such as, I think, ordinals, right, BRC twinning, inscription, and those, I think, drove a lot of hype and activity and attention to the Bitcoin ecosystem. So just wondering, a lot of those innovations happened in the base layer. Do we see those move to layer 2 because of scalability issue, cost issue? Yeah, what are some of the trends you guys are seeing in terms of use cases migrating from base case to layer 2?
So I would say that ordinals really kicked off the activity of I want to do more with my Bitcoin, and it created block space war that as you made an inscription every time you're writing into the Bitcoin block, and that block space became more valuable and basically created demand wars. Now, if you want this to scale to, let's say, 1 billion people, you cannot use the L1. The L1 has to stay for high-value settlement, and so you have to bring these transactions to the L2. Stacks is already seeing this with ordinals on the inscription side, that you want to make the parent inscription on the L1 and then do the child recursive inscriptions on the L2, because then you can deploy or airdrop a Bitcoin secured NFT to 1 million people with a very cheap transaction fee that is scalable and fast. I don't think that you can really do true Bitcoin DeFi activity on the L1 because, quite frankly, you're limited with 10-minute block times. But when you bring it to an L2, you can have a wider range of activities, whether it's AMMs or perp dexes or meme coins. You don't care, but all of this, the L2s are built for that. It's especially why Stacks is going through a hard fork in 10 days' time that brings block times down from 10 to 30 minutes because we're tied to the Bitcoin main chain block to 5 seconds, meaning you will achieve Bitcoin finality after that block settles, which means it's very secure. In order to reorg Stacks, you have to reorg Bitcoin, and 51% of the entire Bitcoin network is too expensive for people to hack. And so the more and more you see these L2 activities, the more and more you can build real-world use cases that should have always been on Bitcoin. I think a good example would be like RWAs. There is no point for an RWA to be on Ethereum when you could use the most secure base layer and then scale it to the L2.
So security is really the utmost kind of...
Security, but I think even like transaction throughput, you could never do 1 million transactions on the Bitcoin network. Miners could not accommodate that, but on L2s, you absolutely can and you should.
Yep, yeah, makes sense.
Yeah, I agree. I think my point is I think for the base layer 1 is still more vulnerable for the asset issuance. So if you want to have a vulnerable asset, you better storage on the base layer 1. But how you actually take the utility from that? And then I think that's also the advantage of the layer 2. And they could play like DeFi, or maybe later on could be even SocialFi, those things on is happen on the layer 2. I think that totally makes sense. But what but if you build the existing, I think still you need to consider like what's the community was thinking. It's because right now I think most of the layer 2 they could easily to support if the asset already have a big market cap. But like for example, Ordi or SET, I think most of the layer 2 could support it. But there was still a lot of the new assets, maybe they only have a small market cap, but they have their own community. But those assets will be really, right now, recently, it's very difficult to like be launched on any other DeFi protocol because they are too small, so they have a lot of security problem. So that's why I think still like very early. We need to fix it. Some problem. It's just like the middle layer. How to connect it with the base 1 and the layer and all kind of different layer 2. I think that's a problem we need to like solve it. Yeah, that's my point.
Thank you, Hannah.
Okay, about encryption, I think for now, encryption is more centralized because the centralized service records the information because we can't store this much more information on mainnet OP return. So I think it's not very like blockchain. It's not very decentralized. So I think maybe if we move this encryption to layer 2, maybe we can solve this problem. But in other hand, we can build a smart contract on layer 2. So maybe we don't need encryption. And about security, I think because about security and the speed and gas fee cost, maybe on layer 2 we can do much better than on encryption. Yeah.
Awesome. Before I go to Jan, I think the last question for the panel is, given we have, I don't know, about 50 people who stayed until the end of the day, so I think they deserve some perks. So can each panelist think about one alpha to share in the Bitcoin layer 2 or Bitcoin ecosystem so that we can wrap up with the day. But Jan, go for over to you.
Sure, thank you. So I guess I agree with like most of what was said, right? I mean, I guess on the layer 2, like, I mean, first thing, what we did after we had like integrated with the Bitcoin network and had smart contracts who could hold Bitcoin, it was all obviously, well, now what do you do it, right, with it? So you want to have like benefit from the speed and the throughput of the layer 2, right? And so we've built what we call ZK BTC, which is really like a Bitcoin twin on the inner computer, so that benefits from the like 1 second finality, from the tens of thousands of transactions you can do on the inner computer, right? So obviously, I totally agree with that. So that's why we've built ZK BTC. But I think the second thing is also like scalability, right? So now, and what Blue has mentioned about storage and so on and so forth, like, fully agree with that as well. And that's also why we're like working hard at Definity to like make smart contracts scalable in all directions, vertical and horizontally. Like a smart contract like on the network, on the internet computer network, can hold like 400 gigabytes of data, which is mind-blowing if you compare that to like 4 kilobyte on Ethereum, and at a fraction of a cost, right? I mean, it's like $5 per gigabyte per year, something like that. But not only that, you can also, if that's not good enough, you go just to like another subnet and can scale horizontally very easily as well, right? And you can orchestrate that. So as a developer, if you want to scale up your application, just do more smart contracts. It scales very easily, and this actually some of the scaling is actually even automatic. So again, so really can scale up Bitcoin to really sky is the limit here.
Yeah, when there's a will, there's a way, right? So when there's enough incentivization, I think it will happen. So who is ready for the alpha so we can wrap up the day?
Okay.
Silence.
Okay, you want to start?
Yeah, maybe I go first. So today is the Bitcoin panel, so we more focus on the Bitcoin Alpha. So here first, I want to say our tap layer is going to have some big market movement next month. So because right now we will service a lot of BRC20 project and also will help leverage a lot of the Bitcoin layer 2 and having them to do the data service. So we knowing some of the BRC20 projects going to have some DeFi activity on the layer 2 soon. So that's things we could keep an eye on. And also, I want to say is the Bitcoin, I think the order, because I was talking about a lot with the community, so I know actually the community still have a lot of the new immigration on how to play with the community. And the next move probably will leverage with some layer 2 will have a big airdrop. And also, I think the next move, the most, the killing apps probably will be still in the Bitcoin itself, like how to use the USDT to directly exchange or trade the Bitcoin. I think that's the big opportunity, and that will totally change the or the ecosystem and everything for now. And also after the Bitcoin ETF pass and after the next horizon, definitely Bitcoin need to figure out how, especially for the Bitcoin miner, and especially for someone if they don't trust the centralized exchange, so you will be, all the eyes will be on that part, decentralized trading Bitcoin. So that's my alpha. Thank you.
I feel Hannah is very generous. She shared more than one.
Yeah. Okay, I'll keep ours somewhat simple. Runes are coming in 8 days, 9 days during Bitcoin halving. Runes will break the L1. There will be so much degenerate activity that you're going to have to look at an L2. There are a lot of Bitcoin L2s out there, but very few will hit the $100 billion market cap and plus. Most will be in the tens, billions, and that's it. But only one, maybe two, if we're lucky, will emerge to the 100 billion. Stacks is the only L2 that has proven its consensus mechanism in building in the bear for many years, and is the only L2 that allows a direct Bitcoin yield. I would think that if I was going to build something directly on Bitcoin, I would want to build with a protocol that has incentivized Bitcoin in the first place that offers a yield.
Very cool.
Okay, yes, I disagree with Rena here. Obviously, people should come and build an ICP. We have like full-blown ordinals marketplaces already. We have stable coins that are Bitcoin collateralized. We have like lending platforms on Bitcoin. The network is live since almost 3 years now. Never has been down. Is blowing, like scaling out as fast as it can. It's a merry family anyways, and so come building, happy to support you with grants, whatever you need, with technical expertise. So come and build and join the family.
Whenever there's controversy, there's opportunity. So, Blue, last one. What are you bullish on in the Bitcoin ecosystem?
I don't know. I think just keep Bitcoin, and when the price is go down, we can buy more.
Buy more. I love that. Thank you so much for your time, and really thank you for staying for the last panel of the day, and I hope you enjoy the rest of the festival. Thank you.
Thank you. Let's give it up for our moderator and our panelists as well. Thank you. And shall we take a picture together? Fantastic. It's lovely to listen to different perspectives on the topic, Bitcoin Layer 2. And let's look at the camera in the front. 1, 2, 3. Big smile. Fantastic. Another big round of applause for our panelists and also our moderator. Thank you very much. Definitely a perfect way to wrap up today's program. So ladies and gentlemen, this will be all for the Layer 1 and Layer 2 forum. And the end of the program at the main stage. A big thank you to all the speakers for the insightful sharing, and also thank you so much for shedding new light on how we understand the trends and opportunities in Layer 2 and the Web3 industry beyond. I would also like to extend my sincere gratitude towards all audience here today for your great participation. Thank you so much for your interest and support of the Layer 2 Forum hosted by Wanxiang Blockchain Labs and Hashkey Group, organized by W3Me and co-organized by SNZ Capital. We'll be back tomorrow for a more interesting, exciting program. So we look forward to seeing you all tomorrow and have a fantastic evening. See you all soon. Thank you.